Good morning, sir.
Hello.
Sir, good morning, sir.
Good morning.
Sir.
So we can start talk at 9:45, sir, a.m. Exactly.
Yeah, okay. Okay, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Hello.
Hello, sir.
Sir, Dr. Srinivas Raju, sir.
Yes, sir.
Sir, good morning, sir.
So, good morning, sir.
Participants, very good morning, pleasant morning to one and all. This is Dr. A.V.S. Sridhar, HOD Professor, Department of Mechanical Engineering, Narayana Engineering College, Nellore, and also coordinator of this 1-week faculty development program on robotics. On behalf of Department of Mechanical Engineering, Narayana Engineering College, Nellore, it's a great honor for me to invite our today's subject expert, resource person, Dr. S. Srinivasu Raju sir, and also welcome to all the participants for this today's faculty development program, 3 sessions, with the valuable guidance, valuable support given by Aicte Atal Academy, and also valuable cooperation given by our resource persons. We have successfully completed, and also support given by all the participants. We have successfully completed 3 days sessions, and today we are going to start morning session. Topic is intelligent control robots by Dr. S. Srinivasan Raju sir. It's once again, it's an honor for me to introduce our today's resource person, Dr. S. Srinivasan Raju sir. Sir is received his bachelor's degree in electronics instrumentation and control engineering from Sri Venkateswara University, Tirupati in the year 2005, and also received his master's degree in instrumentation engineering from MIT campus, Anna University, Chennai in the year 2010. Sir has received PhD degree in Department of Instrumentation and Control Engineering from National Institute of Technology, Tiruchirappalli in the year 2018. Currently, Sir is working with VR Siddhartha Engineering College, EAE department. He is having totally 8 plus years of experience in the field of teaching and research. He also worked as project associate in ASTEC project sponsored by DIT in the Department of Instrumentation, MIT campus, Chennai from July 2010 to June 2011. He had been awarded the HTRA fellowship from MHRD, Government of India, for his doctoral study. His research interest includes sensor design, energy harvesting, instrumentation, process control, and MEMS. Sir has published 20 plus publication papers in national and international journals, and also attended 15 plus conferences, national and international conferences. in across our country. With the brief introduction, warm welcome you, sir, for today's morning session. The topic is intelligent control. I request all the participants to utilize this good opportunity and gain knowledge in this particular topic. Once again, thank you, sir, for your valuable presence. Warm welcome you, sir. You can start your talk, sir. Thank you.
Thank you, sir. Thank you for nice introduction, sir. I am sharing the screen, sir, now.
Yeah.
Sir, I have shared the screen, sir. Whether it is visible, sir?
Sir, 1.5 minutes, sir.
Okay, sir.
Yes, sir, we are viewing your screen, sir.
Ma'am, I can't able to see, ma'am. I think I don't have co-host settings, ma'am.
Sir, you are the host, sir, now.
Okay, ma'am. Ma'am, now are you able to see the PPT, ma'am? I have shared it.
No, sir, no, sir. Only your screen, sir, desktop screen.
Yeah, once again, ma'am.
Okay, sir.
Now it's okay, ma'am.
Yes, ma'am. Yes, sir.
Yeah. Thank you, sir, for giving this an opportunity to share my knowledge on control systems. Okay. Today I am here myself as Srinivasan Raju. I have done PhD in the area of MEMS-based control systems. So today I am here to give brief introduction about the controllers. Okay. I am going to start with the definition of controller. So how many types of controllers are available? For example, if you see, we have linear control system and non-linear control system. So what are the methods are existing in both the cases? In the case of linear and non-linear, why we are going for intelligent controllers, and how many type of intelligent controllers are available for different type of the process. So I am going to give brief description about these methods, including the principle, and finally I will try to show some examples which solved in the MATLAB. So here I am considering highly nonlinear system to simulate in the MATLAB. I consider conical tank as a high nonlinear system to implement the fuzzy logic and moving robotic arm vehicle. So I try to implement fuzzy PID algorithm for robotic arm, and I have shown the results in the MATLAB. So we'll start the presentation with the basic terms of control system. I think all of you know about this terminology, even though I'm going to spend 5 to 10 minutes about this definition of control system. So while coming to the introduction to control system, first we should know what is the system. So I am saying the system is nothing but collection of components. Okay, so a collection of components or elements which can be affected by any external input. So it has to produce the desired output. The desired output have been set by the user, or we can call it as an expert. We can call it an expert or knowledge engineer. The knowledge engineer will provide the set point to the system. The system has to follow the instructions given by the user. And in the system, nominally we have two types of the system. One is linear, another one is the non-linear. So we have linear and non-linear. So in this case, a linear system. So when I am going to say the system is linear, the output of the system will be varying linearly with respect to the input. Currently, in real-time application, we can't find any system with the qualities of linearity. So all real-time systems are exhibits dynamic in nature. So we are calling it as a dynamic system. Okay, dynamic system meant by it's having the memory. So for example, if we say the response of the dynamic system will vary with respect to the time, and it will be influenced by the output at future also. But in the case of linear system, the output of the linear system will not be influenced by time. So it will be the constant. The output will be always constant irrespective of the input. So we are saying that the control system is interconnection of components. So I am drawing the block diagram here. So this is the block diagram. So control system will have one input Okay, I am considering single input and single output control system. Okay, one input and one output. So what is the meaning of input here? Input, I am calling it as an excitation. I am denoting it as excitation or command which we are applying to the system in order to produce a specific output. The specific output will be decided by the designer. It will be decided by the designer. And the output, how I am calling it as output variable. Output is the but actual response obtained from the control system. So here we have the parameters. So what are the parameters involved in the system? Disturbances. The disturbance may be externally or inherent disturbances. It may be known or unknown disturbances. So with respect to the disturbance, how the system is able to track the input or how the system is able to achieve the desired response. Now here I am saying that the controller input includes the desired values of the process, output variables which we have discussed here. These are the output variables, and we also include the actual values of the process. What is the meaning of actual value of the process? Which has been set by the designer. That value is set, but we are calling it as a set point. We are calling it as a set point, which is designed by the designer. So the main objective of any control system, irrespective of its application, it may be manufacturing, robotics, process, chemical, biomedical, wherever it may be. What is the main objective of the system means it has to track the performance criterion specified by the designer without any obstruction. Without any obstruction means even though in the presence of the known or unknown disturbances. And now we want to see how many type of systems are available in real-time nature. So we already discussed about the static and dynamic. Static means the output is a constant with respect to the time t. Even though the time is varying, the input is varying with time t, the output will be a constant. And dynamic nature. The system is the dynamic nature. So we already discussed that always all real-time systems exhibits the dynamic behavior. So we are now how we are going to represent the dynamic system. So dynamic system can be represented by using differential or difference equation. Differential equation. For example, you can see either d square by dx square. And static systems always we can represent it by using linear algebraic equations. Linear algebraic equations. And next one, we have continuous time and discrete time systems. In control systems, mainly we are focusing on static or dynamic, continuous or discrete, linear or non-linear, time varying and time invariant system. So continuous time means whether the system parameters are varying with respect to time t and described by differential equation. Described by the differential equation. So we are calling it as a continuous time. For example, how we can represent is R of t. So the response of the system will be continuous with respect to the time t. In the case of discrete time system, the same system, the response of the system will be vary at regular intervals of time. So the response will be like this. We can see the response will be like this. So this can be represented with the help of difference equation. Difference equation means u of n minus 2. N minus 2 represents the d square by dt square in time domain. So we have two methods to represent any system, either continuous time or discrete time. So continuous time system is represented by differential equation and discrete time system are represented by the difference equation. Similarly, we have linear and non-linear. So we all know about the linear system which satisfies the principle of superposition theory, and non-linear system. So always we know that the system is non-linear with respect to the nature, right? So what are the equations we can describe the non-linear system? We are using partial differential equation or differential equation to describe the model of the non-linear system. We are utilizing these two methods to describe the model of the non-linear system. So equation describing the non-linear dynamic system, which consists of the one or more number of non-linear terms. So always we are preferring the non-linear. So non-linear. So based upon this linear and non-linear, the controllers is classified into the classical and non-linear controllers. Advanced, classical and advanced. So always the classical control theory can be applicable to the linear system. The classical control theory cannot be applicable to the non-linear system because non-linearity is included in the system, which cannot be eliminated or which cannot be reduced by the effect of linear controller. So further, we are moving to the advanced controller. Advanced controller is what we can say it's a intelligent controller also. Now another one is time varying and time invariant. So we know that time varying dynamic system, this also can be described by difference or differential equation, but the coefficients of these equations are varying with respect to time t. For example, you see t square t by dt square sir. So this terminology will give us very difficult to find out the control solution for this type of the system, time invariant system, because the coefficients of the system model also is varying with respect to time t. So its behavior of the system is not in regular nature. So these also can be described by using partial differential equation or by using the difference equation. So which have only coefficients. So these are the different system classifications considered in the control systems. So next slide. So in this, I am going to give brief description about basic control method. First one is open loop control. So all of us know about the open loop control system, and another one is closed loop control system. These two are basics in the control system. So closed loop control. So first one, what does it mean open loop control system? I am having the process like this. This is the process. Okay, this is the process, and the process output should be maintained at some constant level, which will be designed by the designer. So here I am having the controller. The controller will have the input as set point. Set point. Okay. Sorry, I am writing. I will write once again. So here I am having the controller block. The input to the controller is nothing but set point, and the output of the controller will be given to the process. So which we are calling it as manipulated variable. The manipulated variable can be calling it as an input of process variable. Okay, so this is the basic structure of open loop system, open loop control system. And if you see the structure, I have given, for example, to maintain the tank level at 5 centimeter. Okay, I have designed the controller parameters and provided to the process. Initially, it may be achieve the 5 centimeter response, but even though some disturbances, I have changed set point 5 to 7 centimeters. So this change in the set point cannot be tracked by the controller, even though there is a heavy change at input side, it cannot be tracked by the controller, and it won't have any influences on the process output. So the process output will maintain still at 5 centimeter. So always we can say that open loop systems are stable systems. Open loop systems are stable systems. Why we are saying always a stable system means any disturbances exhibiting inside the process or outside the process. It may be anything. It may be manufacturing industry, or it may be physical or chemical, or it may be process industry or robotics and automation. Always we can say open loop systems are stable system and closed loop systems. So why among this open loop and closed loop systems, always we are preferring the closed loop control system. So these are the blocks which consist of the closed loop system. So first one is design performance. The design performance will be set by the designer. Okay, for example, if I consider the level of the tank, so it should maintain its certain level which has been provided by the designer. So according to this level or set point designed by the designer, he can tune the controller parameters. The output of the controller will be given to the process with the system to be controlled. So here we can use any type of the process. You can use aircraft, missiles, economics, or you can go for car control, or we can go for any robotic arm, or I can go for any underwater vehicle, depth tracking. So the system is I can use anyone as a system here. So based upon application, I'm going to change the controller parameter. So what is the input to the controller? By seeing this one, the process output is feedback to the controller. Okay, here we have the error block. This error which is used to find out the difference between desired response and the process output, and this differential error will be given to the controller. So what is the main objective of here is the system utilizes the feedback technique to compare the actual output with the reference output, okay, in order to track the change in set point. So what is the main objective? The output there should be zero error. The error should be minimized. The error should be minimized. This error can be caused maybe due to some disturbances, or some disturbances at the output side or input side or inside the process. So to make the system output and the desired reference, which can be closed as by minimizing this error. How we can implement the controller? So what are the key issues here? the first key issue is modeling and analysis. So how we can obtain the modeling of the system? For example, I am using a robotic arm system or 3DOF robotic arm. So how I can go get how I will get the 3DOF arm? Mathematical modeling of 3DOF arm. It's highly nonlinear system, right? So this can be modeled. Once after obtaining the model, I am going to design the controller. Which controller I have to choose? Depending upon application. Depending upon application, I am going to choose the controller I place here. So whether I will verify the system is able to track the set point or not. So these are the simple characteristics of the open loop and closed loop system. Now feedback system, this already I have discussed. So what are the benefits of feedback system means? We can reduce the sensitivity to process parameter. So what is the meaning of process parameter? Any disturbances which are caused internally or externally, or we can go for disturbance rejection, or we can provide a precise control of the process at lower cost. And performance and robustness also will be very good in the case of feedback controller as compared to the open loop controller. So what is the drawback of the system is more mathematical knowledge is required to implement the feedback control system, and it may require sometimes large loop gain which cannot be accepted by the any industry person. After that, the system should be stabilized. Once after implementing the controller with respect to the process, okay, it should be stabilized for some time. Okay, this system should work continuously to track the change in the set point. Okay, stabilization also very important parameter in control system after achieving the proper transient and steady state response. So how we are going to find out the stabilizing of system? Based upon the performance indexes. Based upon the performance indexes of the control response, we can say that the system will be stable for some time, or the system will be stable for marginally stable, or completely is an unstable system. So this is the example of open loop control system. Here we are considering the simple example, heating system. I want to maintain the the temperature of airflow at some particular set point. So which can be measured with the help of the temperature sensor. For example, I want to maintain 70 degrees centigrade. So here the input signal, what is the input signal here? I am providing the voltage as an input signal, the voltage as an input signal which gives to the controllable heat source. So the temperature is obtained from the thermocouple. Here we don't have control of the current flowing through the coil. Okay, we don't have the connection with the motor and fan. If I have the feedback, that means the temperature output is connected to the motor and fan. So based upon this error, I am going to control the speed of the fan. Once speed of the fan will be controlled, then I can control the current flowing voltage across the coil. So this will use the desired response. So how we will approximate the system? So always we can approximate any system with respect to first order or second order. All higher order systems can be approximated to either first order or second orders modeling methods. Why we are going to approximate to first order? Because it's a highly nonlinear device. Okay, we are approximating the parameters, the system parameters between the operating regions. Then we obtain the model. It may be linear model or non-linear model. And second one is the closed loop control system. Here I am considering the car control system. Car control system. So what is the main objective of here is to control the direction and speed of the car. If you see here, the desired direction is our objective. The driver can able to see the direction of the travel and actual direction of the travel. So the objective is to control direction and speed of the car. Okay, so what are the output here? Actual direction. So where the car is moving, the car is moving correct direction or wrong. And what about speed of the car? These are the outputs. So what about the controller inputs now? The controller inputs nothing but the road marking and speed signs. Road mark, whether you have to take the U-turn or speed time, any speed breaker is there. So these are all will be acting as a controller inputs. So what is the disturbances here? The disturbances is nothing but the road surface or wind or any obstacles. Okay, what are the possible subsystems means? Car, power steering system. So the driver is a controller here. He is going to control the steering mechanism. So steering mechanism and brakes always utilize the hydraulic amplifiers. For amplifying the force to the brake system or hydraulic amplifiers for amplifying the force of the steering wheel. Okay, he's going to control the steering mechanism, and the automobile is incorporated into the modeling process. From this, we are going to measure the distance and speed or any visual or any tactile. So this is the simple block diagram of the closed loop system. Here we have shown the time response. Okay, the black line shows the desired response of the travel, but the blue line shows the actual direction of the travel by the driver. So who is going to give input to the driver means the error between the desired course of travel and actual response of the car. So here we can say additional feedback is involved here. So what is additional feedback? The feel of steering wheel by the hand. The driver can control the steering and also he can control the brakes. So here the feedback system is familiar version of steering control system and also with the braking system. So this measurement can be obtained easily with the help of visual and tactile feedback. Visual and tactile feedback. So we can conclude that control system always operates in a closed loop sequence within actuators, sensors, and measured outputs. So always we are preferring the sensors and actuators to measure the to obtain the measurement of the parameters. Next, till now we have seen the different type of the system, how we can represent system. We can represent system either in transfer function model or in state space model. What is the meaning of transfer function model means? So transfer function model, simply I can say that it's nothing but ratio of output to the input. Ratio of output to the input. So this is the transfer function. Laplace transform of the input and output to the following relation. So here the main important parameter is we are considering initial conditions are 0. Initial conditions are 0 means the system is in ideal state. Initial conditions is 0, which indicates that the system is in ideal state. And state space model. So why we are going for state space model? The system is in now dynamic state. Actually, all real-time systems are in dynamic in nature. So we are providing importance to the state space model. So how we can represent state space model means x dot equal to ax plus bu and y equal to cx plus du. Here x I am calling it as a state vector and u I am calling it as an input vector, and x of state vector, x is equal to state vector and u input vector. So I am not going in details with respect to mathematics. Just I will give the brief description about the state space. And A I am calling it as a state matrix, B I am calling it as an input matrix, C I am calling it as an output matrix, D and disturbance matrix. So what is the meaning of state variable here? State variable is nothing but the smaller number of linear independent variables. So this is the transfer function g of s equal to y of s divided by u of s, right? So how we will arrive this one? Once we apply the Laplace transform technique to the differential equation, we will get this transfer function. So the differential equation will have some initial values. That initial values depends upon the independent variables. How many independent variables are involved in the system? So this we are calling it as a state variables. And next one is state vector. So what is the meaning of state vector? Which is a collection of state variables. Collection of state variables. So the state variable and state vector can be represented in state space. Okay, and state equation. So these two we are calling it as a state equation. So why I am going to call it as a state equation means these two can be represented in state space and a set of n simultaneous first order differential equation. So if you see here, this is the first order differential equation. Even though the order of the system is fifth order or higher order, we can represent here number of the, so for example, consider order of the system is 5. So we have here 5 number of state variables, x1 dot, x2 dot, x3 dot, and x4 dot, x5 dot. That means each state variable represents the first order differential equation. Okay, so the first order differential equation with respect to independent and dependent parameters of the process. So these can be formed as state equations. And if you see the output equations nothing but algebraic equations, so which gives expressions of the output variables in the form of linear combinations. So output variable, what is the meaning of linear combinations? Output variables with respect to the linear combinations of the input. So this is the output state. So we have seen, so we have two methods to represent the state space, either in transfer function or in state space. So these two methods we are using to represent the model of any system. Okay, and now why I am providing here impulse input? So I want to examine the response of the model before applying the control system. So for that we can use impulse input. We have some standard signals: impulse, step, ramp, parabolic. So these all will be a standard signals which can be used to find out the transient or steady state response of any system. Transient or steady state response. This is not particularly related to the one type of the system. So it can be applicable for all type of real-time applications in nature. Transient or steady state response. So here why I am considering the impulse response. For example, I am considering the simple cantilever beam. So cantilever beam is but one end is fixed end, other one is free end. Other end is free end. So I am going to apply a tip excitation at the top, at tip of the beam. Just I am going to apply the tip excitation. So it will vibrate like this. So it will vibrate the oscillations, and after some times the oscillations will be died out and it will reach the stable position. That means from this vibration, I am going to find out the transient response of this cantilever beam with respect to the input which I have given. The input I am calling it as an impulse input. Okay, it's not a constant, so it's only at some amplitude value at t equal to 0, and remaining time instant the value is 0. So from this the output of the cantilever beam will be like this. So the oscillations will be died out and it will reach the steady state value at some time. So this is the response of the cantilever beam. So from this I am going to find out the rise time, peak time, how much time it is going to take to settle the origin value, steady state value. So all these things I can find out. So if I apply the Laplace transform to the impulse function, we know that Laplace of impulse function will be always equal to 1, and we arrived a very good relationship. So which is the transfer function of the system will be equal to the response of the process. Response of the process, irrespective of any control action. The transfer function will be equal to the response of the process. Once if I apply impulse, if I apply only impulse to the signal. So this is the basic standard signal which we are using to find out the either transient or dynamic response of the any system. Next, so here I have given some properties which I have already discussed earlier slides. So here all initial conditions is 0 for transfer function, and transfer function depend on only on system parameters. It's not depend on independent or dependable parameters. It depends on only system parameters. And the transfer function depends only on the complex variable s and no other variables. So here I can say that the order of the numerator is less than that of the denominator. The transfer function is called strictly proper transfer function. So if the order of the numerator is greater than the denominator, the transfer function is called the improper. So just I have given some properties with respect to the transfer function, and this I have already discussed about the state variable representation. So this is the way we are representing the system. Okay, system describe the state variables, so which have this input vector and output vector. So each state equations can be represented in the form of first order differential equation like this. It's having n number of state variables. That means the order of the system is n. So each state variable can be represented with respect to the first order. So a system is represented in the state space form by the following equation: x dot equal to ax plus bu, y equal to cx plus du. So always we can represent, but here the important point is we can consider the initial conditions. So always all mechanical systems will have some initial conditions, that those systems will not be in ideal state. So we are considering those initial conditions in respect to the state vector, and we are trying to implement any control algorithm only in the case of state space. Sorry. And next one, so this we have already seen the transient response of the first order system. We already discussed whether any model of the system, either mechanical or chemical or process industries or manufacturing industries, we can represent either in the form of first order or second order. Okay, these two we can represent, or we can able to bring back those higher order models into the first order or second order using different methods. So here I am considering simple RC network. So this is the RC network. So I'm having the transfer function as like this 1 by RCS plus 1. So the transient response means, what is the meaning of transient response? Without any response, without any input, how the output will be changing with respect to the initial conditions. With respect to the initial condition, how the response of the system will behave. So that response will be calling it as an transient response. Here the voltage across the capacitor is not zero. So we are considering that voltage across the capacitor is not zero. So based upon this VA input, I am going to arrive the transient response of the system. So this is the block diagram. We can represent the open loop mode. Okay, here we K is a gain. I am calling it as a K value is gain, and tau is a time constant. How I can derive the time constant means the response of the system to reach 0.63% of the input, step input value. That response will be calling it as a time constant. The time taken by the response to reach 0.63, that means 63% of its final value. 63% of its final value, we can calling it as a time constant. So here I am applying R of S equal to 1 by S. So what is the meaning of R of S equal to 1 by S means I am going to apply here step function. Step function, and the controller response will be like this. So this is the controller equation. Okay, this controller equation is in the form of Laplace domain. Laplace domain means I can say it as a frequency domain. I can say it as a frequency domain. So it could be bring back to the time domain by applying inverse Laplace transform. So we can apply inverse Laplace transform. After applying the inverse Laplace transform, we arrive this equation. So if you see here, when t equal to tau, so when t equal to tau, what is the value of this one? This one value will be equal to the 1. So 1 minus 1 will be 0. That means this control response will be 0. Control response will be 0 means there won't be any oscillations. So this is the first order response of the system. Now, till now we have seen how we can represent in the form of the first order and second order. Another important concept is stability. Stability is more important with respect to any type of the application. Okay, so what is the meaning of stability? Blindly I can say that stability is nothing but if I am applying bounded input to the system, the output is also should be bounded. The output also should be bounded. Then I can say default the system is stable system. I can say default is stable system. For example, if we see here, okay, we'll talk example later. Next slide. A stable system is a dynamic system with bounded response to a bounded input. And why we are going for stability characterization? Absolute stability depends upon whether the system is stable, absolute stable, marginally stable, or unstable. So these four characteristics can be depends upon the closed loop feedback system. So we can able to find out the characteristics only for the closed loop feedback system. Only for the closed loop feedback system. Okay, here we have two type of the stable system which we have already seen. First is zero state response. Okay, what is the meaning of zero state response means there won't be any initial conditions exhibits in the system and the response of the system only with respect to the input only. If the response of the system only with respect to the input, that means all initial conditions are zero, then I am calling it as a zero state response. And zero input response. What is the meaning of zero input response means the response of the system only with respect to initial conditions only. That means here we are not providing any input to the system. I am going to find out the response, how my system is going to behave with respect to initial conditions. So which gives information about the transient response. So this gives information about the transient response. Once I know the transient response, I can easily find out the steady state response. So what is the important characteristics to obtain or to analyze stability means the system should have the transient characteristics. So all the inputs are zero. That's why we are saying that the total response of the system, is depends upon the zero state response with the zero input response. So if I combine zero state response with zero input response, so I can say that is the total response of the system, which we can easily find out the stability characteristics from this total response. So the total response is incorporated based upon the zero state response and zero input response. And these are the examples of the stability analysis. So we can see here, the cone is placed on the horizontal plane. This is highly stable system. Even though I am providing the any external disturbances in the form of in this direction, it will be oscillated and come back to the stable position. And this is the neutral. Why I am saying the neutral? Even though I am going to apply any disturbances through this direction, it won't change its position. Okay, it won't change its position. It will be have the same position. And this is a completely unstable system, because if I am applying any small disturbances to this one, it will change its position. That means the output is not bounded. The output is not bounded, and we can say the stable and unstable system. Okay, this stable or unstable system. And this is the main performance of any control system with respect to the any process. So the response should be stable, highly stable system. Okay, once I know this highly stable system, it should be asymptotically stable, and these two are belongs to the stability point of view. And next one is bandwidth. Why the bandwidth of the system should be high? So sufficiently the response will be very fast. Within less time the controller able to respond for our queries. So the response will be fast, and the control should react or respond quickly to the control input. Or sensitivity and robustness. So low sensitivity to noise, and it should reject the external disturbances. And if any modeling errors also, it can be eliminated, and parameter variations. And highly sensitive to control parameters, controller inputs. Some maybe we can see some of the inputs may involve with the disturbances, the known disturbances or unknown disturbances. That also high sensitive to the control inputs, low error. So these are the main or major important points the designer should keep in his mind while designing any control system for any typical process. So the typical process may be anything, but he should have these things in his mind. Then only he can able to go for very good stabilizable controller. He can design the good stabilizable controller. First one is
Hello. Hello, sir. Hello. Srinivasan sir. Hello.
hello sir, my voice is audible.
Sir, now it is audible, sir.
Ma'am, some internet instability is there in my college. Now it's clear, ma'am.
Sir, PPT is not visible, sir. Your voice is
Yeah,
not.
ma'am, now PPT is visible, ma'am.
No, sir.
1 second, ma'am. Continuous and discrete controller. So we can say that maintain the value at an output variable, which is at the design level, and the parameters are variable usually continuous mode in continuous time system. So this continuous mode can be converted into the discrete mode. Why we are going for discrete? That is a different chapter, that we are calling it as a discrete control system. That we are calling it as a discrete control system. So always the algorithm can be implemented in computer science, so the computer will accept only the discrete language, binary language. So all continuous algorithms can be converted into the discrete mode. But if you see, the most of the continuous industrial process will have multiple feedback loops. For example, if you see chemical reaction, temperature, pressure, or position control of gripper at end of the robot arm. So all these have the multiple feedback loop. And now here I am giving about the first one is basic regulatory control. Regulatory control can be calling it as I can call it as a normal feedback loop control. It's normal feedback loop control. So these are the input parameters. So here we are considering multiple inputs to the process, and we will see the output. It will have multiple input and multiple output of the process. From the output, it's going to measure the performance measure. The performance measure is going to give the feedback. The performance measure is going to give feedback and in the form of sensors. Okay, index of the performance will be fed in the controller by the designer. And what are the measured variables? Output variable. Output variable. So the measured variables is measured with the help of the sensor, and that can be divided to the that can be given to the controller. The controller now able to take the corrective action to adjust the input parameters. To adjust the input parameter so that the process can able to track the set point. The process can able to track the set point. So this is the regulatory control. I am saying it is regulatory control or nominal feedback control. So what is the objective here is, so we can maintain the process performance at certain level and within the tolerance band of that level. So mainly how the controller, how the designer is going to implement the parameters of the controller means he is going to keep performance index based upon the performance index of objective. He is going to tune the controller parameters, which can able to achieve the performance index set by the designer, and the output also will be tracked simultaneously. The output also will be tracked the set point without any disturbances. Now feed forward control combining with feedback. Second one is, first one we have seen the feedback controller, and next one is feed forward with the feedback controller. So if you see here, the same process is having a multiple inputs is given to the process, and the output will be multiple outputs which can be measured by the measured variables. Okay, each variable will have the controller, so it sends by the sensors, and the output of sensors give feedback to the controller, and the performance index is given to the controller block and feed forward control elements. So the disturbances is going to act on the process is going to directly to the controller, is going to directly to the control of another controller, feed forward control. That we are calling it as a feed forward. That means it is going to take necessary action on the disturbances before it appears in the process, before it's going to appear on the before it's going to influence on the output of the process. The feed forward control can take necessary action to reject the disturbances. So the disturbances is going to appear on feedback element, and feedback element also will go provide the action to the controller. So the controller now can adjust the input parameters based upon the three values. So what is the three values? Measurement variable, performance indexes, and the response come from the feedback element. So in this we can say one control is a master control, another one is a slave control. Another one is we are calling it as a slave control. This I can call it as a cascade control also. I can call it as a cascade or master slave control, or we can have different terminology with respect to the different application. The performance target level means which is given by the set point. The user have given the set point to the system. So usually combined with the regulator control. So when we are going to use feed forward control, any disturbances is going to be occurred on the process, either input side or output side. So we are going to use the feed forward control to reject the disturbances. And next one is PID control. So we have seen regulatory feed forward. Then we are coming to the linear control system. Here we will see the linear control system. We have two types of the control systems: linear control systems and non-linear control systems. Linear control systems and non-linear control systems. So the linear control systems, most of the industries or most of the researchers, they are using the PID. Proportional, integrate, and derivative controller. So the PID is most popular feedback control algorithm which is used, and we can easily understand this algorithm. And we have n number of methods to tune the PID parameters to obtain the desired response with respect to the different applications. So what is our objective? The dynamic characteristics of the process should be able to track the change in the set point, or what are the set point provided by the designer. So that should be tracked by the tuning parameters. So provided the excitation to the plant. So the PID controller which provides the excitation to the plant, that's nothing but the input of the plant, can be calling it as a controller output. I am calling it as a CO, controller output. So what is a plant here? The system which is going to be controlled. The plant output also same. It looks like nominal ordinary feedback loop. It looks like the ordinary feedback loop. So in this, the controller will change the response. The response of the controller will change the response of a plant with respect to the measurement or set point. So the error is the word R minus PV, process variable. So this, the change in these two will be fed as error and be given to the controller. So the controller will take the necessary action. So here we are using the PID. So PID, almost 70% of the industries are using the PID controller for controlling the process. And in this we have three modes. One is proportional mode, integral mode, and derivative mode. So this is the block diagram of PID controller with respect to the process. So here I am saying Kp is a process proportional gain, and Ka is integral gain, and Kd is a derivative gain. So this is the structure of PID controller. So in the S domain we can represent it like this: U of S equal to Kp plus Ki by S plus Kds into E of S. Actually, if you find out transfer function of this one, if you find the transfer function of this one, we have the order of S squared and denominator order will be S. So this won't be applicable in real time if you want to implement in hardware structure. Any controller can be implemented by using the hardware elements, by using the electronic components. So it's very difficult to implement or to realize this controller in real time, because numerator, the order of the numerator is greater than denominator. So we are going for the modified version of PID controller. There is 2 degrees of PID controller, either position form or velocity form, which available in the literature and also available in the industries. They are using 2 DOI of PID. So in the time domain, I can represent it as like this: Kp, which is nothing but error of t, and integral del, which is going to obtain the integration of error with respect to time t, and derivative of error with respect to the time t. So here we are going to find out the 3 parameters. First one is Kp, another one is Ki, another one is Kd. So these 3 parameters can be identified by using different tuning rules. For example, we have Ziegler-Nicholas tuning rule. Ziegler-Nicholas tuning rule. These are the default tuning rules, can be applicable to almost all of the process. But the desired response cannot be satisfied with these parameters. If I found that these tuning rules by using Ziegler-Nicholas, those desired response of the designer cannot be able to track with the help of these tuning rules. Or we have another one, Cohen-Kuhn method, Lubens method, and like this we have n number of methods to find out the tuning parameters Kp, Ki, Kd, and depending upon the structure, whether it's a first order system with time delay or second order system with time delay, or non-minimum phase system or minimum phase system or delay system. So with respect to different applications or with respect to different structure, we have different tuning rules. So we can use those tuning rules to find out the satisfactory responses from the PID. To find out the satisfactory responses from the PID. So these are the effects. So if I am using proportional controller alone, which reduces the error to disturbances, but still allows the steady state error. So when the controller includes the temperature, when the controller includes only proportional and integral, it will reduce the steady state error. If I am using the only proportional controller, it tries to reduce the error, but the response cannot be tracked by the set point. So error will be there. That error I am calling it as steady state error. So to reduce the steady state error, I am going to introduce another term, integral term. But if I introduce the integral term, it reduces the steady state error, but it increases the overshoot. And settling time also it will be increased. So although and typically at cost, it increases the cost of the dynamic response. And so additionally, we are going to introduce a derivative term. Typically makes the system better controllable. For example, if you see P controller will be used only for level, I can easily control the level of the tank using P alone. So I can go for PI for height. I can go for PI for flow of the tank. how much the input is flowing to the system, and the output of the flow should be regulated at particular level. And when I am going to use a PID, so best example for PID is I can go for temperature control. If I am using the PID for temperature control, I can able to achieve the desired performance. So here I have given different parameters, specifications of the system, and how it is varying with respect to various parameters. For example, if you see the P alone, the rise time will decrease, but it increases the overshoot and it decreases the steady state error. And if I am using PI, so it decreases the rise time and but increases the overshoot. So if I am using the additional D, so which decreases the overshoot and setting time also will be decreased. So normally we are preferring the PID for controlling the any process. So these are the tips of designing a PID controller, so which we already discussed in an earlier slide. Now, so till now we have seen basics of controller, so open loop and closed loop, and how the controller can be evaluated. The performance can be evaluated using stability, and how we will arrive the model of the system. And now we will move to the intelligent controllers. So intelligent controllers, I am calling it as a knowledge-based controller. I am calling it as a knowledge-based controller. So why I am calling it as a knowledge-based controller means the intelligent controller is a controller which used to emulate the important characteristics of human intelligence. Emulate the important characteristics of human intelligence, and we can apply to many applications. So what are those applications mean? We can apply to robotics. The intelligent controllers can be applied to robotics and manufacturing industry and traffic control, automation, communication control. Okay, here the human intelligence is required. It's a basic knowledge to implement the control algorithm for this highly nonlinear process. Highly nonlinear process. So here I can see what is the meaning of knowledge base. Knowledge base is nothing but in the form of set of rules. These set of rules can be available in the system. How the user is going to frame the set of rule means based upon his experience and heuristics and facts and control expertise. So by using these four terminologies, he is going to frame the rule base. Okay, that means here the important and at most point is the designer should know the in and out of the process. The designer of the intelligent controller should know the in and out of the process. And we can say this is not similar to the classical controller. So what is the meaning of classical controller? Which we already discussed in linear controller. PID will be a classical controller. And the main distance between classical controller and intelligent controller is in intelligent controller, the human can perform the task, complex task, without knowing exact mathematical model of the system. So here, exact mathematical model of the system is not required. Exact model of the system. Exact model of the system is not required. But in the classical control, it requires a mathematical model. It requires a mathematical model. It doesn't based upon the human intelligence. But in intelligent model, it depends upon the human intelligence. And what are the disadvantages of the classical method? So it's very difficult to obtain trivial solution for large process. For large process, definitely where human should involve. So those can be solved with the help of the intelligent controllers. Those can be solved with the help of the intelligent controllers. So where we are going to use these intelligent controllers, large scale and complex systems, and where analytical model is difficult. So what is the meaning of analytical model? The mathematical model of the system will be a difficult. And the important input output signal is not available for measurement. That means we are not having any information about the system. We are going to control entire system with the help of the human expertise. There is no mathematics is involved in intelligent controller, and everything is depends upon the how the human having good knowledge about the system. So in this, what are the popular approaches? Adaptive control, model reference adaptive control, optimal control, model predictive control, fuzzy logic, neural network, and fuzzy neural control. So the applications, we can applications in mechatronics. So here I am given application mechatronics. So I can go for speed and position control in the mechatronics, okay, which are alternative to PID controller. I can go for robot trajectory control and obstacle avoidances. I can go for control of appliances such as washing machine, So all these things can be controlled with the help of the intelligent controllers. So first we will see the adaptive control system. So adaptive control system, why we are calling it as adaptive control system means the adaptive control is a controller, okay, which can be able to work over wide range of operating points, or wide range of the operating points. So if you see the structure of, this is the basic block diagram of adaptive control system, one of the intelligent controller. So it is having the two loops. This is the first loop. I will say this is the first loop. First loop is nothing but normal feedback loop, with the plant and controller, and this is the second loop. This is the second loop. So the second loop will have the external parameter as parameter adjustment. Okay, so the other loop is a parameter adjustment. So why we are going for parameter adjustment? The parameter adjustment adjusts the controller parameters with respect to the change in the set point, with respect to the change in the input, and how it can be adjusted. So we are going to incorporated here one algorithm which is used to adjust the controller parameters automatically with respect to the set point change, so this controller is highly non-linear control. So we are calling it as a non-linear control. Why is not called non-linear control? Because the parameters are varying with respect to time t. Now, if I compare with adaptive control with the ordinary feedback control, this is the adaptive control and ordinary feedback control. So, adaptive control will have the mechanism to adjust the control parameters. But in ordinary feedback control, we don't have mechanism to adjust the control parameters in the case of disturbances or any non-linearities in the process. And adaptive control can be suitable for linear and non-linear process. And if you see the ordinary feedback control, it can be applicable only for the linear process. Okay, adaptive control can have any n number of loops, but linear control will have only single loop, and it can be applicable to multi-input, multi-output process. And here it can applicable only for single input and single output process. So this is the basic structure of adaptive control. So these are the adaptive control in time varying environment. Why I am calling it as a time varying environment? Because the time changes, the environment changes over time, and changes have the potential effect on the system performance. For example, you consider supersonic aircraft operates difference in subsonic flight than in the supersonic flight. So for example, you consider where majorly we are using adaptive controller means flight control system. If aircraft is flies, the mass will be gradually reduced with respect to the fuel consumption. So the mass will gradually reduce with respect to the fuel consumption means the parameters are gradually varying. The system parameters are gradually varying. Those system parameters, with respect to those system parameters, the adaptive controller can tune its parameters defaultly by itself, and it will provide the controller response. So we have given slow varying states and fast varying tracks. Adaptive control is a special type of the nonlinear control. We are having the slow variation, slowly varying parameters, and fast varying parameters. So the controller with adjustable parameter and design procedure. So what are the major important points here is, so we can see your identification function. Current value as performance index is determined based upon the measurement of process variables, and decision function. It will try to find out the decision based upon the output variable, then change one or more input parameters, alter some internal functions of the controller, and finally it modifies the system. So finally what I am going to say now is adaptive controller is works only with the time environment network. So among adaptive controller, the first one is model reference adaptive control. So we have seen the application of adaptive controllers where we can use in the design of flight control system, and we can use in robotics, and we can use in process control system, and we can use in the steering control system, or automatic tuning of PID controller. So now we will see one of the adaptive control method which we are calling it as a model reference adaptive control system. MRAS, or I can call it as a direct self-tuning control, or I can call it as a direct adaptive control system. So here also we have two loops. This is a primary loop and secondary loop. So this is a primary loop. Primary loop will have process with the nominal feedback controller, and secondary loop will have extra model and adjustment mechanism. So whatever the performance index designed by the designer or specified by the designer is provided in reference model. So performance index is going to provide it in the reference model. Okay, performance index is going to provide in the reference model, and the reference model will going to direct the controller how the output will be response with respect to the command signal. Okay, so basically it was introduced with the flight control system. It was introduced for the flight control system. Okay, so if we see the second loop controller, second loop is having the adjustment mechanism. Okay, adjustment mechanism. The inputs to the adjustment mechanism is nothing but the response of the model ym and the y and the plant output y. So it's going to find out the error, which is y minus ym, and minimize the error. So based upon the minimization, it's going to find out the controlling parameters theta. So the controller parameters can be updated in the controller. Controlling parameters are updated in the controller. So initially, this MRAS is used to determine the adjustment mechanism which provides the stabilization, which provides the stabilization of the system, and it was developed in the MIT USA Instrumentation Laboratory. So it depends upon the MIT rule. So what is the meaning of MIT rule? So here we can see this is the MIT rule which is used to adjustment the parameter mechanism. So d theta by dt is equal to minus gamma e dou e by dou theta. In this we know error. Error is equal to y minus ym. So it should be minimum. Error equal to y minus ym. It should be minimum. Okay. Next, dou e by dou theta. Dou e by dou theta can be calling it as a sensitivity parameter or sensitivity derivative with respect to parameter theta. So what is theta here? Theta is a controller output, and it's going to find out the change in error or sensitivity of error with respect to the controller parameter. How the error is influenced to adjust the parameter. And next one is gamma. Gamma can be calling it as an adaptation rate. Adaptation rate. So this rule can be depends upon depends upon the based on the application. So the user is going to decide the value. The designer is going to decide the value of gamma, and which has been chosen by the based upon the application. So for example, if gamma is small, and we can use gradient method. Gamma is small, we can use gradient method to solve this MIT rule. Gradient method to solve this MIT rule. Gamma is small. Once I can able to obtain solution of this rule, I can easily find out I can easily go for tuning the controller parameters. If gamma is large, I can go for Lyapunov stability. So Lyapunov introduced his theory, Lyapunov stability theorem. Introduced theory or stability theory for non-linear systems. So we don't have linear stability theorem for non-linear systems. And second case, so we have seen model reference adaptive control, and next one we are going to see model identification adaptive control system. So in this, what is the difference between MRAC and MIAC is recursive parameter estimator. Here we have the recursive parameter estimator, which estimates the plant parameters in online. Which estimates the plant parameters in online. So I can call it as an online parameter estimation. Online estimation of plant parameter. So this is also having two blocks. So you see here, this is the first nominal closed loop block. Okay, nominal feedback block process with the controller, and secondary loop will have the controller design with the recursive parameter estimator. So in this, the recursive parameter estimator estimates the process value. We are providing the controller output simultaneous process to the parameter estimator, and this parameter estimator estimates based upon the inputs and based upon the outputs of the process, and the values given to the controller design. The controller now can able to design the controller tuning parameters based upon the specifications and the input from the recursive parameter estimator block. So in this, we are estimating the plant parameters in online mode. So this and the online parameter estimator block I have shown here. How to estimate the parameters in online mode. So here the basic idea is we are going to implement the adjustable predictor for the plant input and previous planned output measurement. You see here, Q inverse gives the previous Z inverse. In the discrete domain, we are calling it as a Z inverse, which provides the previous planned output. Previous planned output. So I am going to feed simultaneously present input along with the previous planned output. So which is adjust here I am having the mechanism to adjust the parameters of the online parameter estimation mechanism. So which we can call it as a prediction. This method we are calling it as a prediction method of any plan. So the response of the plan y of q can compare with y hat of q. Y hat of q. So the error, once the error is minimized, that can be given to the adaptation mechanism algorithm. So the adaptation mechanism, here we have the online solution. Here we have the online algorithm to find out the plan parameters, or we can use few design parameters also we can use here. So to find out stability of this one, we are using the Lyapunov stability theorem. So this is the way to obtain the parameter estimation by using the online. So another third one is optimal control. So optimal control, we can find applications in many different fields. You can find aerospace, process control, robotics, bioengineering, economics, finance, management services. We can find a number of applications. So here, what is the meaning of optimal? Optimal means I am going to obtain the optimum performance of the system, optimum performance of the system with respect to the performance index based on the error. So with respect to the performance index. Performance index, that is minimize the error or maximize the output or minimize the cost, maximize the profit. I am going to provide the optimization technique or optimization equation in the form of the performance index. So it is also having two loops. One is primary loop, another one is the secondary loop. So secondary loop consists of the state observer. This is the secondary loop. Secondary loop consists of the state observer along with the state estimator. So state estimator estimates the states of the system with respect to find the optimum response or optimum control value in order to provide the in order to satisfy the objective function provided by the designer in the form of performance index. So it estimates the present state. So it estimates the present state, and also it estimates the future states, present state and future state. The state estimator determines the optimal control signal, and which will be given to the controller. So to satisfy the objective function. So what are the methods we are going to use in optimization is linear programming, non-linear, gradient method, and Kalman filter method. These are the basic methods which we are using the optimization algorithm to find out the optimal solution. Another one is predictive control. This is one of the most important advanced control algorithms which we are using in process industries and manufacturing industries. I can say this is a model predictive control is one of the intelligent controller. MPC refers to the class of computer control algorithms is mostly used to predict the future response of the plan. So how it is going to find out the future response of the plan? So the differences between error, we can see here, the process output with the model output. The differences between the error can be predicted by the help of the predictor. So if you see the error can be given to the difference between process outputs and model output can be given to the prediction block. Here we have the prediction horizon. We have the two important characteristics here. One is prediction horizon. Another one is the control horizon. Controller horizon. Prediction horizon and controller horizon. So prediction horizon is used to predict the future value of the output, and the corresponding control horizon will provide how much control effect will be taken by the MPC controller. So we can calculate the controller calculation. So this algorithm can be implemented in discrete mode. This algorithm can be implemented in discrete time mode. So which the controller calculation is involved, the set point calculation and the predicted output The predicted output also will be decided by the controller horizon. So the output of the controller horizon will be given to the process. Here, the important parameter, that means the set points for the control calculations, which we are calling it as a targets. These targets are provided in the form of objective function. Are provided in the form of objective function. These objective functions should be minimized or maximized depending upon the user. Okay. For example, if you see these objective function can be maximized, can be used to maximize the profit function, can be used to maximize the profit, or can be used to minimize the cost of the labor, or can be used to maximize the production rate, or can be used to maximize the or to minimize the labor. So especially we can all these qualities can be incorporated in the objective function. This can be taken care by the controllable horizon. So we can see here the how the MPC will be work for this one, how the NPC can able to track the set point changes. So here we can see the sampling instances k plus, k plus 1, k plus 2, and k plus m minus 1. P indicates the number of prediction horizon, m indicates the controllable horizon. So the actual output y, so I can see this is the set point, this is the actual output. I am going to predict the future output, which I have shown here bubble, in the form of bubble, and actual output I have shown in the form of dotted. So this is going to predict by the controller. So with the help of this control effect. So always the controller effect should be minimum. Always the controller effect should be minimum, and it will track the set point after some some instance of the time. So once it is able to track the set point, the error is minimized. The error is minimized. The controller is able to withstand at its position. The output of the control response will not bring back to the zero. It will be able to withstand at its position and it will maintain the output. It will maintain the error is equal to zero. So how it is going to maintain the error equal to zero? That means it always predicts the same output y hat. So y minus y hat will be always zero. So how many number of prediction horizons is required now? So number of prediction horizons should be more as compared to the control horizon. This is the important constraint in implementing the MPC algorithm. In implementing the MPC algorithm. So number of the prediction horizon is more as compared to the number of the controllable horizon. And next one is expert or knowledge based system. Till now we have seen the intelligent controllers based upon the mathematical knowledge. The user should have the mathematical knowledge, and then only he can able to implement the whatever the algorithms we have discussed till now. And now we'll see the expert and knowledge based algorithm. So this I am calling it as an artificial intelligence based system. I am calling it as a AI based system. So why I am calling it as a AI based system means it depends upon the human. The human can involve, or the expert can involve, the expert can involve in designing the algorithm. If you see, this is the block diagram. This is a block diagram of the expert or knowledge based system. Okay, here what are the factors that humans should have before designing the controlling parameters? Before designing controlling parameters, he should have information about the facts and experiments. He is going to frame the rules based upon the facts, based upon experiments conducted on the process, and based upon the judgment about the process or uncertainty. So once the user will have all this knowledge to frame this one. So in this case, so this is the basic block diagram of expert or knowledge based system. So if you see here, the inference engine, this is the main important block of the expert knowledge system. The knowledge is extracted from the domain expert by conducting an interviews from the knowledge engineer. So what is the meaning of knowledge base? Knowledge base is nothing but the computer memory and in the form of AI programs. Computer memory in the form of AI programs. So based upon the problem definition, the inference engine is trying to find out the solution or try to find out the knowledge from the knowledge base. Okay, knowledge from the knowledge base. So where the problem is going to provide the inference engine? From this problem definition or external facts and observation. These are going to be acting as inputs to the inference engine. So the knowledge base. Okay, now the explainer should explain why the inference engine selected only the particular solution. Only the particular solution. This solution can be reviewed by the human expert. If the solution is okay, then he is going to provide the same algorithm. If he is not satisfied with the output of the explainer, then he is going to frame the new rules. Then he's going to frame the new rules based upon his knowledge. So what is his knowledge? Facts or experiments or any real information about the process. So here, if you observe here, there is no mathematical involvement. There is no mathematics involved here in this to design any expert or knowledge based system. So this expert system is going to be used to control highly nonlinear systems, which is unable to define the model of the systems using artificial intelligence. So this is, I am saying that this is one of the expert control system. Okay, so the block diagram is shown here, the expert control system. So I am calling it as the expert control system is a combination of PID and expert system. Why I am using PID? The tuning parameters is going to be designed by the expert system. Here, the tuning parameters of the PID controller will not be evaluated by any algorithm. It can be fed with the help of the expert system. So we are combining with the PID and expert. One, this is a human operator. He will say whether the tuning parameters are okay or not. So this is a highly nonlinear process, and which combines the PID controller. So the input to the expert system. So this is the input to the expert system process parameter, which can be predicted. I can say it as predicted, or I can say it as a expected inputs, process inputs. So these process inputs can be further processed by the controller, further processed by the human operator, and he will conclude that the tuning parameters. So to minimize the settling time or zero steady state error, minimize settling time or zero steady state error. So these are the simple block diagram of the expert system. So here this is the nominal feedback loop. If we see here, this is the nominal feedback loop with the process along with the controller. Okay, the controller tuning parameters is going to be derived from the expert system. This expert system is based upon work on the knowledge of the human operator and whatever the information fed to the system. So what information is going to feed here now? Process information. How is going to identify the process? Is going to estimate with the help of online estimator. Online estimator. With the help of online estimator, he will estimate what are the inputs and outputs of the process plan that will be given to the expert system, and it will be given to the controller response. So once the human will say that these tuning rules is okay for this plan or not. If he is unsatisfied, again is going to change the rules. Again is going to change the rules of the system. Again is going to change the rules of the system. Next one and final one is fuzzy logic. So I am going to find out with the fuzzy logic, and I can say fuzzy logic. What is the advantage of fuzzy logic over conventional or classic controller means? It doesn't require any good mathematical model. First we will see the advantages. Advantage of fuzzy as compared to the classical or conventional. It doesn't require any good mathematical model. Good mathematical model. And the control system requires less information. Once the mathematical model is not required, it requires less information of the process. That means it requires the expert. We can easily implement the algorithm. And the rules, fuzzy rules, can be tested individually. We can test the fuzzy rules by individually. So what are the other advantages means? The concept is very easy, and it's easy and flexible for the system. So here I am saying the fuzzy logic. So I am going to derive the fuzzy logic is simply describe computing with words rather than the numbers, or I can say it is a control with sentences rather than the equations. So fuzzy logic is going to deal with the problem have vagueness, uncertainty, or unclear impressions, where we don't have input-output relationship of the model, where we don't have exact mathematical model. There we can easily apply this fuzzy logic. So if you see the fuzzy logic, where I am going to apply process control, I can apply. I can go for the agriculture or robotics, military science, or I can go for any market prediction field also I can apply. Now, if I am seeing fuzzy logic means it is going to converting an linguistic control strategy based upon operator knowledge. So operator knowledge is very important here. Operator knowledge. Operator knowledge, and if you see the advantages, so we can increase the robustness, and fuzzy is rule-based algorithm. Fuzzy is rule-based algorithm, and what are the disadvantages of this means is it's very difficult to implement the fuzzy logic using machine learning. Using machine learning. Why we are incorporating machine learning here means, okay, the response of the fuzzy is difficult. The response of the fuzzy is difficult to predict with the analytical tools. So these are the advantages we have seen already. And now the terminology. So if you see the terminology, first one is linguistic variable. So all the data can be represented. For example, if you see we want to measure the temperature data, so I can represent it in the form of either cold or hot or medium. Okay, we can represent it with the help of words, not with the help of the data. This I am calling it as a linguistic variable. Next one is membership function. Membership function can be called it as a fuzzy set. I can call it as a fuzzy set. So which this is the example of membership function. So the nominal x-axis will have the variable range. This is the x-axis will have the variable range, and this is the y-axis will have the values of the membership function. So always the membership values should be like between 0 and 1, 0, comma 1. Okay, so we have different type of the membership functions of fuzzy sets. It may be triangular, or it may be triangular, trapezoidal, Gaussian, or bell shape, or and S-curve waveforms. Okay, we have different type of the membership functions. So what it depends upon the actual application. Which membership function I have to use, that depends upon the actual application. And for example, the system should need very high control accuracy. So we are providing the Gaussian or S waveform, S curve waveform. And next another terminology is fuzzy sets and operation. Fuzzy sets and operation. So what is the meaning of fuzzy set? All the data should be bring into between this membership level. For example, if you see the temperature of 400 degrees Fahrenheit, I can represent that is 400 degrees Fahrenheit as a low or as a medium or as a high. It depends upon my knowledge about the process. So these membership function, these fuzzy sets can be clearly, we can say that it should be have some boundary, exact boundary. And fuzzification, the process of converting the crisp value. What is the meaning of crisp value means? I can say it is a numerical values to linguistic variables. So I am going to convert the data to the number of words. So what is the word here in the case of temperature? Low, high, medium. Low, high, medium. So I am going to define the temperature between 0 to 40 as a low, and 40 to 80 as a high, medium, and 80 to 100 as a high. So whatever the data available between these things will come into the low set, and the data available between 80 to 100 will be appear in high set, and the data available from 40 to 80 will be appear in the medium set. This process we are calling it as a fuzzification process. Once the rule base is framed, and after implementing the algorithm, I can implement this as a defuzzification process. So this is the block diagram of the fuzzy controller. And before going to the block diagram of fuzzy controller, I want to say about the fuzzy operations. So we are using AND, OR, and NOT. AND is nothing but intersection, or union, NOT functions. NOT is complementary. NOT is a complementary. So we are using AND, OR, NOT. These are can be used as fuzzy operations. So by using these three, AND, OR, NOT, we are going to frame the rules of fuzzy control system. So this is the basic block diagram of fuzzy control system. The fuzzy control system will have the fuzzy controller is nothing but a nominal controller. So this is a process. Instead of controller, here we have the fuzzy controller. The output of the fuzzy controller will be U of t, and the output of the process will be Y of t. So what are the input to the fuzzy controller means? I can give the input is error. What is the meaning of error means? I can say it as a difference between R of t and Y of t, and derivative of error. Error and derivative of error can be fed as input to the system. Here, what is the most important point is the prior knowledge is required. How we are going to get the prior knowledge is required? The prior knowledge is required for the system. The prior knowledge is required for the system. The prior knowledge is required for the system. Ma'am, I'm sorry, my voice is clear, right, ma'am?
Sir, very clear, sir.
Thank you, sir. Thank you, sir. Here, the important point is the user should have the prior knowledge of the system. So, how we are going to get the prior knowledge? We already seen the impulse response of the cantilever beam. For example, I am considering the cantilever beam as a system. So when I am going to excite the system with respect to the impulse response, okay, it will give the oscillations. So it will give the oscillations. That oscillation I will call it as a transient response. So these transient response can be used as prior knowledge to frame the rules of the fuzzy controller. Rules of the fuzzy controller. So the operator or expert should avail about the information about the transient response of any system. So this is the dynamic behavior. I can call it as dynamic behavior of the system. So here I am going to derive various reasons. If we see here, we have A, B, C until L points. So initially my controller response is at 0. Controller response is 0. I am giving set point as 1. For example, I am giving set point as 1. Here my process variable. So E is equal to R minus PV. 1 minus P. So error will be positive. Here in this region error is positive. So once error is positive, it is rising, right? So the rising line, the rising signal will always give the derivative error will be negative. So after reaching the B, still again the dynamic response of the system will be increasing. So here the error will be negative now. The error will be negative, but even though it's rising, the derivative of the error will be negative. So like this, I am going to categorize the different nodes of the points, different nodes from A to L. So from this, I am going to frame the 9 rules, A to L. So if you see here, after C, it's going to fall down. So it's going to fall down means the derivative error will be always positive. So we have the derivative error as positive and error should be negative. Why error should be negative? Set point will be 1, but process variable is more than 1. So error is 1. Error is negative. And after D, if I am seeing after D, so set point is always 1, process variable is less than 1, so error is positive and derivative of error also positive. So like this, I am going to find out, or I am going to have the transient analysis or basic information about the process, or the designer will have the information of the process. So what are the inputs to the system means I can say only error and derivative error, and the output is controller output and planned input. So these are the output and these are the controller output and planned input. So the main blocks of the fuzzy controller is fuzzifier. So we already seen the membership function. So here we are using either triangular or trapezoidal or Gaussian or bell shape. So whatever the data I am having, I am going to derive it in 3 modes: negative, 0 and positive mode. So for negative, I am using the trapezoidal membership function. For 0, I am going using triangular, and for positive, I am using the again trapezoidal membership function. So fuzzifier nothing but fuzzification process. We are calling it as a fuzzification process. That means crisp value going to convert into the number of words. Converted into the number of words, which we are calling it as a fuzzification. So after find out the fuzzification, we are going to find out the inputs. What are the inputs to the system? Error and derivative error. And what is the output of the system? Controller output. So these are the input and output. Then how I am going to frame the rule based upon the linguistic variable. All the input data is going to divide between these 3 linguistic variables: negative, 0 and positive. So after assigning the membership function, I am going for the inference engine. So inference engine, this is the main important block or involves in executing the rules of the system. Okay, here the membership function, we are framing the rules by using if and then statement. If and then statement. We are framing the rules by using if and then statement. The designer or the expert of this domain, the domain expert, will frame these rules based upon the linguistic variable. So how many linguistic variables we have here now means we have 3 linguistic variables. So we can frame the rules maximum up to 9. I can limit the rules to 3. I can limit the rules to 6, or I can limit the rules to 9. So depending upon my desired specifications. And these are the knowledge based rules. For example, if you see rule number 1, if error is positive and derivative error is 0, so my control output should be positive because error is positive and it should have some positive response. So what are the reference point of dynamic response? These are the reference points of my dynamic response. So these going to be used to help the controller to evaluate tuning parameter by using this rule. And the next rule, if error is negative and derivative error is, if error is 0 and derivative error is negative, error is 0, that means there should not be any control error. I can say the control output should be negative. because it should not increase. The control output should be decreased. So what are the reference point means? This will be the reference point for controller output. And similarly, we have error is negative, derivative error is 0, and error is negative. Control output should be negative. When the both controller error and derivative error is 0, then the controller output is 0. That is, we are calling it as a set point. So like this, we are feeding the n number of rules. So how we are going to frame these rules? I already told you, it depends upon the expert domain knowledge. For example, I am not, for example, these rules cannot provide the design specification which I want now. So then what I will do now, I am going to change these rules. I am going to change the rules. If error is positive and the derivative error also positive, the control output should be negative. The control output should be negative. Or if error is positive, derivative error is 0, the control output is negative. So I am going to change the rules like this until to achieve the desired response. So like this, we can frame the rules. If error E is positive and derivative error is 0, then the controller output is positive. So like this, we are framing the rules. So once after framing the rule base, it comes to the defuzzification block. So defuzzification blocks means successfully we completed the implementation of controller, and the response of the controller will be given to the system. So how the response of the controller will be given to the system is with the help of the defuzzification block. So we are going to convert the linguistic variables into the crisp values. Crisp values are numerical values which are accepted by the real-time system. All linguistic variables cannot be accepted by the real-time system. So we are going to convert linguistic variable into the crisp values by the real-time system. So the defuzzification process is used to convert the linguistic form of the conclusion. So what are the methods are used to convert into the linguistic used to convert from linguistic variable to the crisp value means center of gravity approach. So we are using center of gravity approach. This is the method we are using to convert into fuzzification into the numeric values. So until now, we have given some concepts about the intelligent control algorithms. So I have considered the direction control of robotic vehicle. So just I am shown the results. These are the results of P proportional controller and PI controller response, PID, and application of PID control I have given. So final stage. This is the final stage. Control system performance should be like this, as we don't have time to discuss much. And here I implemented the same model reference adaptive control for the robotic arm in MATLAB Simulink. So I can able to track the set point which I have given here. The solid line shows the set point and dashed line is shown the our controller response. So this is the roadmap of the control system. I'm going to conclude with this one. Roadmap of the control system. So linearized and non-linear. We have the linear system and non-linear system. Non-linear system should be linearized. Once linearized, we are applying linear differential algorithms. If it is not linearized, then you can go for the non-linear techniques to obtain the time domain response. So linear differential equation means you can apply the transfer function, or you can go for the frequency domain. So from this, you are going to find out the response analysis. And once we have the responses of the system, then we are going to find out the performance specifications. That means how much of the speed response should be, and stability, what about the error, sensitivity, and the performance analysis. And after knowing all these concepts about the process, then only I can go for the control design. So why I am showing here means, before going for the controller implementation, we should know all this knowledge about the process. Then only I can implement successfully to stabilize any nonlinear process with the help of any intelligent control technique. And these are the books I referred to learn these intelligent controllers. One is digital control of dynamic system. Another one is feedback of dynamic control system. And this is my Google Scholar profile. So I am interested in the controls design and also energy harvesting. My PhD topic is I implemented MEMS-based energy harvesting with the help of controller design, and we propose some sliding board control algorithms for vibration algorithms also. And I am interested to work collaborated with anyone in the area of mechatronics or vibration control or any sensor design or any health monitoring systems, structural health monitoring systems. And thank you for giving this opportunity to HOD sir and principal sir of Narayana Engineering College. Thank you very much, sir. I am and I will take another 5 minutes to show the demonstration of the MATLAB, which I already opened in the system. I think I have I think everybody can able to see the screen, right? So here I am using one nonlinear system. Okay, this I have created a nonlinear system. So this is simple differential equation. For this nonlinear system, I am providing the step input as well as sinusoidal input. So I am going to analyze the response of the system with respect to both sinusoidal and step input. So I am executing this one. Sir, additionally, I will take another 5 minutes, sir. I will complete.
Okay. Yes, sir. Yes, sir.
Thank you, sir. So I executed this one, so we can see the response of this nonlinear with respect to step and sinusoidal. With respect to step and sinusoidal. So here we can see the response only with respect to step will have different characteristics, and the response with respect to sinusoidal will have different characteristics. When I combine the step and sinusoidal, the output almost matches the input response. The response of the nonlinear will be always oscillatory with respect to the both step and sinusoidal. That means it exhibits the nonlinear in the output also with respect to the input response. And this I have tried to show. And next one is I implemented fuzzy logic for control for conical tank. Conical tank is highly nonlinear tank system. So in this, I want to control the level of the system. So I am using here cone function, and this cone function I have called in tank FLC. So we implemented here fuzzy logic, basic fuzzy logic control to achieve the height of the to achieve the set point tracking. Okay, if I run this one, so this is the response of the system. We can see here how the output is going to track. See, even though it's having the oscillation, but it's unable to track the set point change now. See, I have given set point as a 1 now. PLC as a 1, set point as a 1, but it's settled at 0.8. So fuzzy logic, that means I have to change the rule base. And it allows the input will be like this. The input to the inlet flow rate to the control valve, the inlet flow rate to the conical tank will be varying like this. And this is the control action and changing the controller action. So this is not a good controller. Why? We are having oscillations and it is not tracking the set point. So what I have to do now? Again, I have to change the rule base to achieve the response of the system in effective manner. So then I went for the expert PID controller. In expert PID controller, we tune the PID parameters by using the algorithm. So in this case, I am considering the inverter pendulum system. This is also highly nonlinear bull. So this is the transfer function of the inverter pendulum system. So for this inverter pendulum system, we calculated the ordinary feedback loop, ordinary PID controller values by using an existing methods. These ordinary PID values will be updated with the parameters because these inverter pendulum parameters are varying highly nonlinearly. So these parameters are updating here. The controller equation E of K, PID controller, these parameters will be updated and it will provide a satisfactory response. So I executed this one. So we'll see the response. So here we can see the response of the controller. The response of the controller. We can see here. This is the response of the controller. It can able to settle at 0 value. And one more thing is this is the response of the process variable along the set point. So I have given position 1 as a set point. My pendulum will be able to track within oscillations to the set point. This is an expert PID which I have implemented using mathematical knowledge. Now the same inverted pendulum, in this I implemented the fuzzy PID. I used the fuzzy PID algorithm to update the parameters. These are the fuzzy PID rule base. So expert control rules. So I am going to incorporate here different rules based upon the error and change in error. What we have discussed now, and error and change in error, we incorporated here different tuning rules, and we tune the perfect to, that means to minimize the error. So if we see the response of this expert PID with fuzzy based PID, expert PID with fuzzy based PID, here we can see here there is no oscillations in the response of the output. So without any oscillations, it went and stand at the position which I have given in the form of set point. So what is the difference between earlier algorithm and this one means earlier algorithm manually we have given the values. Those manual values can be updated by using the mathematics. By using the mathematics and this one I can update the PID values with the help of the fuzzy logic. So we are using different tuning, different rules we frame to achieve the desired response. So these are the things I want to show to I want to show to you. Uh, so thank you, sir. If any queries, kindly please ask me. I'm ready to try to solve the queries.
Hello. Once again, good morning, sir. Participants, you have any inquiries, any doubts, you can clarify. Hello.
Hello, sir.
Any response from participant side? Any doubts?
No doubts, sir.
Okay, very good. If you are not having any doubts, I also going to share sir email address and details to you. In future, if you are having any doubts, you can directly interact with the Srinivasa Raju sir for our clarification.
Yes, sir. Yes, sir. Yes, sir. I'm ready to help, sir. I'm ready to give the clarification, sir.
Now I'm
Please share your Facebook link also, sir.
Yeah, okay, sir. Yes,
Yeah,
sir.
thank you, sir.
Thank you, sir.
now this is a time to conclude this session, morning session, first session by Dr. S. Srinivasa Raju sir. Sir has talked on the topic robot intelligent control system. During this 1.5 hour session, sir mainly covered introduction to control system and what is system, dynamic system, control system, system classification, feedback control systems, control group components, transfer functions, before stability and relative stability, types of control, regularity control, and PID control system, proportional integral derivative, tips for designing PID control system, intelligent control, adaptive control strategy, optimal control, and also, sir also explained about fuzzy logic and its terminology, block diagram of fuzzy control systems, fuzzy operations, and also sir also explained with some beautiful example by using this MATLAB demonstration, and also sir shown some reference books for further reference. So in this 1.5 hour, participants, I hope would gain some knowledge about control systems of robot. Thank you so much, sir, for your valuable information during this 1.5 hour session. I hope
Thank you, sir. Thank you, sir.
participants, the next section will continue within 1 or 2 minutes by Dr. V. Venugopal Reddy, sir. Topic pick and place mechanism. And also, sir, also very much interested to cover some programming part and by using virtual lab, arc welding by using virtual lab. Sir also very much interested to cover that topic also in coming 1.5 hour section. Once again, thank you so much, sir, Srinivasa Raju sir, for your.
Thank you, sir. Thank you, sir, for giving this opportunity. Thank you, sir.
Thank you so much. Within 1 or 2 minutes, the next session will start. Sir, teacher. సార్ 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 కంక్లూడ్ చేశారు సార్. సార్ మీరు 2-3 minutes రెడీ సార్. మీకు sir, once again, good morning, sir. Dr. Venugopal sir, very good morning and warm welcome to our college and this FTP today's second session, sir. And also welcome to all the participants for this second session, that is from actually 11:30 to 1 o'clock. And already yesterday, sir has covered 2 topics. One is sensors and actuators, and another one is lab session by using teach pennant. And again, today sir is going to cover pick and place mechanism, and also sir very much interested, voluntarily sir very much showing very interest towards to presenting some programming part by using virtual lab, like some arc welding and some practical concept sir is going to be covered in this 1.5 hour section. I hope this session would be very helpful to the faculty as well as student community. Welcome you, sir, again to this second session, sir. Thank you, sir. Thank you and warm welcome. Sir.
Sridhar, is it audible?
Yes, sir. Now it is audible, sir. Now.
Okay. So then we'll start now, okay?
Yes, sir. Yes, sir.
Okay. So the screen is visible for all of you?
Yes, sir. Yes, sir.
Okay. So this is the topic today. So this is a robot program, because in fact I could have told the first this one and I could have told the yesterday's session after that, but surprisingly I see the schedule in a different way.
Sir, excuse me, sir.
Yeah.
The screen not sharing, sir. Not sharing.
Okay. 1 minute. Yeah. Now is it okay?
Robot programming for pick and place applications, sir.
Yeah.
Yes, sir.
In fact, yesterday we had a lab session that could have been started after completion of this topic, in fact.
Okay, sir.
Somehow the program was scheduled like that. So actually I imagine that the robot program is over.
Yeah.
So that was the reason that I put some videos and all. Anyhow, no problem. So yesterday, whatever the comments that what you have seen it, so all the things we are going to explain now, so that we are going to refresh now. So what we will do doing is we'll see what type of commands which are available in a VAL programming. VAL means there is a versatile assembly language. Some people they say that versatile, okay, versatile or variety. Some people they say that versatile. Generally, we are going to call it versatile assembly language programming. And this actually can be used for pick and place as well as the continuous path. But the only thing is difference between pick and place application and continuous path application is pick and place applications almost all commands are same. for whatever the applications are there, pick and place as well as the point-to-point robots. Okay. And for the continuous path, so it is specific to the application. Suppose if we are using some commands of welding, so welding commands are going to be different for continuous path. So spray painting, the commands are going to be different. For any other operations are there. So for each individual specific application, the commands are going to be variable in the continuous path. But in case of a point-to-point as well as the pick and place, the commands are going to be the same in val actually. So fundamentally, the students they'll be getting confusion. Then what is the difference between pick and place and point-to-point? Is it correct? So most of the people they'll be getting a doubt. What is the difference between pick and place application as well as the point-to-point? See, point-to-point, the best example is the drilling operation. Okay, drilling operation. So you'll be taking from one position to the other position. You'll be doing some work there. You'll be doing some work, isn't it? So you are going to move from one point to the other point. So path is not dependent. Okay, whatever the fashion, if you want, you can go. Whether you want to go shortest way or longest way, so whatever the way you want to go from one point to the other point, the path is not dependent. Okay, so wherever, whatever the way that you want to, you can travel from one point to the other point in both the cases. But the only thing is, after reaching the second point, if you are doing some work, that is called the point to point, like a drilling operation. All right, like a spot welding is there. The spot welding, one position to other position you are doing, and you are doing some work there, drilling operation or a welding operation, whatever it may be. But in pick and place, you are going to pick this from one point and you are going to keep it other point. All right, suppose a conveyor, the components are going to reach, and you are going to pick this object, you are going to keep it in a lathe machine or milling machine or whatever is possible, isn't it? So pick and place. So after you are going to pick it and you are going to place it, after placing you are not doing any work. That is only the difference between a point to point and a pick and place. I think continuous path you can understand. So welding operations continuously you are doing it. So path is important there. But here in the pick and place and point to point, path is not important. So there the path is important. When you are doing a spray painting, suppose along certain line of action, you should do the painting. Otherwise, if you are doing irregularly, you won't get, isn't it? So path is important, it's like welding applications, so all these things. All right. So this is how the difference takes place. So what we will do is in a very simple short, we'll try to complete, assuming that you are knowing the fundamentals of trajectory planning and what is the path and trajectory planning. Okay, I think you might have heard about trajectory planning and everything. And little bit we should understand about the obstacle avoidance also. So these are all the things within 5 minutes I will try to cover as if they are knowing about all these things. So, and after that we will go for different types of commands which are available in pick and place as well as the continuous path. And after that, I'll tell you, first we'll take up some examples, and these examples I'll explain. Command by command, I will explain that how it is going to execute and everything. So these commands, 10 solved examples are there, 10 unsolved examples are there. There are total 20 examples are there. So all these 20 examples, what you can do is, you can put it in a virtual lab. There is a virtual lab which is being implemented by Aicte Kharagpur. So this link and everything I'll share you now. I'll show you the link and everything. So here a link, if you want, you can see this link. Yeah, this is the yeah, Aicte Kharagpur. See, this is the Kharagpur link. So this is the mechanics and the robotics lab actually. This is a virtual lab. In the virtual lab, you have VAL actually. This is a versatile assembly language programming VAL. So robot teaching using VAL actually. So mechanics and robotics lab, there is a lab is there in which you have software is being available by means of a lab, VAL. So VAL means the versatile assembly language is the code of it. Okay. So they have used VAL 2 actually, but there are certain companies are there, Staubli. So here there is another company, is Staubli. So this company, they are using VAL 3 actually, 3.0. VAL 3.0. So if you want, you can use this Staubli robotics lab, which is written in a VAL 3 version, or you can go for the Aicte Kharagpur, mechanics in the robotics lab or virtual lab. So those commands, whatever I'm going to explain about these programs, whether it may be solved or unsolved. So first you try to put these solved examples into this, and you see the simulation, everything. Simulation, just you can check it up. So theory also it is there in your lab. That's one advantage. You have beautiful teaching methods. So So some points I have taken from here also. So manual programming, lead through programming, okay, and offline programming. What are the commands which are being available here? List of val commands. So calibration, do ready, do drive. So all these commands. So configuration. So DH notation. So okay, and for a particular DH notation, how your okay, the transformation commands are going to be created here by means of the DH notation. Denote in header notation, isn't it? The final transformation with reference to NSAP, isn't it? So the 6-axis movement. So normal approach and okay, one is towards, one is down, one is x, y, and z axis. Okay, so P is the position. So Px, Py, Pz is the position of the endpoint with reference to the base. So this is the command that the final transformation you are going to get it here. So you see this simulation. So here this is the simulation in fact. So here simulation, if you see this, oh yeah, see you see here this simulation. So here this is the transformation matrix. Based on this transformation matrix, based on this transformation matrix you can create, because these are the positions actually. Positions, these are the locations we are going to call L letter locations. So P means programming commands, L means location. Okay, so this location commands you can change whatever the way you want it, so based on the configuration. So this location coordinates you are going to get it by means of the teach pendant. You are going to take to the virtual point, pick a point, and you are going to record the coordinates, isn't it, of all the joints. And after that you are going to take the robot to the placing point, okay, a dropping point, and you are going to record. So this transformation matrix, location matrix, you are going to get it that way. And here this command, just you can see the right side which are there, yeah, right side. So these commands actually which are there here, which are there, so these commands you try to type it here. Okay, these commands, this is the explanation. If you want, you can understand. So these are the commands you can place it, and after that you can go for a do ready. In the case of do ready, so simulation is going to happen by one it is going to take. So here, so the light color bar is there, light color bar. So here the movement is going to happen here as for the program which is being written. Okay, so the calibration, generally why do you want to calibration means generally initially whether the object is there at the position or not. So generally the component always the robot hands will be on the top actually, home position, things called as home position. If it is there, home position is all right. Somebody is, suppose say the earlier people they have stopped at some other point, so you cannot guarantee that it is there in the home position. So first you have to go for a calibration. Always the robot will be on the top side, calibration point. You have to be there. So generally like a weighing machine. So initially you are going to press it to 0, isn't it? Exactly, let's say you are going to do calibrate. So you are going to ensure that the object is there at a home position. Okay. So this is how you can implement it in a virtual lab. So first you should see, as per our point of view, so what you should do here is you should go for a list of commands first. You should understand. So after that you have to see some programs and everything. All right. So that's what we are doing now. I think all of you are interested, so that's how the these critical points I'm completely omitting, because overall functions to be performed, programming and everything. So here, what is the path and trajectory? Path is the spatial description, and trajectory is the spatial and temporal. Temporal means the time. That's what the space and time is going to be this thing. So path generally you are going to define in terms of two actually, C path and via path. C is the continuous path. So there will be nodes will be there, programming in nodes. That is the target points. So you are going to reach via the target points. You are going to cover you are going to create a path in such a way that you are going to do that. Otherwise, if you are going to draw along the dotted lines to do that straight line motion, you have to stop it there, because robot actually. So if you want to take the turn immediately from there, you have to stop it. You have to move it. So continuously, if you want to move it, so you have to take this along this path. So there is no other go. So that you are going to go towards from the node points or programmed points. All right. Otherwise, what is going to happen along the dotted points? So even the shortest one, if you are going to do that, you have to stop your motion. You have to continue again. You have to stop it again. You have to continue. So the stop and start actually. So the component is going to vibrate. So the one that you are going to carry it for pick and place applications, continuous point. Maybe the welding torch, or maybe the spraying torch, and you are going. It's going to vibrate. It's going to stop it. It continuously should move. Okay. So for this, actually, you are going to create certain curves. Actually, maybe 2-degree curve, 3-degree curve, 4-degree curve. So for all the giants, giant 1, giant 2, giant 4, giant 5, giant 6, for all the giants, curvilinear friction, you are going to get it 5-3-1 principle, 3-1-4 principle. There are so many principles of trajectory planning in there, where I think you might have heard all these things. So there is a way of type is there. Way type is there in case if you want to satisfy both the things. So linearly you can go up to a certain time, and after that, if you want, you can take the curve. So if it is a possible, it is a possible. Okay, if that point is not essential to reach to that point, if you want, you can go very near to that. You can take a turn without stopping the motion of it. So most of the cases, C path is most appropriate as compared to the via path. So via path, in case it's not possible, then you can do it. So trajectory, that's a path actually. So this is a Roosevelt trajectory. So trajectory, how both the time and distance, isn't it? Position and time, because it's a temporal problem. Space and time both are going to realize. Okay, so you are going to draw a curve here. Is taking off, and after that is a constant velocity is going to maintain. So after that is a variable. So distance is variable. Distance is variable means the velocity is constant. Velocity is constant means so after that is going to reach to the set down point. So every arm actually initially is going to take up with a curvilinear, and after that is going to reach to the constant. After that it is going to be decelerated. Okay, first is accelerated with a constant move, and after that decelerated. So how we are going to depict this motion in terms of trajectory planning in a robotic programming is, so here the velocity you are going to move it to the, because they're non-linear, so velocity is going to become a linear. Okay, suppose say x square is the this thing, and dx by dt, isn't it? So that is going to be x now. So that is going to be a linear. Now after that is a variable. Now it is going to become constant. So again it is a decelerated. Velocity is reduced now. Okay. So here acceleration, if we are going to take it, so it is going to become constant. X square is becoming dx by dt, and dx again if you are going to do that x, so it is going to be constant. So here this velocity is going to become 0 along this. Acceleration is going to become 0. Okay. So here again it is going to become a down in the deceleration. This is how you are going to depict the position as well as the time factor in case of this. So this actually giant interpolated motion or spatial interpolated motion, these all the things I'm not going to deal now in the trajectory planning. But only purely we will see how you are going to program a robot. That's very important. Generally, the robot motion is going to be described in terms of 4 variations actually. One is called sequential giant control, and second is called slewing or uncoordinated giant control. The third one is a giant interpolated control and a straight line control. So here, I think all of you might have heard about these 4 type of motions. So sequential giant control means suppose that there are 3 giants are there, 3 links are there. Okay, 3 links are there. So 3 links actually 3 giants. Imagine that there are 3 giants. Why I'm going to specify what giant means, because the drive you are going to give to the giant. Now 3 giants are there. 3 giants means 4 links will be there. Okay, so 3 giants. So it's sequential giant control motion. In this, what is going to happen is there are 3 giants means 3 motors will be there. Maybe what type of motors? So maybe electrical or whatever. So imaginary electrical motors are there which are fixed for 3 giants. So giant 1 has to rotate for 30 degrees per second. Giant 2 so it has to rotate by 40 degrees per second. Suppose giant 3 has to rotate by 70 degrees per second. So first it will rotate with the first giant will rotate with 30 degrees per second. So during that giant 2 and giant 3 is going to be idle. So after that giant 2 starts with the movement of with 40 degrees per second. So during this giant 1 and giant 3 is going to be idle. So after that giant 1, giant 2 is going to be idle, and after that the motion of giant 3 is going to start. Okay. So sequentially the giant movements are going to happen. Ultimately, by moving all this with 30 degrees or 50 degrees or 70 degrees, you are going to reach to the target position. Okay, so this is called, this is how you are going to operate the program, the sequential giant type of control robot. So in a slewing motion, in a slewing control giant motion, so what you are doing is, so here simultaneously, giant 1 is going to run with 30 degrees of freedom. At the same time, giant 2, giant 3 also with respect to degrees of freedom, 30 degrees, 50 degrees, and second degrees of second. So all the things are going to simultaneously going to happen. So simultaneously is going to happen. Only thing is the last one in the sense which is going to travel to the maximum distance. Maximum degrees means here 70 degrees per second is there. So that is going to take a maximum amount of time. Until that, So you cannot use giant 1 and giant 2. You have to wait until that. There is no other go. So maximum time where whatever is taking that giant. So until that you have to maybe before that giant 1, giant 2 is going to be over. Suppose the giant 1 is 30 degrees, so giant 2 is 50 degrees, and giant 3 is going to rotate by 70 degrees per second. So all the giants, the velocities of the giants are going to be the same. Suppose imagine velocities are going to be the same. That means the drives are going to be the same. Speeds, drive speeds, and the specification, everything. So the last one, which is going to rotate 70 degrees, so it is taking maximum amount of time. Even though giant 1, giant 2 has been finished early, you have to wait so up to giant 3 so that you are going to reach to the end position. So in the case of C, giant interpolated motion, what they are doing here is, so imagine that the giant 3 is taking more amount of time. So in case of slewing motion, during the operation of giant 3, before that, giant 1 and giant 2 are completed, but you are unable to reach to the target position. Isn't it? So Parigiti, that means Parigiti Paul the slow bottom better. That's what I think you might have heard about that, isn't it? So exactly similar to that. Before, see, even though you are reached to the final, before you reach to the final position, but completion of the giant 1 and giant 2 in slowing motion is not useful. That's what you can say. It's the maximum speed you are going to move, the maximum speed. So in a giant interpolated, what you are doing is by keeping the third motion means which is taking the maximum amount of time. Suppose say for 70 degrees per second, it is taking about 10 minutes, 10 seconds at a time, suppose say. With reference to 10 seconds of time, so giant 1 and giant 2, instead of moving with the maximum velocity, you are going to slow down the velocity of giant 1 and giant 2 so that so giant 1 and giant 2 is also going to be completed within 10 seconds of the time of the third giant. I think you got my point actually. In giant interpolated motion, you are going to slow down the motions of giant 1 and giant 2 so that ultimately you are going to complete by the time you are going to complete the giant 3. Otherwise, what is going to happen if you are going to move with the maximum velocity? So wear and tear is going to happen unnecessarily. So there is no point in doing that. Okay, so that's the giant interpolated motion. You are going to program in such a way that so all the giants are going to be completed with the maximum amount of time, so that it is going to reach to this thing, so that you can save the wear and tear of giant 1 and giant 2. All right, so that's what the drawback of the slowing motion, and the giant interpolation is the best. So straight line motion, I'll explain this straight line motion. There's some examples actually when it comes to that point. So I'll explain about the B point later. Okay, so here these are the explanations I given complete. So these are the examples also I given this slow motion and everything. I think you can go through these examples. So in case the giant speed, so giant 1, giant 2, giant 3 are going to move the same speed actually. That is the example 1. Example 2. So there is a variation of speeds will be there. Different giants will be moved with the different velocities. All right. So if that is the case, how to deal this problem? That's what we are saying. Problem 1 and problem 2. Just you can go through that. If the time is there, I could explain, but the only thing is, otherwise I have to sacrifice your programming. That's what we will do that. Okay, so try to go through these examples and everything. I'll be sharing your PPTs and everything to through your head of department. Now, obstacle avoidance. So, in case of obstacle avoidance, so generally, when you are going to program this robot, you must see that the wrist actually maybe end effector will not touch the obstacles. Okay. You have to program in such a way that is external environment actually, but still you should have a knowledge about it. This is a Lozano and Perich. These two people actually they have proposed the three types of obstacle avoidance algorithms actually. So first algorithm is a hypothesis and test. Second is called penalty function. The third is called explicit free surface. I think all of you are knowing about this. Okay, hypothesis and test means virtually you are going to teach by moving this hand by hand so that you are going to avoid this and you are going to record it and you are going to play it back. That's what teach by exactly similar to the error and correction, do and error. So that means find the error and correct it. This is called hypothesis and test. Second is called penalty function. In case of penalties, the hypothesis test generally is going to be useful when there are 1 or 2 obstacles are there in your path. If there are more than 2 or 3 applications of obstacles are there, then you can go for either the penalty method or the free space method. Okay, so this is the way that you are going for next higher version penalty function. Generally, this is a concept of optimization principle. So you are going to create an objective function here. This is the rotary motion, and this is called linear motion actually. So here, what you are doing is, if I am going to take my arm very near to the object, this is a hatch line is the object actually, the obstacle. If I'm going to go very near to that, it's almost, you can say, touching means almost infinity. If I go very far away means the penalty value is very low, 100. If I'm going to go very near to that, if I'm going to touch this, the penalty is going to be infinity. If I know that I'm going to touch it, so what is going to happen is the path is going to be very short, but only penalty is going to be very infinite. Penalty is going to become very infinite. Okay. So what I'm doing is I'm going to move my hand in such a way that I'm going to take a very optimization of the distance as well as the near to that. I should not touch very near to that. At the same time, the path should be very minimal. So in such a way, compromisingly, I'm going to create an objective function. See here, this example, if I'm going to take near to this object, actually, is going to reach very shortest, but the penalty is going to be infinite. Penalty is going to be infinite. So what I am doing is I am going to move from here to here, from here to here. Okay. So what I am doing is I am going to avoid this obstacle avoidance without touching it. I am going to change my path and I am going to do that. So I am going to sacrifice the time, distance as well as the penalty value. Penalty is optimum. At the same time, distance is also optimum. So this is how you are going to create objective function in such a way that you are going to optimize the distance as well as the penalty. So this can be used for multiple number of objects. So here, so instead of object creation, what you are doing is here in the explicit free surface algorithm. So you are going to create where the free surface is, the free space is there. So there you have concentrated the obstacles. Here you are not going to concentrate the obstacles. Only the free space you are going to draw. So the hatch lines are the objects. That means obstacles, where the obstacles are there. So remaining free space you are going to create it. So you are going to move this path along the free space so that you are not going to touch the obstacles. Okay. So free space within this your workspace. So free space is going to be drawn, excluding the hatch lines means which are representing the obstacles. Okay. So this is how you are going to program it. I think this introduction part is over. Now straight away we are going to go for a robot programming. So robot programming, it all depends on the three factors. So workspace is very important. Workspace is the space within which you are going to program it. That's very important. So for this, actually, you require the help of a sensor. Okay, so whether it is reaching to the maximum position, the travel length or not, any obstacles are there. So all the things you are going to do that. Internal sensor and external sensors are there. At the same time, so here programming data is also very important, which is going to take care of the sensors as well as the commands and everything. Okay. So robots workspace and which is linked to the sensors, and sensor information also linked to the computer where you are going to program it this thing. Now the methods of programming is one is called mechanical setup. Mechanical setup is very old one. So the screwdrivers setup will be there. You are going to stop it there. You are going to tight it. Again, you are going to move this object, and again you are going to move this. Otherwise, you are going to create a pegs at a point of reference 1, 2, 3, 4, so that you are going to do that. It's very old one, very old one. Okay, so this is second one is called lead programming, lead through programming. Third one is called the offline programming. So lead through programming is also called as online programming, and the other one is called offline programming. The lead through programming, again, there are two types are there: teach by guiding, and the next is called teach by teach box method. So teach by teach box method is called the teach pendant. This is what yesterday we have seen it. Teach by teach box method is called the teach pendant. So these are both are point to point, or maybe pick and place, or maybe the continuous path. Both the versions are being available lead through programming. So in a teach by guiding, okay, so offline programming is just like we're writing a program, right? See, in a lead through programming, when I'm going to teach actually that, so robot cannot be used for work, Okay, in offline actually, so you are writing a programming one side, on the other side, the robot is working for the previous job. So during that, for the next job, I'm going to write a program offline. So as soon as the first job is over, this second job program is going to be run, and I'm going to do that. So there won't be any wastage in offline programming. In case of online programming, lead through programming, that means the robot itself is being used initially for teaching it, with reference to the guiding or maybe the teach pendant. Okay, so the time is going to be wasted for only single time. So multiple times when you are going to repeat this, so time is not going to be wasted. Like a tape recorder is there. So Balasubramanian, what he will do, Gansala, what he will do actually, he is going to play it initially. He is going to record and everything. Okay. So once it is recorded, any number of people they can listen it. So there won't be any restriction at all. Only during that first time only, so instruments are going to be used for recording, isn't it? That's what is similar to that. Lead through program is going to be done. So in the future, what you are doing is, so this is what exactly is happening now. So in future, so this is a given task. Description is going to be given to a robot, and the robot itself is going to configure it. How it is going to do that by means of the machine learning algorithm and everything. So you are going to describe the task, that's all. Okay, so based on the task, it is going to develop the program. So this is the feature that what is going to happen. Okay, so the electro programming as well as the offline programming will do that. So this is called teach by guiding. So we are going to, so there will be man will be there. So actually going to take this end effector from one position to the other position. So pick and place suppose. So initially I'm going to take this actually the to the pick point. So I'm going to record this coordinate. All right. So lead through programming. Okay, lead through programming, and after that I'm going to pull from here to here there. So whatever the safest region is there, the safest path is there, I'm going to take it. I'm going to stop it there at a drop point, and again I'm going to record it. So pickup point is recorded, place point is recorded. So after that, for a specific application, you keep the object there. I'm going to repeat it, and it is going to pick this object and it's going to place that so dumping point. Okay, so this is how repetitionally it is going to happen. Whether it is whatever the application, point-to-point application, link application, or pick and place application. So this is going to happen the same thing. So instead of pulling by manually, so if the robot is small one, you can do this actions. If the robot is very big, so I cannot pull that end effector or arms and everything, because I have to pull this entire all 6 degrees of freedom, everything. Isn't it? So heavy robot is not possible. So for that actually, so these are the disadvantages. So for this we require the teach pendant. So teach pendant actually is a cord wire will be there, which is connected to the control box. So here there will be a, you are going to write a move. Okay, you are going to approach. So you are going to give the command. So exactly these commands are going to be sent to the servo controllers. Servo controllers. Okay, so generally servo controllers should be there. If you want to implement the teach pendant, servo controllers should be there. Without servo controller, you cannot do it. That's very simple logic. But in the manual guiding, non-servo controllers also you can do it. So there is no, because so here is not listening to your voice, isn't it? So naturally, non-servo motors are viable for the previous one, but for this teach pendant, you require the servo motor in order to implement this teach pendant controls and everything. All right. So here, so this is the difference between these things. This can be used for heavy robot actually, because if you want to move this entire robot means the end effector is if you want to move it, so you have to move entire robot, isn't it? So that's how servo controlled teach pendant systems are being used for that. Okay. Now the disadvantage of teach pendant, you can see that. And offline programming like val programming and everything, these are the commands actually, like you are using ADA programming, C programming, Python. There are so many graphic user interface languages are being used. Okay, and yeah, present situation, what are the robots are being used? So these are the types of language they are using it. MH1, Wave, Val, PAL, Rail, Help, JAWS, RPL, MCL. Okay, so here there is a, these are the different commands. Even ADA also is being used. See, MH1 actually, this is the first one which was introduced in 1960s by MIT. Okay, so by seeing the progress of this, Wave actually, this is the language which is invented by Stanford University. Stanford University. Okay, this is called the competition. That's what happened in between the perfect competition between MIT and Stanford. Everybody says that MIT and Stanford are rivals, because these two universities have become rival in developing the robots actually, programming. This is how rivalries happen, and progressively, independently, these two have become this thing, and the perfect competitions happen. Perfect competition happen between these two institutions actually. Because of this only, independently, these two institutions have been grown to the level that no other institutions have become very parallel to this actually. Now everybody say that I want to get admission in MIT, I want to get in Harvard. It's because the competition that was held between these two in terms of development of the robot actually, that's only the reason. There is no other reason that. So here only thing is some people like Paul is there. Paul actually, so this man actually he developed the wave actually. After that he developed the IAL, and after that he developed VAL actually. So this man actually has pulled by Purdue University. This man was pulled and joined in Purdue University, and after that he developed the VAL, RAL, and along with some Sheen man was there actually. Along with the Sheen man and Paul, these two people, they have developed VAL, PAL, these are rail, so all these sequences, they are the RPL and everything, and MCL, these languages. So this is the introduction for this ADA. Actually, for the electronic part they are using, so ADA programming is also being used. So VAL is very popular for Puma robots actually. Puma robots, okay, which are being developed in Japan actually. So Puma and Cincinnati and Unimation. Cincinnati, Puma, and Unimation. For these three robots, VAL is being used. VAL means the assembly language. Okay, this is called assembly language, versatile assembly language. This is used for any three types of robots. Yeah, after the simultaneously, they are being used for most of the robots. So here, after this, what you are doing is, because these are the list of commands. So the list of commands, instead of putting in terms of PPT, so I'm going to explain about the running matter only. So here the who has developed, when it is developed MH1, so all these things have been given in the notes actually, where who has developed. Okay, this is Stanford University in 1970 to 75, it has been developed. So these are the advantages. So assembly language is developed by the Stanford University in 1974. So here PLA actually the arc welding programming language for particularly specific to this one. And what are the disadvantages of this? So AML is their manufacturing language, AML. So IBM has entered after this. So first is MIT, second is this thing. The company has been entered after this. It's a very funny thing actually. So that companies once they enter means they will see the end. That's all. Companies. So that's how the improvement has been started. The academic as well as the industries. So side by side the development is happened. So this is how IBM actually, I think you might have heard about why big elements should not dance. Okay, that was the movie, the novel is there, isn't it? So IBM has become very competitive in earlier stage. After this, by 1995, the IBM has become almost dead position. IBM. Okay, so that's how one guy who has become headed to this IBM, he converted again. Now he made that very successful, because early IBM was making only the computers only boxes they used to make, but they don't have software knowledge. Okay, software they used to buy from others, so Microsoft and everything. So hardware they cannot do anything without the software support, isn't it? They used to buy the high amount of from the software industries, and they are not in a position to tolerate, isn't it? They are not unable to match their hardware compared with the software, because software is costly. So after that, the man who has taken the IBM company, and he developed the software. So he made his own software. So anyhow, they are very strong in hardware and everything. So after that, the cost has become viable. So that's how you might have seen one Naval actually, the same, who converted that industry during 90s. He has written one book actually, why big elephants cannot dance. Generally, elephants cannot dance. I know that. Everybody knows that. And he proved that the elements also can dance. Why elements can't dance? That's what the novel he has written. Okay, so this is how IBM entered in a very early stage to become a competitor to the academic field. Okay, so these are the Pascal also is being used for certain not implement certain integers actually, like a count to integers. So all the things. So Paul actually, Richard Paul is there. Richard Paul, Paul. So this man early was there in Stanford University. After that, he has been entered into Purdue University actually. So this has been developed when he was there in Purdue University. Okay, MCL language, McDonald actually implemented for Cincinnati robots. So Rail, there's another one company. So RPL actually is being developed. After this Stanford Research Institute, there is one separate organization has been developed actually during 1970s. So this is called SRI. This SRI is very popular word, Stanford Research Institute. Okay, so ADA also is being used, and VAL, which has been very popular, It's based on the basic concept, basic language concept. During 1975, Victor Sheenman along with that Paul. Okay, these two, they have developed this. And here, programming instructions. Now we'll see the programming instruction. I think we have completed the part of it. Now, see, program instructions are a robot configuration. So this is for both pick and place as well as the continuous path. So while programming commands are there. So first we'll see pick and place robot. Point to point or pick and place. So there is a difference also. I told you about this. So here there are two types of commands are there: programming commands and monitor commands. Okay. Monitor means how you are going to store it, how you are going to track it, how you are going to locate the programming, how you are going to locate the locations. So programming means the program that what you are written. Location L means P means programming. L means location. Location means sense the commands. Commands that means the program the joint locations. So locations is being called as okay. So this is how the monitor commands that depends upon. But most of the important is the program commands. Programming commands are divided into 6 or 7 divisions. So one by one we'll see. Robot configuration. Robot configuration. Imagine suppose that you are doing some spot welding work. So spot welding, if you want to take it, whether I can configure it like this or I can configuration like this. If I give a command above means it is going to configure like this. So if I say that configure below means it is going to configure like this. So this is the configuration configurator. Because for the same position, two options are being available. If two options are there, I have to give the configuration. Otherwise, it is say that I have to go to this point means how I am going to go, whether above position or below position I have to specify. If any choices are being available. So here motion control. Motion control are like a move command is there. Move yes. So what is this move and move yes means? Move some specific location. Move P1. Move P1 means I'm going to move the location P1. So move S means I'm going to move straight. Okay. If I'm going to move straight means so whatever the end effector position is there, I'm going to move along with that. Okay. So once if we are going to locate this end effector correct location, after that if you are going to give move straight means that will always better. Otherwise, if you don't know the position of this end effector, you try to update move command. Move to a specific location or move straight to a specific location. Next is draw. Draw means you are going to move along the XYZ axis. So also is also move command, but only thing is there move specific point, move P1. But here I am going to say move 0030. You move 0030 means along Z axis. So 30 mm distance you can move. That's what you can say. Draw 10, 20, 30 means move to a distance of 10 mm along x axis, 20 mm along y axis, or 30 mm along the z axis. That's what the difference between move and draw. So here approach actually appro and appro S is there. So exactly similar to the appro means so generally APPRO and 10 mm if I say. So there is a specific location is there. Imagine that P1 point is there. So if I'm going to approach to the P1 point, and I'm going to stay at 10 mm offline, 10 mm offline along Z axis. I'm going to approach along the Z axis only, along the Z axis. All right. So generally, the final position of I want to take the end effector. So this command is being used. So I'm going to approach with the offset of 10 mm. The offset of 10 mm means I'm going to approach the object just above that 10 mm. 10 mm. This is offset by 10 mm. So after that, I'm going to move it. So why I'm going to take it is directly if I'm going to take my hand near to the object, I'm going to strike it. So first I'm going to align just 10 mm or 15 mm or 20 mm above that, and after that I'm going to move or I'm going to draw it. Yeah. So whatever the options if you want, you can take it. So when I'm going to take it above again, so this is called depart. Depart. So approach is coming to downside along Z axis. So there is a minus Z. So again, if I'm going to take it top side, again it's going to be the Z. So 00 minus 30. Appro 00, suppose say appro minus 30 means I'm going to, so appro 10. Appro 10 means I'm going to approach to the specific point of this 10 mm away. And again, I'm going to depart it. So appro and depart. Okay, one is minus axis, the other one is the positive axis. So along Z axis only the movement is going to happen. So for a final one, when I want to take the grasp the object actually. So this command is going to be useful. So here appro S and depart S. So this is straight line motion. That's going to happen. There's only the difference between appro and appro S and depart S. And the circle. So the movement along this circle movement, like 3 axis, 3 points is there, so you are going to move it. So our circle is also moving a command only, but only thing is for this you have to specify 3 point of reference, P1, P2, P3. If I am going to give circle means if I say that is going to move along the circle. Circle is also command. It's not a geometrical description. Always try to remember, because in case of Aicte language in a CNC motion, so circle is a descriptive matter, but here is the circle is a motion command. That's only the difference. One example we'll see. Generally, we are going to use it in a continuous path motion circle. In a welding, actually, we'll see that circular motion. So linear motion, move as, draw, approach, depart, approach. So all the things are linear, and a circle is going to be the curvilinear. So hand control. So hand is the end effector. So you have a open close. So open gripper and close the gripper. And open eye and close eye. If I say that open immediately and close the eye means close immediately. So if I say close eye immediately 75 means so you are going to close this until it is going to become a 75 mm. You are going to close it. If I say close immediately means it is going to close to the value of 0. If I say close eye 75 means you are going to close it until the gap distance between two fingers is going to become a 75. 75. That's the difference between close eye and 75. So close means I'm going to close it. I'm going to close it with a specified amount of suppose say 10 mm and something. Close eye means immediately is going to close it to 0 value. If I say close eye 75 means until 75 mm it is going to be closed to that value. So there is a grasp is there. There is a command. Grasp command is also exactly similar to the close command. But here grasp 20,15 if I am going to give it here, so up to 20 mm gap is there. Suppose between two fingers up to 20 mm gap is there, then I am going to execute the command of 15. This is subroutine command. Subroutine command. That means suppose if it is calling that grasp means the gap between two fingers is more than 20 means it is going to execute it. It is going to pick the object. If it is less than this 20 mm, because two sensors are there, opposite two sensors. That's what touch sensors I told you. No? So between the fingers, actually, finger 1, finger 2, there will be sensors will be there. The sensors actually is going to see whether the gap is there 20 mm or not. If it is a 20 mm is there, it is going to go to that and it is going to pick it. If it is less than 20 mm, so you are going to write some prompt command. Prompt command. So gap is less than 20 mm. So that 20 mm means there is the size of the object. Size of the object. Okay. If it is less than the size of the object, you cannot grasp the component. This is the logic behind this grasp command and close eye command. So grasp 2015 means so if the gap is less than 20 means the 15 sub command I'm going to go to that. So sub command means you are going to write something stop motion, or you can do execute something, or you can do error correction. So all the things we are going to do it. So this is the difference between grasp and close command. So move part 20. So move part means location. Move to that point, point 1. Move point 1 30 mm. Okay. And until you are going to that means you are going to move to the P1 position. Move means move straight to a point of P1 and until the gripper position is changed to 30 mm. 30 mm. That means the gripper between two fingers distance is 30 mm. So move P1 via P2. Via P2 means you are going to move to the P1 via P2 point. That's what we have seen it in the via path this thing. So move P1 to 10 mm distance. Okay. So next is the location assignment modification. So set and here. This set and here, these two are the location assignment and modification. These two I'll tell you with an example. That's always better, because set and here, these are the two standard commands. So for every programming you will be using actually. Set 1, set 2, set 3, you are going to do that. So we'll see that in a program how you are going to use this location assignment and modifications. Okay. And programming control. And here programming control is very important here. So here set I here is very important. Okay. Set I means your integer you are going to do that. Set I is equal to column 1. Okay, like a row 1. So you are going to set an integer value. So type I. Type means whatever you want to type the matter. Type the matter. Type I means integer. Suppose counter 1. Count is equal to 0. So something you want to type it. So that type matter is going to be typed on the program after execution. After execution, suppose you want to write some matter, like a printf statement is there. So type I is the printf statement. But type I, if I write it, only integer values are going to be typed. If I write a type means anything can be written. That's only the difference between type and type I. Exactly, set and set I is the same thing. So set I, if I say that integer you are going to set it. So count is equal to count 0. That's what, but that will not be displayed on the after execution. Set I, but type I is going to be visible for you after the execution. That's the difference between set I and type I. Okay, prompt is the statement like the grasp command you are written there 20, 15. Okay, at 15 branch out. So you are going to write a prompt is equal to, so distance is not okay, distance is a narrow distance, or maybe the whatever the command you want to write it. So the same prompt you can write it. So enter the value or the 1 or 0. If I write enter 1 means I can proceed it, enter 0 means I'm going to stop it. So that's the statement. If you want, you can write it exactly similar to your non-executable statement you will be writing, isn't it? But this is also executable, but only thing is input values, whenever you want to feed it, you can prompt it. So branch out, so if something you want to write something, suppose say, sequentially if you want to run it for 0, 1, 2, 3, 4, multiple to that, instead of looping actually. So continuously if you want, you can run it with a prompt command. Now go to command 20 if you are going to write it. So 20th line, you are going to go directly 20th point and you are going to execute it. Branch out this thing. Suppose say in grasp, like 20, 15 is there. So that 15 command is there. That is the go to command. 15, go to 20, go to 15 means that is 15 value. So this is the go sub means subroutine. Return means say return and end. So difference between return and end means return means you are going to return the configuration, final configuration, the same position. End, if I am going to stop it, so again your end effector is going to be vertically, it is going to be turned off. That's the only the difference between return and you are going to return this with the same configuration of the end effector to the home position. So after that, if I write end means again it is going to be reached to the top position. That means upside. So your end effector is going to be available the end effector. 2 fingers are going to be shown towards the sky, the end position. No? So return position, the home position, whatever it is there, this is going to be returned back. So that's how, in order to see that whether it is the return position or end position, we are going to calibrate it with initially only. Okay. So if logic and then, okay, if logic expression is correct, then you can execute it. Otherwise, then if you want to execute other than that, you can go for if else. So all these commands, so whatever is available in C language, all the things, you can do that. Proceed or pause commands. So these two are being there. First, generally pause if you give it. So after that, if you want to proceed it after a certain command, you can proceed it. Pause and proceed. Suppose generally in a debugging. If you don't want to execute, suppose say known something else. Which is already known to you. So pause those commands in a debugging and everything. After that, after pausing again, you can proceed it. So in between pause and proceed, whatever commands are there, they will not be executed. After proceed again, these are going to be executed. Okay. Next is interlocking commands. So these interlocking commands, whenever you want to use this robot for any other applications. Suppose the conveyor is there. From the conveyor, you want to pick this object and you want to place this object onto the other machine, isn't it? So for certain applications, so whenever you want to interface this robot with other robots or maybe other conveyors, so other companies, other CNC machines and everything. So either before that or maybe after that. Okay. So both the things. Input command generally through the computer, input commands will be there. So generally, if you want to interface this robot with other things, there will be output commands will be there. So here you want to interact with the AGVs, you want to interact with the CNC machines. So all the things are not possible. So for this actually interlock commands are going to be useful. So here is a signal, wait, delay, react, and branch. So these are the 5 commands are there. So generally signal and wait, these two are important. Signal is the output command. So wait is the input command. So generally most of the robots allow 10 lines of output, and 0 to 10 is the output, and 11 to 20 is the input line. So 1 to 10 is the output commands, signal commands, and 11 to 20 is the wait commands. Okay, wait for the input, and for the output is the signal. That means you are going to give a signal through port number 11, suppose say. So port number before 6, suppose say. 6. So signal 6 means through the port 6 you are going to give a signal. That is signal means that is suppose a 6 output is denoted to gripper, suppose say gripper. So you are going to give a command to the gripper, or maybe conveyor command is being attached to the 6, or maybe the camera is being attached to that. So you are going to give a signal to the 7th port, where 7th port which is attached to that. Whichever is attached to that is we are going to give a signal to execute or open it, close it. So whatever the actions are there, observe it. So all the things. Okay. So here 1 to 10 generally you are going to give a signal for the output, and 11 to 20 for input with reference to the wait commands. Delay. Wait means almost you can say that you are going to wait it for some time. Okay, wait it for some time until you are going to do that. Delay is entirely different. So voluntarily you are going to delay it. So for purposefully you are going to wait. So there is a difference between the wait and the delay. So wait, why you want to wait actually? Suppose a gripper you are going to take very near to that. So after that you are going to wait for some time so that you are stabilized. So the system is going to stabilize. After that you are going to wait for 0.5 seconds, suppose say. So after this, throw a command of throw port to some whatever the port is there. So after that you are going to grasp the object. So this is a purposefully you are going to do it. Okay. Delay. So the one delay. So delay means wantedly you want to delay it. Suppose delay some microsecond. So if you want, you can delay it for inspection, checking, verification, everything. Okay, this is non-operational delay, and wait is for the operational. Okay, so these are the signal commands actually. So signal commands, so there are certain variations are there. So signal on and off is there. Maybe signal with reference to signal M with a port number. Okay. Okay, signal 2 minus 3 also is another command is there. So signal 2 is going to be on. So by the same time, signal 3 is going to be off. Minus 3 means signal 3 is going to be off. So 2 means signal 2 is going to be on. So at the same time, signal 3 is going to be off. So simultaneously two ports simultaneously can be controlled with this. So exactly similar to that, wait minus 1 and 2. Wait minus 1 and 2. So wait 1 is going to be off. Second one is going to be on.
Excuse me, sir.
Input signal. Hello?
Sir, excuse me, sir.
Yeah.
Here it is not visible, sir.
Not visible?
It is not visible, sir.
But I am sharing it now.
Sir, you are sharing the PPT, na, sir?
Yeah.
On the wall. Okay, sir.
Is
I
it-
think there is a video, that's why I am asking.
No, it's a PPT. It is a PPT.
Okay, sir. Thank you, sir.
It is visible, sir.
Yeah, it is visible.
Okay, sir.
Okay. So here, exactly similar to that, weight is minus 1 and 2 also you can give. So signal weight actually this is very important. So see here. So here there will be 20 ports will be there. That's what I told you. So 11 to 12, 20 is for weight input, and 1 to 10 is for the signal. So generally, very standard denotation is input output 4 actually. It is to signal the equipment. It is to signal the equipment. It's like fourth one. So generally you want to give a signal for on, off purpose and everything. On and off purpose, generally you are going to take the fourth one. Exactly the 11th one is going to be used for the input signal. 4th and 11th actually. So on and off situations. So for the signal, the signal input and output is going to be given. 5 and 6 is going to be aligned to the end effector. End effector in the sense the gripper, close and open. 5 and 6. 5 and 6 always remember for the output signal for the gripper, close and open. 5 is for close, 6 is for open. So this is 4 in output is going to be meant signal on and off, and the 11th one for input signal on and off. Okay. So in the same way, 5 and 6 is meant for gripper, close and open. So these 4 commands always try to remember whenever you want to write the program. These 4 always should be in this fashion you should do it. So remaining other things is flexible. Whatever you want to do, connection, camera, if you want to give the connection, is the input place or output place, whatever the port, if you want, you can do that. Any other sensors like ultrasonic sensor is there, some other potentiometer is there. So all the sensors, whichever port you want, you can connect it. But only thing is the end effector, there's a gripper. If you want to do that, you have to give connection to the 5th and 6th, so that the close and open positions are going to be realized to that. Okay. So this is the reactor. Indicates the reactions are invoked if the external binary signals are. So here is this is we'll see this actually, this command actually when it is going to be used. And here is a subprogram is a palette. Actually, palette is subprogram. So React we'll see an example. So how you are going to do that? In the theory, if you want to do that, it's quite difficult. But in example, I'll explain about this React and sub palette. That means subprogram palette. That's what I can say. Subprogram subroutine. That's what you are done in a APT language also similar to that. So React I means this is the interruption. This is called generally interruption actually. Why you want to do this interruption is very important. React. So this is what I can understand. Suppose the alignment of the component is not okay. Okay. So that's how if I'm going to take the near to that my end effector, if I want to catch it also, my end effector is going to be damaged because there is a misaligned component is misaligned. So for that point of reference, so you are going to use the reactions. So reaction in sense. So I'm going to stop it there. Almost you can say that. Once unless it is going to be corrected, until that the reaction command is going to execute. Once if I do the correction, and again I'm going to start it. Okay, this is what React component is going to be. Immediately you can stop it, or over certain durations you can stop it. This is what the difference between React and React I. Okay, sub means the subroutine. Subroutine. Palette subroutine. So palette is subroutine, and yeah. So here branch is okay. So here is a delay by so microseconds. I told you that delay 10 means delay 10 microseconds. So wantedly, if you want to do for any measurements of the dimensions and everything, if you want, you can delay it. But usually, if you want, you can delay it. Okay. And branch in the sense subprogramming generally we are going to use a sub branch. Okay. So input and output commands. So they are not that much important actually, input and output command, because that all depends upon the mouse command. Now everybody is using mouse actually, so that's not required. So QWERTY keyboards now they are nobody is using. Okay, all mouse and ordinary keyboards they are using. So monitor commands also to locations actually. So here imagine that here is how you are going to use this command here, this command actually. So here the locations. So we have taken giant 1, giant 2, giant 3, all 6 locations are there. So here part means this part is a position actually, position P1 position. So P1 you are going to designate like this, you are going to store it like this. So whenever you want to retract again, you are going to retract by means of the pointer part is equal to P1. So part is going to be variable, you are going to declare. Part is equal to P1. Part if you want to get the constant, you can keep it. Otherwise, variable if you want, you can declare as a point of part is equal to P1. So P1, P2, P3, P4, after that you can change it. Part is equal to P1, part is equal to part P3, so on so. So if it is a constant, you can write a point P of part. So there is a difference between variable declaration and a constant declaration. I think you might have heard about all these things actually. So here shift command. So here shift command is very important. Suppose I'm going to pick the object at a constant place is okay. If I'm going to change the shifting position from there's one point is there. So next point I want to shift this location from this point to this location. So early my there is one point is there, pick up point at 10, 10, 10. So after that there is another component which is and the another location is there. So this location point I'm going to shift it. Okay. So there are some 10 objects are there along the 3 rows and 2 columns are suppose there. So the shift this constant distance. If anything is maintained along x-axis, 10 centimeters, there are some components are there. Along y-axis, some 20 distance, some points are there. So this shift, I'm going to shift it along x-axis 20 mm, along y-axis 10 mm. So this shifting is quite possible. So instead of giving dimensions independently, shifting if it is uniformity is there, logic is there, so shift command can be used always. Okay, so these are the distances you are going to shift pick by 70 mm. So you are going to transformation pick by shifted to 70 mm x direction and 20 direction. So this is also possible to that. Inversion generally you are going to use for transformation. Inverse means inverse transformation like matrix calculations and everything you are going to use it. Just simple calculations. So frame generally you are going to use it for declaration of base frame A1, A2, A3, or maybe suppose generally 0 point or the brace you are going to take it A1, A2, A3, A2 and A2, A3 transformation frames actually. So transformation frames, so DH notation will come. For exactly similar to that we are declared, but these are the higher versions. So inverse and frame very rarely will be using, but when you are going to use the multiple layers actually. There is one welding example I told you. The multiple layers for inversion and frames are being declared. Otherwise, for two-dimensional up to shift is okay. After that, beyond which is not required. So editing and commands like exactly similar to that. Edit commands you are going to that. Load P and load L means load P means program, load L means locations. Load if you write, so you are going to load both the P and program as well as the locations. That is the difference between these. So copy names, all the things are going to be used. So speed 20 means what is this 20%? You are going to reduce, you are going to use the speed up to 20%. That's very important. Speed 20 means programming control. It's not that numerical value, it's the 20% of the full value. So speed is suppose initially they are going to specify in the problem, you can move the robot by 20 meters per second. So out of 20 meters per second, 20% you are going to use it now. Because whenever you want to pick this object, you can move the faster. So after that component is fixed, picked, then the movement is going to be reduced by 20%, 30%, 40% something. Because the weight is there, so you cannot move the full speed. Okay, your speed if you mention is a full speed, 20%, 20 means the 20% of that you are going to use it. Okay, so whenever you are going to transport it from one position to other location, so again speed is you are trying to reduce 50% to 80%, 20% of this. This is the percentage always try to. So this is the execution of so-and-so commands. So about means you are going to abort the commands. So here, so there is in val2 there is another command is there, drive to 60 and 20. So 60 degrees at the speed of 20 degrees for the motor speed. So joint 2 actually, joint 2. You are going to drive it with a 60 degrees at a speed of 20%. So this is the higher in val2 these commands are being available because individually control joint 2 only want to concentrate. So this command is going to be used for the giant control, specific giant control with the giant percent of speed. Okay. Now continuous, I told you about this continuous path command. So this is the application specific will be there. So till now, whatever we discussed, we have discussed the point-to-point commands and everything, like pick and place apply command. So this is the continuous path commands are specific to the application. That's what I told you initially. Okay. Now what we'll do? Suppose say one example. One example for a continuous path. Suppose you are using for the welding instruction. Suppose that in a welding instruction, let me see the time now. Oh, time is almost over. Yeah. Okay, welding instruction. So welding instruction. Suppose for continuous path. So weld set W set, and here W weaving set. Welding set and welding set, there are two types of commands are there. So how you are going to use it, and W set and WV set. W set is for setting the speed, voltage and control. Generally we will be using it. Setting the speed of the welding gun, isn't it? You are going to set the speed of the gun and the voltage and the current, W set. So there will be three values are going to be given. W set was 20, 30, 40. 20, 30, 20 with reference to 20 is the speed, 30 is the voltage, and 30% is the voltage, and current is some 50%. So that is what we are going to do. Is the W set 10, 50, 60. So that is the explanation is given. And W weaving patterns. Weaving pattern generally we are going to follow straight pattern and triangular pattern, and this is a triangular pattern. Triangularly we are going to move this object. Okay, and trapezoidally I'm going to move. The thick is very heavy, so trapezoidally or triangularly you are going to. So the gap between the component 2 is very much thick weld if you want to have. So I'm going to weave it in a triangular or maybe the trapezoidal movement. If thickness I want to have very low, so I can go straight away. Straight away, if I want to go, so I can give a move command. Okay, go set, move command. So if I want to go, the pattern is the specific pattern, I want to do that. Start. Suppose if I start means I'm going to say start 1 and 2. Start 1 and means W set and 1, and WV set is a 2. So there is a start 1 and 2. If I say start means it's a straight command. So this is how the thickness based on which. So here the WV set is going to be set with the 86103220. So what is the 86? This is thickness width. So all the things you can understand. And here is the triangular weaving pattern is going to be set like this. So 1083030. 108 if they specify only, I'm going to specify only two parameters. So 10 and width and thickness, only two parameters. So remaining other parameters, so intermediate lengths are going to be 0. So 0 is the time factor. So remaining are length factors. So W start is the start one. W start 1 and 2 means the W. I'm going to start welding with the W set is 1 with the speed, velocity, so and so with the weaving pattern. So 1 and 2 pattern. So you're going to set a different pattern. Suppose in the same line of action you want to follow certain things with the length with the straight pattern directly, and with the triangular pattern, the curvilinear pattern, so on so on. So then a curvilinear pattern you can go for directly a circle. There is no problem. Okay, and different patterns are going to be following. Different patterns you are going to declare initially, and that patterns are going to go simultaneously. You are going to WN means welding when you are going to do 0.5 means so you are going to stop it for 0.5 seconds. That's called welding end. Crater fill means generally you are going to crater fill at the end of the welding. Okay, at the end of the welding, because of the arc deflection, which is there very near to the earth actually. So arc deflection is going to happen. So crater fill you are going to use with reference to 0.8 and 3. 0.8 means the circle distance, circle. So you are going to 0.8 distance you are going to do the welding with an amplitude of 3 mm. So this is called crater fill. Generally at the end of the do that, because of the arc deflection you are going to use this crater fill before the W end. Okay, W end. So W end, why you are going to use this command means whenever you want to use the different pattern, weaving pattern, suppose from straight pattern to the circular, circular to the trapezoidal. After the trapezoidal, you are going to come to the other one. So intermediately, if you are going to use it, so you are going to use the W command. You are going to stop for a certain amount of time, and after that, you are going to start with the different this thing. If it is a straight is there, you can use it without any W end. So here is the linear interpolation. This is what I have told you about the linear interpolation. Motion is the fourth motion I told you. First is the sequential joint interpolation, slewing motion. That is the joint interpolation. The fourth one is called the linear interpolation. So this linear interpolation I am going to specify like this. Whenever the Cartesian coordinate system is there. Cartesian coordination means there are two links are there, which is having a Cartesian coordinate system. This is the link 1 and link 2 is having a x and x only. So here you are going to move like this. Suppose say, so there is one robot is there where one is the rotational joint, rotational one, other one is the linear one. Okay. One is rotational, other one is linear. So one is the linear is you are going to draw this, and second is rotational you are going to draw this. So if I want to move this object from point 11 to 66, from here to the 66 combination. So for the A, so 11 to 66 combination. Just you can see this 11 to 66 combination. So I'm going to move like this. So this linear interpolation in this case actually where the giant robot of having one is a rotational, other one is a linear. You are going to do. Suppose imagine that there is a two both are rotational. Both are rotational means you can create a one sphere object. In a sphere, this is going to be sphere. This is going to be seen as a cylindrical actually. It's a plane is a cylindrical, but in a sphere, there are both the axes are going to rotate with the rotational joints. Now, yeah. Now, what we are doing is we'll take it a little bit complicated because these all the things you can understand. It's not a problem. So here, now I'm using a pen actually mounted, and I'm going to write a letters of 2 into S. So I'm going to attach a pen to the end effector. I'm going to write a letters of K and S. So how I'm going to write in terms of valve programming. So using a pen mounted in the robot end effector, and robot to write your first and last initials. Maybe first and last initial is KS, and letter size is 30 mm height. Okay, and like engineering drawing, letter size you are going to specify exactly. So exactly similar to that, you are going to write in a reference to the interlocking commands. So you are going to use the interlocking commands. So only interlocking commands, no other than that. And here, and first you are going to move to the safest position. So safest position is going to be declared. This is in terms of L. Okay, location. So that you are virtually going to do that. You are going to record to the safe position as some position. So that will automatically remove. 6 is the location for output, isn't it? Output means the gripper is open. Gripper is open. So after this, you are going to keep the pen there. So once you keep the pen, so signal is going to be locked and the pen is going to be locked. Okay. So move intermediate location. So intermediate location is from safe location to the intermediate location. Intermediate location generally on the top of the first point. On the top of the first point, intermediate location will be there. And so just to maybe 2 mm or maybe 3 mm above that. And after that, you are going to go to the location 1. So location 1, location 2, all the locations are going to be given as some coordinate points, which are being recorded, which are being located. So okay, so first you are going to go to the location 1. So after that, you are going to drag it up to location 2. And again, you are going to drag back from 2 to 3, and after 3 to 4, it is going to go. From 3 to 4, 4 to 3 again, it is going to come. Okay, 4 to 3 again is going to come. From 3 to 5. Whether if you want to take it again intermediate point, otherwise you can redraw it again. So only thing is while coming also he is going to draw. There's nothing else. Because it is drawn again, it is going to come back. Otherwise, if you don't want to redraw again, you are going to take again to the intermediate position, interposition, and again you are going to take to the third point, again fifth, and again from fifth to the again intermediate location 1. Intermediate location 1 is again on the top of the 6th point, on the 6th point. After that, again you are going to go to the safe position. Again signal 5. Signal 5 is for closing gripper, closing the gripper. Okay. So here move safe again, and after that wait signal. Wait signal means signal command. So signal command until you are going to get, that means you are going to wait for signal 12. I'll say signal. Again signal 6 is a given command. So after that again it is going to go to intermediate location 2. And after that location 6, 7, 8, 9, 10, 11, and so on and so on. So it is going to go. Again it is going to go on top of the second. Again it is going to be the safe position. And again signal is going to be given as a gripper close. 5 is for gripper close always. Okay, so this is the end of the program. So end of the program. Generally, you are going to put a small dots also. If you see the textbook, so these type of comments are being used available in this textbook actually. So this textbook is the SR Dev. I think SR Dev. So this is called the Robotics Automation and Robotic Control by SR Dev. Okay, so this the programs and everything. So I given these examples and everything from here only. So there is nothing to worry about it, because the textbook, if you want, you can download also. Robotics technology and flexible automation. Robotics technology and flexible automation by SR Dev. Okay. So this is a palletizing problem. So in this palletizing problem, just I'll explain to this actually, describe about it first. So in this palletizing problem, just you can see this. So here there is a pickup point is there. So here this is the drop point. So you are going to suppose a conveyor is there. It's along the conveyor. So point is object is going to be available here, and you are going to pick it and you are going to keep it one by one. You are going to keep it. So how much height of this object is there? That much offset you have to create it. Okay, again, this is called to shift this location by 50 mm, so that the second component is going to be in incremental value. You are going to keep it. You are going to keep it in a loop, so that is going to become incremental. So you are going to shift the location along the z-axis. Okay, 0, 0, 50 mm. So along the z-axis means positive 0, 0, 50 mm. So I'm going to shift the location in the same constant position. So that's how I'm going to like the logic of shift position. Okay, at a pickup the drop point. So pickup point shift is not required, because this conveyor fresh components are going to be available again and again. So shift is not required to the pickup point because the component is freshly the component is going to be available in the conveyor, isn't it? So at a drop point, so shifting should be done along the z-axis, because along z-axis we are going to. So the linear way, if you want to go to keep it the one over the next, second, third, horizontally if you want to go to do it horizontally, you are going to shift it along the x-axis. So like 10 mm 0, 0. Okay, 10 mm along the x-axis in a positive direction. Along the z-axis, if you are going to is a minus 10 0, 0, 0. Along the y-axis, if you are going to that's how. So in terms of the shifting is required when you are going to keep that, when you are going to drop it. When you are going to simply you are going to drop it. The chute, suppose in a chute, if you are going to drop the reference to the gravity, so there is no point with reference to shifting and everything. You will not shift it. because ultimately you are going to go near to the chute, and from the chute to the through the gravity it is going to fall down. So when you are going to keep against the gravity of it, against the gravity the top of it, so shift command is to be useful there. So here the robot origin is given at the this point where 0, 0 position at a distance of -40, -40. So this origin point, whether they can give here or maybe the base. So wherever they want to give. That's based on this, the coordinates are going to be given with reference to pick point and drop point, isn't it? So only these 2 points are required: pick point and drop point. So you are going to take this robot virtually from pick point. You are going to record this coordinate. And again, I am going to take very near to this, and I am going to drop the drop point. Okay. So these 2 coordinates are already available to me, and I know this entire environment. And now I am going to write the program. So here, this just you can see this explanation also I given this completely, because this explanation is not there in your SR Dev textbook. For each command and command, the explanation is being given. So there's one thing that I had done it so that for each line command, what is happening is everything you can understand. So all 25 commands are there. All 25 commands for one example completely explained, so that you want next examples that is going to be highly convenient for you. Whether you want to maintain the stack vertically, you want to maintain the stack horizontally along x-axis, along y-axis, or maybe along z-axis. So in what way fashion is possible, that you can do it by yourself. This is the explanation that I given. So remark actually not executable command. So remark, so this is what you can say that the example problem, there are 6 parts are there. So set B the deposit, set A is the pickup pointer, set B is for the deposit pointer. Okay, so set B is the deposit. Why I am going to declare this as a variable means set A is not variable. It's not a variable. Set A is a constant. Set B you are going to declare as a variable, because the deposit actually I am going to shift this position with a distance of 50 mm. That is thickness equal to thickness, so that I am going to put onto the vertical position, stacking position. Otherwise, you need not to declare this a variable, because set A, the say A position, I am not going to declare it as a variable, because set A is a constant. Set B is a variable. That's the reason I'm going to set initially as a this open I means I'm going to open this paper immediately. That's what you can say. So so approach S. So 10 point actually this is the 10 I'm going to give. So whenever I want to use that command again and again, so I'm going to because I'm going to pick this object. Okay. And so this is the pickup point. Pickup point is the A point I told you. No, the same thing. Pickup point is a constant one. So pickup 100 means I'm going to go to the near to the pickup point with a offset of 100. So I'm going to stay. Pickup point is somewhere else. Suppose say 0, 0 point is there. So if I say approach to pickup 100 means so from pickup point along the z-axis there is a 100 mm offset is there. Exactly on the top of this pickup point 0, 0, 0. So with an offset of 100 mm, I'm going to stop my end effector. Okay. So after that, I'm going to give a command of move. So first I'm going to safe side. I'm going to go to the pickup point 100 mm approach, and after that I'm going to move to the pickup point. I'm going to close the object. Okay. Early it was open, and again I'm going to close it immediately. I'm going to pick it, and I'm going to depart again. I'm going to depart again to the 100 mm. The approach and the depart, the difference is approach is a forward along the z-axis. So in the same retraction, if you want to do, you have to depart it straight 100 mm. You are going to go on to the safest position. So again, so after that, what I'm going to do here again, so you are going to approach to the point of B. That means you are going to B means that is a deposition. So I'm going to approach towards the deposition. The same without changing the orientation of this object. All right, without changing the orientation of the object. All right. So I'm going to approach to the point of B, and after that, I'm going to keep it there at the point, goes to the point B. So on the top of B point, deposition point on the 100 mm, I'm going to approach it. So after that, I'm going to move towards the B position. I'm going to open it. So that component is going to be released. At the 15th line, the object is going to be moved to the point location B. So initially, you're going to approach on the 100 mm top of it. Again, you're going to move toward downside, and I'm going to open the gripper so that the component is going to be released. So now, again, I'm going to depart it 100 mm above, because the approach I'm used at 100 mm. I'm moved it, again I'm going to depart it by 100. So approach and depart always don't confuse. Move is going to be this thing, but approach and depart is going to be opposite. All right, approach you are going to, again you have to depart it. These two always should be in the same sequence. Now, yeah, this is the, again I'm going to move to 100 mm safe side. Now I'm going to set the count is equal to count to 1 plus 1. Count 1 plus 1. That means now the second point from the point. Second means the second object I'm going to count it. Second, this thing. Now first is 1 is 0 is over. Now I'm going to the 0 plus 1. Now second component is going to be kept. For the second component, so type integer count, because this is a count is the numerical value. So object is 1, 2, 3, 4. So I'm going to declare the integer value. So remark is whatever it may be. So Q stacking is up to 6, isn't it? So this is if count is equal to 6, then go to the 20. Go to the 20. Always. Up to that, you are going to execute it. Execute. So what are the execution you want to do? You are going to shift this location from 0, 0, 50. Okay. Only that Q stack point you are going to shift it. You got my point? So this is how you are going to shift it one to the other location. Otherwise, you are going to go to the second. You are going to go to the second 10th point. Go to the 10th point. This point 10th point. If you are going to the 10th point, means again for the second point, third, second object, third object, the fourth object, you are going to raise. Once you are reached after 6 objects, count 6, then you are going to go to the 20th. In 20th point, you are going to limit to the speed 50%. Always 50% always means you are going to 50%. You are going to limit to this, and after that you are going to keep it ready. In case ready means the object is ready for next operation. Next operation means again your end effect will be in the seeing the sky. So your end position is going to be seeing under the sky on the top. Okay, this is how you are going to do it. So this is the deposition location and pickup location. So and count 1, 2, 3 up to 6. All right. So these commands and everything is going to be list is going to be given to you. All right. List L. List L means the locations are going to be list. So first one is the list P. List P means the program is going to be listed up to the end point. So before end there is a dot is there. What is the meaning of this? Is the executable statement. If dot is there, is executable. If dot is not there, non-executable. That is only the difference between dot and meaning of the dot in a this thing. All right. So this is the explanation for all the points. The diagram is being given. And if you want to explain with the continue with the along putting this object along x-axis, y-axis. So now the along z-axis because this is more complicated. So you that variable y you are declared initially the variable declaration everything at this point you should understand this. Set B this. Okay. So pickup point is not a variable because pickup point is a constant. A single point is going to be available, but the variable point you have to declare like this. This is the explanation, and yeah, this is the pick and place. This is the example. So here the mission 1 and mission 2 is there. From mission 1 you should pick up this from a point 1 and you have to keep it at a point 2 on the mission 2. Okay, and mission 1, mission 2 is there. Mission 1 you have to pick this object and you have to keep it on the mission 2. Suppose say lathe and drilling is there. Lathe component is going to be over and lathe. You have to pick up this and you have to keep it on the mission 2. All right. So this is pick and place, how you are going to do it actually. So here imagine that the robot is moving at 5 meters per second between mission 1 and mission 2 because here the dynamic robot. Mission 1 and mission 2 is very far away. I am going to pick this object, I am going to carry it with the 25 meters per second, I am going to keep it on the mission 2. This is the logic behind it, pick and place. Okay, so dynamic robot, it's not a stationary robot. Okay, so here what you are doing is you are going to give the signal 5, okay, for the gripper. And speed here is I'm going to specify to the 60%. 60% of the 25 meters per second. So I'm going to open the gripper to the 100 mm. 100 mm. Size of this actually is specified to 20 mm. Size of the object is 20 mm, isn't it? So 20 mm is more than 20 mm. So 100 mm I want to open my gripper. 100 mm. So here I'm going to approach the point P1 onto the top of 50 mm. Offset with the point. I'm going to approach the point P1. The point P1 means on a mission 1. The offset of 50 mm. 50 mm away from point P1. So after this, I'm going to limit to the speed to 10 mm. Speed is 10% only out of 25, 10% I'm going to. So I'm going to move to the P1. from the safest position, all right, which is at 50 mm. So again, I'm going to grasp it. What is the grasp 10 and 100 mm means? This the opening is 10 mm. So here is the object is 20 mm. Sorry, here is object is 20. So here grasp to 20. Here grasp is 20 and 100. So if the grasp the opening is up to 20 mm, okay, then you go to the command of 20 line. Otherwise, you can go to next line. Next line means the opening is not 20 mm. If it's not 20 mm means if it is supposed to less than 20 mm, you cannot grasp it. That's the meaning of it. That's what the prompt. Enter 1 or 0. Now, if you enter 1, you are going to proceed to the next line. If you are entered 0 means you are going to stop. That's all. You are going to stop it. And after that, you are going to see that your opening is 20 mm. So by mistakenly, there is a chance that the gripper is going to be opened by means of some many regions because of the initial force or maybe the something is struck up. Suppose there is no, what is the guarantee that a gripper always they will be moving in between these? There may be sometimes that the gripper openings are going to be because of the sticky nature or maybe fingers are not opened. So in order to ensure that, otherwise what is going to happen, this end effect is going to be damaged by itself, or sometimes the end effect is going to damage your component also. That is the reason here opening is very important. So grasp 20, 100. That's the statement. I think this is the use of this grasp command. Otherwise, you have to go to the 100. Otherwise, you can go for next. So here prompt command is required whether you want to go ahead or not. If you are going to give one means you are going to proceed. Type you are going to proceed. So I am going to go to the 100. Go to 100 is not required to write. If you want to write it, there is no point. You can write it. Otherwise, it is going to take from the grasp command itself. So here is yeah. I stopped on your okay. That's what I can say that error input actually. So if any gripper is not positioned, error input is there. You are going to stop it at this position. You are going to end it. Otherwise, you are going to go to the this thing. If opening is more than 20, equal to 20, you can go to the next command. So you are going to go to the P1 position. No? Again, you are going to go to the with the 40%. Again, you are going to go to the P2 point. The safest of 50, and again you are going to reach to the P2 position. Again you are going to below and above. This is very important. That means you are going to move to from below position. Okay, this is the configuration. The below configuration. Okay, and again you are going to open it until 100, and again you are going to come to the above, and you are going to depart to the point of P2, and you are going to end the solution of it. This is called pick and place. Okay, so gripper opening is very important. So grasp command is used for this thing. Not ensure. Otherwise, if the machines are running and if something is going to happen, if human beings are not there, so gripper opening is very important. That's how the grasp commands are being used as in this example. So here, depalletizing problem. Depalletizing problem here is, shall I continue for next 10 minutes? Hello? Shall I continue? Because that welding example is there. Shall I continue?
Okay, sir, but that welding example, please share that video, sir.
Welding example, surely I'll do it. But explanation, I want to be this one. Earlier it was explanation. Shall I give within 5 minutes time? Welding?
Yes, sir.
Within 5 minutes, I'll complete.
Yeah,
so this is a depalletizing problem. Is this example is these components you are going to go without there in a row edge and column edge are aligned. So you are going to pick this component. You are going to keep it in a chute. You are okay. Row edge and column edge. You are going to draw it and you are going to drop it in a chute actually. So how you are going to declare these positions and everything? How you are going to change this? This is the logic which is being given in depalletizing problem. This problem, depalletizing problem. If I am going to pick this object, okay, which are there, but only you are going to keep it in a chute. So here no stacking, no unstacking. This is unstacking problem. Earlier it was stacking. This is unstacking problem. Which are there in stacking in the row edge and column edge. You are going to keep it systematically. You have to creep this programming command. You can understand it's not a problem at all. The logic behind it is moving from one position to other position, row edge, column edge, and everything. So there is another problem is in depalletizing problem is along the diagonal only you want to pick up this object, this example. So there before this example you are going to pick this all the objects and you are going to keep it in a chute. But here you are going to pick this object only on the diagonal. So how you are going to modify the logic behind it? There is another example, unsolved example. You are going to pick this along this diagonal, along the diagonal. So how you are going to modify the diagram of this actually? Now the dimensions are being changed now. Earlier it was 20 and 30. Now the dimensions are being changed so that You cannot copy the same example, this thing. So again, modify this dimensions part of it and everything. So a little bit modification of this example, previous example. So now welding example will take it up now. Within 5 minutes, I will complete this welding example. So welding example, this is the example. So along welding example, so example first one is x1 is the home position, no? X12 is the last end position, no? X12. So x1 to x2 I should draw it. Okay, I should draw. I can move from x1 to x2. From x2, I'm going to start my welding. So x2 to x3 is a triangular weaving pattern. No? So x3 to x4 is the straight away pattern, and x4, x5, x6 is the curvilinear. And from x5 to x6 to x7, x6 to x7 is a straight, and x7 to x8, x9 is a curvilinear. That means circle motion. So this is the move motion. Move. Okay, this is the x9 to x10. From x10 to x11 is a trapezoidal motion. That means you have to declare initially how many types of weaving patterns here. Weaving set is W set is the two patterns. So set 1 and set 2. So with reference to set 3 also declared it. So speed with reference to speed, current and variation. So how many variations are required? Set 3. So set 1 and set 2 I created. For triangular and trapezoidal. For straight one, I need not to do that. Circular, anyhow, I need not do that. Circular is also similar to the straight only. So here is this is straight and the circular. The single pass only I'm going to do it with no weaving pattern is there. So this is circle command, this is straight command. I need not do. But this one and this one, trapezoidal and circular, only two weaving patterns I'm going to create. W pattern. W means the W welding weaving pattern. Set 1, set 2. First one is a triangular. The next one is a trapezoidal. Okay. And 3 weaving set with reference to the speed, with reference to the voltage and current is meant for this thing. Whatever the set, if you want, you can do that. So move first. You are going to move to the x1. First, you are going to move to the x1. So after that, you are going to move to the x2. From here, x2, you are going to use a start. W start, welding start. W start means you are going to go welding start. Welding start with 1 1. So 1 1 means W set 1 is a 12, 50 and 55, and weaving pattern is a 10 8 0 0 0 because this is a triangular. This is a triangular, and with this speed and voltage and command, so I am going to execute this second weaving pattern. This is circular triangular pattern. You see this triangular pattern. I am going to do this triangular pattern x1 to x3. So I am going to move to the x2 and I am going to move up to the x3. I am going to move up to the x3 with this triangular pattern. From x3, I am going to now after this I am going to end up now WN because now again from triangular pattern to straight pattern I am going to move. So I am going to weld the stop the welding for 1.0 second. Now I am going to start up to the second point 2. This is the W set 2. I'm going to use the W set 2 for a straight command. So simply I'm going to give move to the x4. So x3 to x4 it moves to the straight command with the second W set. W set means welding set parameters. Okay, and after this circle means curvilinear with the covering with x4, x5, x6 because representing circle you require 3 points. Okay, now you have moved up to the x2. So after this, again you are moving to another circle. Okay, there are 2 circles are there. This is another one straight, again 3 circle, and after that again straight, and after this a curvilinear. So whatever the W set is there, set 1, set 2, set 3, if you want you can take it. Again trapezoidal, again I'm going to take it. W set is trapezoidal, which is moving up to W11, W10 to 11. In between W10 to 11 actually, so you are going to move from the straight pattern to the circular. So W command is going to be given here. So again, I am going to do this. Up to W11 is the last one. Move up to the W11 with the weaving pattern of the so and so pattern. So after this, now crater fill is going to be given because of the arc deflection. So the hole is going to be created just like a dip structure. So in order to fill this dip structure, so crater fill is going to be given here. Crater fill. So crater fill with 1.40 command. So after that, you are going to stop it. Again, you are going to come to the initial one. So this is how I am going to execute with reference to target plan. So here this is a welding problem for multi-layer, multi-pass with the curvilinear welding. So this example is there in SR Deb actually. So here is a Bhattacharya and SR Deb actually, the Aicte. These 3 people, they have done it this welding. Just you can see this profile I want to see. So here there is a stationary point, and there is a one circular pipe is there. Along this circular pipe, triangular pattern, I should do this welding. Again, I should go back to this. Again, I should go to this. And here there are two pipes are there. There are two pipes are to be welded with the multi-pass. The multi-pass means because the thick weld should be created here. So here multi-pass is going to be created here. Okay, layer 1 and layer 2. So curvilinearly I'm going to do it along the curve. So remaining other things, only the straight, only the along the arc only you are seeing the example, last example. But here along the circle I'm going to do welding. It's a multi-layer pass because the two circle objects are going to be added here. And this is a example with a multi-pass, multi-layer. Okay, multi-layer in the sense, there is one the plane is there. There is another plane I'm going to create it here. But earlier example, the plane is same. Plane is same. This example, the single plane I'm going to do the welding. But here the different multi-layers, multi-planes. So you are going to. This is a very critical example. Just you can see how much big example it is there. So here you have to initially you have to declare about the different planes and everything. You should do that. And see different. This is very big problem. Very big problem. Just you can see how much problem it is there. Subroutines. So this is the ultimate problem actually. Very big problem. You can see this. So examples also I given this actually. This is the unsolved examples. Almost you can say 10, 11 examples are there. All 11 examples you can go through this unsolved examples also. And as per this. Yeah, no, I think almost everything we have completed here. Any doubts are there? Hello? Hello, any doubts are there? Hello?
No, sir. No, sir. No, sir. You can able to follow it up.
Okay. So I think we have covered building example, and second example I could not do because you can understand it's not a problem. Then you can purchase, there is a one robot programming, there is one book is there, particularly Muhammad. He is from Saudi, actually, Saudi Arabia, is the Institute of Petroleum and Energy Conservation. There is a college is there. He is a professor, Muhammad. He has written a book on robot programming. And SR, particularly, this example, welding examples are excellent. This example. Remaining other examples I have taken from that Muhammad textbook, robotic programming. And this welding example, and I have taken from SR Dev. Okay. Flexible introduction to robotics and flexible automation. That is the name of the textbook. Okay, so these programs, what you can do is they can type in that Aicte Kharagpur virtual lab is there. That what I have shown the link and everything. So you can see the virtual operation, everything. You can verify. You can do that. Okay. Sridhar?
Sir.
I think this material I'll share it now.
Okay, sir.
Theory as well as the unsolved examples, solved examples, and everything.
Okay, sir.
Let them practice it. Okay.
Definitely, sir.
I think they are much interested. So I given full complete yesterday night also prepared this. Almost 12 solved examples are there in this.
Thank you, sir.
Okay. Yeah.
Okay, sir. Okay, sir. Once again, on behalf of Narayana Engineering College, Nellore, I'm very much thankful you, sir. Grateful you, sir. Yesterday and today, with your valuable support and cooperation for taking nearly 3 sessions. Yesterday 2 sessions and today 1 more session. Today sir has covered pick and place applications of robot and also with sir interest. Sir is showing interest towards discussing this robot programming with various commands and applications of various commands in welding case study and as well as pick and place case study. And sir has covered some topics like robot trajectory, robot motion control, hypothesis and test, penalty function, etc. And also sir specified one test book which is very much useful for the participants who are doing their research work in this particular field. Once again, thank you, sir. Thank you very much for your valuable support, sir. Very good afternoon, sir. Thank you.
Okay. Thank you. Bye.
चला बसा नंतर बघू
2 o'clock అటల్ క్లాస్ ఉంది కదా. 2. మీరు అటెండ్ కావట్లేదు. రేపా ఏ సార్ మీకు లేదా? మీరు కూడా ఉన్నారు లిస్ట్లో. మీరు, గిరినాథ్ సార్, తేజస్ సార్, శ్రావణి మేడం. 100% వస్తేనే సరిగా జరగట్లే కార్యక్రమాలు. 50% వస్తే ఎట్లా చేద్దామని. సర్లే మళ్ళీ మాట్లాడదాం దాని గురించి. నేను మీకు చెప్పా కదా ఏదైనా బెటర్ ఆప్షన్ చూసుకోండి సార్, అడిషనల్ ఇన్కమ్ సోర్స్ అని అంటేనే. సర్లేండి.
Good afternoon, sir. Bhavan Prakash, sir. Hello.
Sir, good afternoon, sir.
Sir, actually, as per this FDP schedule,
Yes, sir.
1 to 2 lunch break. Participants
Yes, sir.
up to 1:15, they have already attended on.
Okay, sir.
Exactly, we will start within 3-4 minutes. Sir.
Yes, sir. Sure, sir. Thank you. Thank you.
Hello. Sir, Banu Prakash, sir. Hello.
Yes, sir.
Okay, sir. Shall we start, sir?
Yes, sir.
Okay. Very good afternoon to one and all. Welcome to our today's expert and resource person, Professor Banu Prakash, sir, for this today afternoon section on stress management as a part of our 1 week FTP. With the valuable support by Aicte Atal and also participants, we have successfully completed 3 days sections up to yesterday and today 2 sessions. And today and tomorrow we are having totally 3 more sections. As a part of that afternoon section today, fortunately we have one eminent professor from ISKCON, Mumbai. So, Sri Banu Prakash sir, having a double PG degree in biotechnology and previously worked in engineering colleges for 10 years in various positions. After that, sir specially completed his extensive course, 2 years extensive course on Vedic studies in Mumbai, Govardhan Eco Village, ISKCON, Mumbai. Sir is presently conducting series of programs on various courses like Discover Yourself, Science of Self-Realization, Promoting Value-Based Education in Schools, and also organizing various personality development programs and lifestyle management programs in engineering colleges, in corporate sectors, in statewide. With this brief introduction, I am welcome you, sir, to this afternoon session on stress management topic. I hope this topic will be very, very helpful to the young participants to enhance their life skills. Welcome you, sir.
Yes, sir.
Thank you, sir.
Sir, thank you very much, sir. So I'm very much grateful.
Thank you, sir.
I'm very much grateful to Narayana Engineering College management, especially Sridhar sir, mechanical HOD, for inviting me to this session, stress management. So might be for the last 2 to 3 days, you would have all been completely immersed in knowing the technical parts of the subject like robotics and all. So we would have things would have been information is there in our head. So to be all of us to be in the same page. So for just for 2 to 3 minutes, so we can relax for 4 to 5 minutes by some breathing exercises. So will you please just keep aside all your okay, whatever books or material or pen one side. Just be aware that you are comfortably seated in your seats. No need to worry about your past or your future. Just try to be in your present. Just try to be in your present. Okay. So just try to close your eyes. Take a deep breath, inhale, assuming that cold air is passing through your nose. Okay. Slowly, and hold for just 2 seconds. Then assume that you are exhaling the air, hot air, slowly. Again, inhale, assuming that you have cold air entering into your nose, filling your lungs. Hold it for 2 seconds, then release the hot air, exhale the hot air. Inhale the cold air, Fill your lungs with the air. And then exhale it. Again, inhale it. Inhale the cold air. Fill your lungs with the air. Just hold it for 2 seconds. Then again, release the hot air. Just do it for other couple of times. Yes, sir. Thank you very much to all the participants. So I hope you are now we will be focusing on the topic called as stress management. So I'm going to share a PPT, so which already some of our seniors have designed it, and we are not going to as usual part like so many stress management kind of things. So we are going to deal with the nature of our body, nature of our mind, nature of our world, which is actually the core issue why the stress has started. So from where the stress has started. So today, now we are going to see the PPT. So I'm going to share the slides with you. So good afternoon and all. So this is stress management. So from Vedic perspective, so we are going to see from the Vedic perspective, stress management on the Vedic perspective. So American Institute of Stress says that so much stress is being increased year by year. So 33% of the cases they are facing extreme stress around the world. 77% the physical health is being now under serious threat, and 73% the mental health is being impacted, and 48% it's they're getting trouble in their sleeping, which it should be actually natural. Normally animals also sleep very naturally, okay, but we being more intelligent, we are being more conscious, but somehow unfortunately our we are now feeling difficult to sleep, and we have to take external aids in the form of pills to sleep, okay. So no doubt technology have increased, no doubt we are trying to reap some benefits of technology, but still somewhere we are losing the plot that somehow our inner world is being disturbed. We are, no matter we are trying to control the external world as much as possible, but to the extent we are trying to control the external world, somehow so much troubles are happening in our world, that is within ourselves. So Global Organization for Stress is saying that 70% or moderate high stress levels are seen in the past, for the past 1 month. And in college as well as in school, students, number one health concern stress because of the competitive nature, that lesser jobs, lesser opportunities, but more people are getting educated now. And everybody want white collar jobs only. So ultimately lower number of positions are less, but people competing are more. And 80% are really feeling that work is the main cause for their stress. Ultimately, it has become a global problem. So 95%, 91% of the Australians are feeling stress and major illness of their life. So they are giving, it's all the survey, so done globally. Similarly, in Britain, most of the workers, like 450,000 workers, they were again saying stress is again the major problem in their life. And Chinese also reporting the same. So wherever the technology is being increased more and more, okay, somehow we are unable to, unfortunately, we are unable to combat this biggest disease called as stress. And if you see now the global trend is the more and more stress is increasing, psychological problems are increasing, and the greatest symptoms for those things, what we are seeing is like all these things have been recently been surveyed. Then the symptoms of the stress, as we all some part of the time, or even our neighbors would have been getting through these kind of symptoms when they are in stress. So irritability and anger, 45% of people say that they have got irritability and anger, 41% fatigue, 38% lack of motivation and interest in things. That is, they are not motivated to do something good, something higher. So 36% are in anxiety, 36% they are saying that they have got headaches when they are in stress. So 34% are feeling depressed because of stress. So 26% they have got some indigestion problems, some stomach upset problems, and 23% are from muscle tension, and 21% appetite changes. So they are not getting proper hunger. Okay. And co-occurring health conditions. Now, if you see, the global threat is two important diseases, that is high BP and diabetes. So these two are very peculiar diseases where they never die and they will not kill us also. Okay. If you have cancer, if you have AIDS, you have something, if you have many things, these things either they will get recovered or they will kill us. Okay. But these two things will go on as long as our life is there. Even if you wanted to get diagnosed some other diseases, the doctors first will say what is our BP condition, what is our diabetes condition. So before going through diagnosis for many other important diseases, but first they will check up that means internal part of our body, which is solely due to stress. At least 100 years before, stress was never a problem. But now if you see, the stress is the only problem which is creating all other health issues. Okay. The stress is a very most important factor for reducing our immune system. And recently we know corona is one such disease, so which was due to virus, where our immune system has been completely got down. So the natural thing was that improve your immune system so you can combat that disease. But unfortunately, though we are seeing that we are going to get for quality food, quality air, quality seeds, biotechnology, we are going to increase some biotechnological techniques to improve environment, to improve quality of life. But unfortunately, things are going down and down, getting worse and worse as the days are going by. And heart diseases, depression, anxiety, and whatnot, even greater people handling great things, still they are succumb to these kind of things. So earlier the lifestyle was be with the nature, go with the nature, and so people were not much affected by this particular disease called stress. So many management seminars, like stress management seminars, say that so they give some techniques, and they speculate something, they speculate some, they really experience, but they're all are temporary solutions, like be positive, forgive them. It's easy to hear, it's easy to go through those seminars, but as soon as you come out of the seminar, you should know how you should be positive, elements that will make you positive. Some say never be controller of your life, but the thing is how we should apply them practically. So somehow, though there are throughout the world so many stress management seminars are going on, but some are unable to tackle this one particular area. So what solutions they give is like you can count the numbers. So whenever you have under stress, or they give you stress balls, just divert your mind to something else, or have deep breaths. Yeah, they give some part of this, surely. But the thing is, they don't give us permanent cure. They don't give. They give a temporary kind of solution where it works for a few times, and afterwards our pressure increases or our challenges increases. So ultimately, somehow we are unable to get benefit out of it. So we are trying to give a solutions from the Vedas. So which we have never manufactured these things, or we are not out of solutions which we have actually experienced. But these solutions are from the scriptures, and scriptures are not mythology. So they are not some concocted stories. So my 2 years of extensive research And definitely, I have got so much confidence that they are all part of history. They are not mythology. Only thing is that our history does not go beyond some 500 years, 1,000 years, or 2,000 years. But our history lies much, much more earlier, much more before than our history books. Okay. And scripture, the great part of scriptures is that they are always proven right and time tested. They are always proven right and time tested. Yes. At whatever point of the time, whatever point of the area, whatever point of the people. So whoever want to test these things, and surely they become successful and they can reap the benefits. So worldly scriptures like you take Quran or Bible or Bhagavad Gita or whatever religion we follow. So the scriptures broadly gives, if you like conclusions, is that they give two important things. Of course, there are many details, so we don't want to go into it. And people doesn't when you take these books or when you take this religion name, somehow many people get disturbed. But my understanding is that I understood that yes, all the scriptures are according to time, place, and circumstances, and they have given different details for different kind of people with different types of problems. But when you wanted to equate it, and definitely there are going to be a lot of problems. But if you segregate all the things, and finally you can come into two important statements from all the worldly scriptures. One is we are all children of God, which is, that means we are all product of Lord. And one more statement is that all claim that go back to kingdom of God. Some say Vaikunta, some say kingdom of God, some say Jannat. So whatever it is, so no scriptures are recommending that please stay here only. You know, please be only. Everything is there, everything is fine here. No scripture is recommending like that. Every scripture is saying that your father is there in the heaven or in kingdom of God, and please go back to your father. So this is the two things, which means somehow we get one particular important conclusion from this is that somewhere the place which we are living is something not suitable for us to live. It is something like it's like miserable world. So I will tell you why it is a miserable world. Okay. So if you go to Bhagavad Gita, so which is where my actual part of interest is, and really it has helped me a lot to understand myself and the people around me and the world around me. And it has given me a lot of clarity. It has given me the thought process, how we deal with the things. Yeah, still there is so much to improve, so much to do. But absolutely, I'm completely convinced that, yeah, if everyone try to follow the mechanics and the management present in the Bhagavad Gita, despite if they belong to different religions or whatever it is, ultimately we will know how to manage our life. So this is one incident where in the starting of Mahabharata, before the uh, main battle starts, so when both the Pandavas and Kauravas, when they are about to fight, and Arjuna somehow draws the chariot, informing Lord Krishna to place him in the between the both groups. Suddenly, out of nowhere, he sees the his he sees the opposite side. Suddenly, he says that how can I kill them? How can I kill them? So before battle, also he knows who are there in the opposite side. Before them also, he knows who are there in the opposite side. But suddenly now he feels that his superiors are there. His lovable people are there, like Dronacharya, who is his own guru, and great personality like Bhishma is there, and all are his relatives only. Somehow in the middle of the battle, is about to fight. Somehow he's trying to he's succumbed to some stress. He succumbs to some issue, and what he's now he's almost is like he does not want to fight, and he crumbles, on the chariot. So what he says is the first chapter 28th sloka and 29th verse. So he says, Arjuna said, my dear Krishna, seeing my friends and relatives present before me in such a fighting spirit, I feel that my body is squaring and my mouth is drying up. So my body is shivering and my mouth is drying up. My whole body is trembling. Okay. And my hair is standing. And he's very, he loves his bow and he never wants to keep his bow. He always wants to carry that bow. He does not want even keep it aside. But in such a state, even his bow was slipping from his hand. And he says, my skin is burning. So when I say these scriptures are time tested and proven, and we are not trying to concoct our own ideas or our own solutions to give for stress. And here we see a person who has a valor, who has immense skill in fighting anyone. He has got all the weapons in his hand, and is fully knowledgeable person, equipped person, and a very great warrior. Fought many battles, even with even with the demigods, but still getting crumbled in a before a battlefield. So now the Lord Krishna is trying to take this situation and trying to give us how we should manage our life, because we are all fighting our own battles. Okay, despite it could be in a family, it could be in work, it could be in our business, it could be in our whatever way we are. Surely everybody is fighting their own battle, and definitely we don't know what kind of challenges are going to be ahead. Somehow we are trying to plan our life that we should be happy and we should somehow or the other cope up with all these things. But still, so sometimes we are crumbled and sometimes we get victory. But here is Bhagavad Gita, so which is trying, where Lord is trying to give us, using Arjuna as a medium, and he is trying to give us so much information about ourselves, so about the Lord, about the soul, about the nature which we are living, about the time and the karma, that what we should do here. Okay, what things we should not do, what things we should do. So what things, if you certain things if you don't do, there is going to be a problem. Certain things if you do, there is a problem. Certain things which you don't do, it's good. So all these things, it's a very from first chapter to 18 chapters. So our conscious levels will start improving, will be increasing. So normally when we see a building, a big apartment, if you think that is a problem, if you are going on a road, if you see apartments, you see apartments are very big. Okay, if you think that, you see sometimes you say problems are very big because you are in between that. But if you go on a aeroplane and see the same apartments, now you see them as a small blocks. Okay, the same things, the same apartments which we if we take as a blocks, when you are in between you find it as a very big, but when you see from a different level you see it as small box. Similarly, when we alone with the same kind of conscious, okay, in the same kind of thought process, if you now be in one place, you see there are so many problems. But when you rise to a higher level, then if you see the same problems, then you no longer feel that as a problem. Similarly, now Arjuna, when he was in the battle in the between the battlefield, and when we was seeing the same people, thinking that he is our relatives and they are our elders, so we need to respect them. And how could I kill them? But still, they are ready to kill us. So now he was under tremendous pressure, tremendous stress, and he was completely bogged down, and he was almost literally crying. Now, when Krishna starts giving him various information about entire things around him and about him, about the nature of the world, about the nature of the soul, about how this entire world, that is material world, is working, that is nature works, and how this time is working, and what to be done. Then the same Arjuna now keeping the same problems before him, that is his relatives or whatever relatives. Now he is completely prepared and completely focused, and he is damn right there to give a wonderful, and he wants to give his best in fighting. So never was there that now the problem has gone. Problem was there only. Okay. So never think that. So if I become a good scientist, if I become a good doctor, if I go to a good position, there will not be problems. So the Lord says that this world will always pose us challenges, and here are the tools where you can utilize those tools, and you can fight that battle. So nowhere the Lord says that, say, I'm going to remove the problems for you. So we should always see that, yes, there is going to be, let me take certain tools, how I can overcome those things. So this is how the warrior who in a bit in the middle of a battle, so coming under tremendous pressure, but taking certain instructions from a higher authority, now seeing the same problem, but it's now no more a problem, and is fully determined and fully focused to fight the battle. And finally, he emerges victorious because the Lord is with him, and Lord is always with those people who are ethically, morally, so who deals their lives, who are always right in their profession or in their life. So definitely, Lord is there to protect them. So there could be two kind of, if you say that stress is not required, no, stress is required, but the thing is we should have positive stress. Positive stress will always keep us encouraging, enthusiastic to face the challenges. Whereas negative stress will always see that this that the challenges are going to really crumble me out, really bog me out. Okay. Only thing is, if you don't have stress, you will rust out. If you have more stress, you burn out. So best is have an optimum stress where you can perform also well. So we should have such a environment where we have a positive stress, so where we can perform the challenges more better. So the practical solutions where we can give is from the scriptures is there is 3+1 formula, 3+1 rule. So we can say you should have directly given 4 rules. So what is this 3+1 rule? So 3+1 rule is that, so there are three solutions, but which you completely depend on one particular main important solution. Okay. So if you don't do that one solution, if you don't take care of that one particular solution, definitely those other three may not work. Okay. That's why, so we are going into 3+1 formula. Okay. So we have three types of stress we have. One is bodily stress. The second one is mental stress. And the third one is social stress. So what is this bodily stress? So bodily stress is, so which is pertaining to our body. So, so there is a time symbol there which says that, so not properly doing our work according to our time. Okay. That leads to bodily stress. Like you should know when you have to sleep, you should know when you have to you should know when you have to eat, what you have to eat, okay, and when you should not eat, and what kind of things you have to eat, what type of food materials you have to eat, and you should not know what you should never eat. Okay. And if you don't follow the time schedule, at least as maximum as possible, since this is being a machine, this is also a machine, okay, definitely bodily stress will be there. Next, coming to mental stress. So mental stress is that, so we are going to, everyone, we are all working, suppose we are all working in one particular organization, but still everybody given the same task. But still what happens is some people handle those things, and some people cannot handle those things, which means that the way they see that particular challenge or that particular task, so it differs from one person to other person, which means that the kind of things which they have in our mind, that means which how they have been brought up, what value system they have been given, either from their birth to when they're grown up, and what kind of association they make. So they try different. We all people see difference in a different way. Okay, and because of this, so when people cannot see the things as they are, and if they have some different ways of looking at it, and definitely some people cannot cope up with that, and then they come into mental stress. And what is social stress? So social stress is that, yes, fine with my body, I am fine with my mind, but still because we have to deal with the people around us, you know, deal with the circumstances around us. Though we may be right in all the ways, but it's not necessary that the other people may respond to us, okay, in a way how we want. So whenever they don't respond in a way how we want, and definitely we go through certain types of stress, okay. So it's like we cannot be alone, we cannot stay alone, and we cannot live alone. Definitely, we being emotional beings, definitely we need some connection, we need some attachments, we need some bondages with the people. But as the days progress, so some people may not respond to the things how we want. See, as the modern thing, modern technology goes, most of the time we try to see that most of the things are under our control. So we try to control many things through our gadgets. Okay, but if this mentality of controlling the situation through gadgets increases, we also expect that people also should respond like how I want to get it. But it's not going to happen because they have their own minds and they have their own way of bringing up, and they have different value systems. So the value system which you feel that is right may not actually appealing to the other people who are actually having different different value systems. So in that case, when they don't respond, it could be in our family also. It's not necessary that everybody will accept and agree to our things. It could be in our organization, wherever. So definitely we go under stress. And the last one is spiritual stress. The fourth one is the spiritual stress. So spiritual stress is nothing but so understanding the nature of the mind itself, or understanding the nature of the soul. Okay. So what actual being is there? So when I put them into a triangle, it's also that they are interconnected also. Okay. Suppose if you are going under a social stress, definitely it will have an impact on our mental stress, and definitely it's going to impact our daily stress. Or if you have bodily stress, definitely it's going to impact our mental or social. So anyway or the around, ultimately, if you are going to get affected by one particular stress, definitely it's going to permeate so entire our body or inner world of our body. Okay. So so now we'll try to uh, figure out so what could be the best possible rules or solutions so to tackle these things. So statistics says that yeah, stress levels increasing from 2012, 13, continuously 18 stress levels are increasing. There are many reports increasing. So if you see the other graph, if you see the smartphones, mobiles, laptops, so gadgets are increasing, but but stress levels are not getting decreased. The technology actually has come, okay, to improve our quality of life and to see a peaceful life, because working hard is toiling our life. So better I get some gadgets so that I can get some time, I can have some relaxation, I can feel a better life. But unfortunately, the more the gadgets are increasing, the more the technology is increasing. We are not saying that technology is bad, but we should know how we should use the technology. Okay. Most of the time, people are trying to use them with with completely not knowing how we should use it, because we are not being trained how to use it. And when we have a powerful weapon with us, so we try to get what to say, uh, we get to bound to become slave of that particular instrument or whatever gadget. So if you say knife is good or bad, if you ask me knife is good or bad, okay, it's a product of technology. I say it depends upon the person who is handling it. If a person is trained, if he know what is good and bad about that one, surely is going to use it for the better purpose of cutting the vegetables or fruits and use it for the better life. But if he is not properly trained, the same technology, if he's not, then he's going to uh, create problem to some others, or he may create problem to himself. So technology is a very powerful tool, but it should be handled with care, with proper training and proper understanding. And that's why in military also, whoever joins military, there are powerful weapons like AK-47. But before giving that particular weapon to his hand, He is going through so much training, making him understand what is the value of life and to what he has to fight. And when finally when he is given that weapon, he knows when how to handle it. Okay. So similarly, the only problem nowadays is that so that we are not aware of the goods and bads of a technology. People who are handling it, they are not thoroughly trained, and that is why now we are seeing the reverse impacts or hazardous impacts of these things. So I'm trying to now I being from ISKCON or trying to spread this Vedic knowledge. Still, I am also using laptop. I'm also using all these things. But I know I was trained at how to what extent I should use, to what extent I have to handle these things, how it will not disturb my goals of life. That's why it's good. So we are not going to go against the technology. We're not saying that technology is bad. Only thing is that we should know how to handle it. That's all. So as facilities and comforts are increasing, actually it is not going to cure the stress, but actually it is going to cause the stress more and more. Okay, if we are not properly trained how to use it. Okay. So there is a sloka from second chapter, 44th sloka. Bhogaishwarya prasaktanam taya parhata chetasam. The minds of those who are too attached to sense enjoyment and material opulence are bewildered by such things. Bhoga means comforts. Okay. Aishwarya means facilities. Okay. Prasaktanam, when they're too much attached for too many comforts and many facilities, and definitely we are going to get bewildered. That means we are going to get little blocks, stumbles in our life because they are not going to give us life. Okay, now they are just things. Okay, but we being too much attached, we become slaves of that, and our goals are different. Our purpose of living here is different, but unfortunately we become slaves of those particular comforts. So just increasing facilities and comforts can never decrease our stress or never increase our quality of life. Only thing is that they increase stress. But if you know what is our nature, how to handle it, then the same facilities and comforts will give us a happy life. That is it. Actually, the entertainment, what we call actually scripture says, entertainment is a distraction. Okay, and facilities comforts are a trap. Okay, so we from Monday to Friday or Saturday we work hard in our daily life, and we wanted to relax for 1 day or 2 days, but actually this just a relaxation, and that too entertainment or whatever things we do, actually they actually increase the load in our mind, actually that we don't recognize it, but that is what actually is happening. From Monday to Friday we work hard and we go to movies, we go to things, but actually they are not actually they're not releasing ourselves, but we are just trying to escape from some some busy condition of life, but actually we are not finding a solution for stress, or actually they're not stress busters actually. Okay, because we are avoiding it and because we are escaping from it for some time, we feel that we are relaxed, but we should understand that it is not the solution for releasing the stress. It could be a temporary arrangement to move away from the main track. Okay, but actually when you come to the main track, the same problem is there only. The same you have to deal with. The stress cannot be removed from our life, because if stress is removed from our life, then we cannot work on challenges. So we cannot achieve certain things, because when there is no stress, there is no enthusiasm to actually find out certain things or to discover certain things or to make certain things. That's why stress, we cannot say that it has to be removed. Only thing is that it has to be handled with a proper understanding. That is what we should do. Many people that I have to remove stress, I have to remove stress. No, we have to have positive stress. Then all our whatever endeavors are, it's going to be fruitful for us, and it's going to be fruitful for the entire human race. Okay. But if you say that I don't want this stress, then there is no point in like we being as a human beings and trying to achieve certain things. Because if you don't have stress, you are going to rust out. Okay. So ultimately, all these things they become distraction or trap if you don't properly handle it, or if you think that I have to move away from stress. Okay. Absolute knowledge is that what is actually happening, why this stress is increasing is. So what we call from scriptures is called as Maya, this is illusion. So Maya, illusion is, so what is valuable, you don't value it, and what is invaluable, you're valuing so much. Okay. The things which are actually we should value, we're not at all caring about it. The things which we need not worry about it, or we not care about it, but still we are valuing so much. Like they're saying that nowadays we are using people and loving things. Okay. So as long as you are loving things and using people, our entire value system has gone completely into chaos. Okay. So actually we have to love people and use things. As selfishness increasing, okay, as the ego is increasing, so in the rat race of competition, survival of the fittest, okay, so taking that as a principle, so we are trying to, okay, use people and trying to love things, which is completely it's obnoxious, and we are into now under so much pressure. Okay. So actually we actually being social beings, emotional beings, actually we should have good relationships. Okay. But we have good relationships with our things which they don't respond anyway to our good or bad. But those people who are actually who can respond to our good or bad, who can be our strengths, who can support us, we are just using them. So this is one value system where we don't know what to use, what to love, what to give priority, and that's why we are going into tremendous stress. Okay. So some temporary cures is like, okay, meditation, yoga, some pills, yeah, they reduce some stress, but they don't eradicate stress, or they don't give positive stress to the entire our life. And some stress management guru says you can assert your mind, be always alert, be always be active in your mind. And they say, please forgive, don't have some grudges on anyone. So or just have some patience, be positive, be in the present, don't be in the past. So all these things are good to say, all things are good to hear. But as soon as you come out of this seminar and you don't know how to apply it, you don't know how you should do it, you don't know why you should do it. Okay. And ultimately, yeah, it can help you for a few days, but ultimately the stress is always there. Okay. So how we can go for a permanent cure is that we have to understand the nature and the rules of this world. Okay, that is most important for us. For example, if you go to a jungle, if somehow you are landed up into a jungle, so you wanted to go to a jungle and come back as early as possible. Somehow we have been stuck up in a jungle and it has become already night. Okay, and you have all the gadgets with you, some GPRS. You wanted to see what is the route, how to go out, but somehow signals are very weak. So even if you have good signals there, still you are under tremendous pressure and stress because you are in an unknown world. You don't know what kind of animals are going to actually, okay, be what kind of animals may attack you, or you may become prey for them. So though your GPS working, though your gadgets are giving you proper route, still you are into a lot of fear. You are in a moment of stress because you don't know the the nature of the jungle. You don't know what are there, what are those present there. You don't know in what direction they are going to come. You don't know how you are going to be attacked. Even after some time, even if a person who is actually residing in that jungle for about 40-50 years, if he comes there and try to say to you that, okay, I'm here in the jungle and I'm ready to help you out from this jungle and I know the route, and then there is a chance that our stress is reduced. Okay, still there could be some stress or some pressure, some fear, because still he is a man, and a tiger or lion, we are no matter for those animals. Okay, so So understanding the nature of this material world, in the world we are staying. Okay. Like there could be some tsunamis, there could be certain volcanoes, there could be some pandemics. We don't know what kind of things are going to come at what point of time. Okay. So definitely we should understand that where I'm staying is a land of uncertainties. Okay. Then there is a traffic where you have to follow rules. Okay. So rules. So in jungle we should understand the nature. In traffic we should understand the rules. So if you follow the rules, so you are safely passed out to our house. But if you don't have any knowledge about the rules of that particular country or particular state, then definitely you may land up giving a fine. You'll be fined, and that will increase your stress because you have to give some money. Or if you don't know the rules, and if you're on the road and some people on the backside, so they would have simply they go on you, and which will again increase your stress. So ultimately, permanent cure is that you should understand the environment, the world which we are living, and you should understand the nature of this world, understand what are the rules of this world. Okay, which unfortunately our college or school books not don't give us a complete entire details. They give us parts and parts which we don't know where to apply, how to apply those things. So yes, this world is nature. We have to understand this nature of this world and the rules of this world, which we call it as dharma. Okay, the word dharma means understanding. Okay, na, the entire functioning of this world and how we should be in this. Okay, and only the scriptures, like all the worldly scriptures like Quran, Bhagavad Gita, Bible, all those uh, religious books, they give us the details about these things. Okay, and dharma is not that something like I follow Hindu dharma or I follow Islam or I follow dharma is that everyone should follow, has to follow, and dharma is is uh, is one particular thing where everyone has to or will accept those things, and we will follow those things. Okay, so the moment if I change from one religion to another religion, my service nature does not go away from me. Okay, my seeing of the things of this world will not change. Or if I change from one place to other place, no, I have to follow, I have to understand the nature of that entire thing, because dharma is one thing where everyone has to follow, and they have to follow. Okay, and if we don't follow, they will be penalized in whatever world they are, whichever world they are, and whichever family they are. Definitely, because that is how the whole world works for everybody here. World will not have partiality for one religion, and it will not neglect other religion, or it will penalize other religion. No, anyone, whatever religion we follow, we have to understand the nature, the circumstances, and rules of this world, and go about it so that we can have lesser stress and we can overcome the challenges. It's like we are fish out of water. Understanding this fish in the water knows what is the nature of the water. It knows what is the nature of the water, and it can happily, freely swim in the ocean. But no matter how much you remove the fish out of the water and you give biscuits, ice creams, or gadgets, whatever it is, no, it cannot survive there. It goes through tremendous stress. Okay, so that is why we will be more comfortable in our place than we go in some to other alien place. Okay, so that's why wherever we are, try to understand the world around it. You can be in a organization, you can be in a family, you can be in a society, but you can understand the good and bad of all the things. So the rule for mental stress. So how can we reduce our mental stress? The rule one is, so Bhagavad Gita 8.15, 8 chapter 15 sloka says about this material world where we are living right now, the earth. It says Dukkhalayam Ashashwatam. Dukkhalayam means it's a world of miseries. No matter whoever you are, whatever position you are, how much rich you are, so you are going to bound with miseries. Okay. So no, we can never ever even challenge those miseries. So So understanding that, we have to lead our life. So what are those miseries? Birth, death, old age, disease. Okay. No matter who we are, so we are going to get attacked with the diseases, and definitely we have to go through old age and death. Okay. No matter so many plans we are, so we are going to have challenges from these things, and definitely we are going to suffer whenever these come to us. And apart from that, there are adhyatmika, adibhautika, and adidaivika kleshas, miseries. Some goes through problems due to their own body and their own mind. Some goes through the problems of even they are good, but other living entities like other people or other living entities like animals or even mosquitoes. So they get troublous. Okay, like corona, troubled by a virus. That is called as Adi Bhautik. Then third one is Adi Daivik, which are due to natural calamities. So heavy rains, heavy cold, okay, heavy sun. Okay, so we're constantly troubled here with various things, including birth, death, old age. So nobody wants disease, but disease yet comes. Nobody wants old age, still old age comes. Nobody wants death, still we are going to come into death. So understanding that these are the real challenges, and whatever we plan, we should keeping them in the mind. So if you plan, then we understand the challenges. So better we prepared for that, then we are going less at stress. So these are unchallengeable. So if you wanted to challenge the unchallengeable, then you are going to have under tremendous pressure. Okay. If you know that this is unchallengeable and we have to go through it, then you are going to have lesser stress. Okay. So Adhyatmik Adibodh Adidai. So this is what we say it as like Dukkalayam. It's a place of miseries. Actually, this world, all the scriptures say. That's why they say, go back to kingdom of God. Okay. No scripture, no messenger says you be here, and this will be a beautiful world, and everything can happen here. You can do it. Just do it. Nobody will say. You can go through anything. And what is the rule here is? What is the rule here is? Do not expect and do not lament. Okay. So do not expect. Okay. That everything is for you, and you will be recognized. Anything can happen at any time. Okay. Be prepared. And if anything goes from you, don't lament. Okay. So keeping this in the mind, so we slowly we can reduce our stress. Okay. We can understand the nature of this world. Yes, everything is we don't know what happens to us today night. Unexpected things can happen. We know many things have many there's so much history is there. Night they were kings, they were rulers, the next day they have become worse. Okay. In no time. So expecting that everything should happen to me, expecting that everything is going to be fine, will cause you stress. That is expecting that, yeah, there are challenges, there are things. I have to slowly go through these things, but taking some help of the authorities. Okay. Next, physical stress. So how we can reduce our physical stress? Rule number 2 is next, the same sloka 8.15 says Ashashvatam. Ashashvatam means temporary. So everything in this world is temporary. Okay. Dukkala means everything is there are miseries in this world. Number 2 is this is Ashashvatam means temporary. So whatever you take, it is going to be temporary. You build a stronger building for 500 years, it is going to get smashed. Our own body is temporary. We are not in the same body as we are in our childhood. Now you have changed. Then there was youth body. Then there is a change. There is an old body. Then ultimately your death has come. Though you yourself have been changing. Your thoughts have been changing. Okay. So Ashashvata means everything changes constantly from moment to moment here. So nothing in this world is permanent except the change. Change is permanent here. So it is going to change. So now I can say that I will remain in the childhood only. I will remain in youth only. I will remain in the old age. You cannot say, or we cannot say, because even if you wanted to be, how many years we are going to stay here? Okay. So understanding that this world is changing, it will change. It is not under the control of a scientist. It is not under the control of a doctor. It's not under the control of an engineer. It's not under the control of any person here. Okay. So we are living in a temporary world and we want to be permanent. So we want to be permanent in a temporary world, and because we are trying to fight hard, the more you fight hard, the more you feel stressed. But accepting it that, yeah, these are part of life, it has to go through, then I'm prepared for it, then I am lesser stressed. So there was a real time example. So one of our senior devotees, so when they were in their graduation, so they went to a riverside picnic. They went, so all wanted to take a plunge in the river. So they wanted to have good bath and they want to enjoy in that. And everybody were ready. So they want to take off their clothes and they wanted to jump into the river. And suddenly somehow most of the people were in the verge of jumping. A person came and said that, see, in that place there are leeches are there. So you have to be very careful. Please, if you want to jump, but you should take care of that leeches. And if you wanted to fight the challenge of leeches, then you can have salt with you. So wherever the leech is okay, wherever the leech actually getting attached to your body, if you apply salt, the leech will leave the body. Otherwise, the leech will try to suck the blood, and no matter how much you try hard to pull, it will not go away until unless if it's fat, if it is stomach is full, then only it will leave. And somehow this all the other students, so they somehow in the enjoyment mode, and they could not hear anything, and they just jumped away. So somehow I said, this senior devotee, so who was in his graduation earlier, somehow he got that knowledge. He heard that, and somehow he took hold of the salt, and he knows that there are leeches, but he was not afraid. He was not stressed, because he had the solution, understanding that there and there is a solution here. But other people, when they didn't understand, they didn't have the knowledge, and they completely, they didn't hear it, and they jumped it, and finally they have suffered so much, and then finally they have come out and things. So the point here is that understanding what is there, and you know what to do, then you will know how to, okay, deal with that stress. Okay. So understanding that this world is a place of miseries, no matter whatever you do, there are going to be challenges and there are going to be changes. And so in that, what am I here? What is the purpose of my living here, and what I have to do? Okay. So for that, what is the rule here is, you should know the balance and you should be disciplined. Okay. So balance is how much I should do. Discipline is when I should do. Okay. So there is an sloka here, 6th chapter, 17th sloka, verse says, Yuktahara viharasya, yukta chestasya karmasu, yukta swapna bodhasya. So yukta means regulated. So if you wanted to reduce physical stress, you have to regulate your life. Yukta ahara, eating, aharam, okay, eating. So you have to regulate your eating. Okay. Vihara means entertainment, or in our present context we can say exercises, that also be regulated. We have to do exercises. Third one, and yukta swapna bodhasya, you have to regulate your sleep. Okay. So, but if you don't regulate your eating habits, if you don't regulate our uh, sleeping habits, eating habits, and exercises, and definitely we are going to go through physical or bodily stress. Okay. And there is no short solutions. There are no fast food solutions here. Okay. If you wanted to deal with stress permanently, our bodily regulation has to be there. And if you say I can't do this, then better we have to uh, fall into some hospital or fall into certain things where we have to face other kind of problems again. Okay. So how to balance it? So according to Ayurveda, so see, I'm just dealing with our body only or ourselves only. So where comes our religion here? So where comes I'm preaching some Hinduism, or I'm saying I'm preaching some Islam, I'm preaching some other religious thing. No, I'm not preaching anything. So I'm just saying what you do. We not experience all this? That do we all not know that this is dukkha, that we all face birth, death, old age, disease? Do we all not know that this is asashvatam, that entire everything is changing, everything is temporary? Yes. No matter whatever we are, whoever we are, what faith we follow, these things are going to, and everyone has to face here. Okay. Now, coming to how we have to regulate our body. So, entire 17th chapter in Bhagavad Gita give entire list. So, what kind of food we have to take, when we have to sleep, how we have to see the bodily needs, everything. So, eating, if you want to do, so best thing is 2 times a day with full meals. Okay. And whatever the people say that whenever you're hungry, you can eat 3 times, 4 times, 5 times. No, that is not going to work out. It is said in Ayurveda that people who take 2 times fully, that having good lunch 2 times, they are going to have an active body. 3 times is okay, but 4 times is death only. Okay, definitely we are going to land into hospitals and we are going to pay heavy price. So that eating can be between 10:30 a.m. and 10 a.m. and 4:30 p.m. to 6 p.m., which is I don't know. I know that you can never be related anywhere here, but try to fall as much as possible. And if you suppose, despite these things, if you are hungry, you can take some juice, you can take some water. So anything in liquid form is going to always help you out wherever. But junk foods, all these things are really, really going to toll our health, and and the challenges and stress, and definitely we are going to lose our performance. And never eat between night 10:30 p.m. to 3 a.m. Never eat. And I know most of our, okay, these metro cultures have got that most of them eat after 10:30 only, and definitely they are going to cause serious problems. You know. Then sleeping completely between 10 a.m. 10 p.m. to 4 a.m. to the max 5 p.m., which is 6 to 7 hours of sleep. So all these things have increased stress. It will increase stress if you do anything beyond these things. Definitely, we are going to be in stress. Okay. Then exercise and prayers. Prayers are most should be the most important part of our life. No matter whatever we are, wherever we are, what we are following, between 5 a.m. to 7 a.m. It is going to give a lot of confidence. They're going to see a lot of peacefulness, despite there are so many challenges, so many risks. Still, we know the mind will allow us to deal and see the things and try to cope up with those things. If you want to take a rest in the day, it could be between 2:30 p.m. to 4 p.m. Then just it should be about 45 minutes in the day, not more than that. If it's no stress, also no problem, but it's the thing. So these are some things which we have to maximum try to follow as much as possible. At least if you cannot do on the weekdays, you can do on the weekends. You should try to do as much as possible, because you are more important to your family. So you are more important to your relation. So you are more important to many people around you, because you may be some good people who are trying to serve people, who are trying to so give good amount of things to your society. So you may be some role model. You are people may have some expectations on you, but you should try to do as much as possible. So because any solutions from Vedic solutions, always are, maybe it may be slow, but they'll have a permanent effect on you. But being part of this metro culture and these things, and trying to have fast food kind of culture, okay, then definitely we are. So that's why hospitals are, people are increasing, the tests are increasing. You are have to spend more and more money, and where you have really worked hard, day and night, to have to save some money for your future. That's why you had some plans, but still all things have landed up to hospitals only. Okay. And fruits, juices, this anytime you can take, which will always have a good impact. Please don't go for these soft drinks or hard drinks, which are really going to trouble you, and you are going to really face additional challenges despite the other problems already we have in our life, and we are going to increase those things again. What is a balance? How much to eat? So I said what to eat and when to eat, but how much to eat? So eat when you are hungry and stop before full. Don't have full blast. Okay. So if you know that's going to full, then before there's some 10%, some 10%, 15% before only you try to stop it. Exercise when your exercise should be, you should feel energized and relaxed. Okay. So not that you run fast and you heavily lift so many things and you get so much sweat and that is a real exercise. No, it's not like that. If you are sweating and then actually you don't relax, actually you feel energy has lost. So you feel like go on sleeping again. No, it's not like that. If you exercise, you should feel like more enthusiastic. You should now work more. You should be more smart. But that kind of exercise is real exercise. Okay. And best thing is that yoga exercises they don't give so much sweat, but they relax entire your body. And after that exercises, yogic exercises, then you feel like you want to really go on and challenge this world. Okay. And sleep maximum 6 to 7 hours, and definitely it should be as early as possible in the night from, and must is from 30 to 3:30 or 4:30, 5 o'clock, whatever. And the body and the daytime rest is 45 minutes, or if you don't take rest, it's still more good. So how to deal with this social stress? Social stress is like I already said, you have to deal with the people here. Okay. So you may be good with your body, you may be doing everything good. You may be good with your mental mind, but still you have to deal with other minds now. So other minds means here the main principle is ego principle. I, mine, me and mine. And they also have their own me and minds. Okay. And there is always competition in an organization for a post and for a for a position. Okay. And we coined the term politics. Okay. In our work environment and wherever we are in a business, whatever. Because the ego principles are there. So in third chapter, 27th sloka, so Krishna says that ahankara vimudhatma kartaham iti manyate. Ahankara means everything is happening because of me, and everyone should be for me. Okay. And everyone should listen me only. Okay. Because my interest is the main interest. Okay. Not no one's interest. Okay. And when everybody feel like my interest is the only interest, then there is a conflict of interests. Then there is going to be always stress, like what he is going to plan against me and what I'm going to plan against him. Okay. And these things will really bring our performance low, and even our behavior changes, our character changes, and ultimately we land up nowhere. Okay. So that is why this one particular thing is the people who are selfless, okay, and who wanted to do something for the people, who are doing something for people, definitely they have lesser stress and they have a positive stress of doing work, because they give a they have a feeling of satisfaction. When you have a feeling of satisfaction that I am here to, yeah, I want for me I want certain things. I don't want, for emergencies I require certain things for me and for my family, but I'm also here to do something for the people. Then there is an amount of satisfaction which creeps in and which will keep us light and which will keep us happy, and there is lesser amount of stress. And that's why you find where the Bill Gates Foundation, the big Tata groups, so they have crores and crores of rupees. So they would have actually they would have more and more they have gone for enjoyment. But I have gone through the biography of Bill Gates and all. What I have known is he was thinking that I'm getting so much turnover, so much money I'm getting, but still I'm not getting happiness, I'm not getting peace. Then he started Bill Gates Foundation, where actually he was started contributing to the society. Then actually he's more into foundation than more into technical part right now, because there came the amount of satisfaction, and now he's giving contributing more to the world. Okay. which means that selflessness to some extent will reduce our stress. So what is the rule here is refine your speech. So because you are dealing with individuals, so don't try to, we should not never try to hurt them or try to show their faults. Better encourage them what are their good strengths, have a good family relationships. At the same time, when you always genuinely appreciate, not for the not for the matter of flattery, not for not we should not flatter for something that I should get certain things from him. If you flatter and wanted to get certain things, you are going to have more trouble in future. Instead of that, genuinely, if you try to appreciate those qualities which are not in us and try to learn from him which are not in us, and if you understand, if our kind of way of thought process is like that, surely, okay, you are going to have you're going to have lesser competition, and everybody wants to help you also. It may take some time because nobody will believe us immediately. If you change, nobody will immediately believe us. But surely over a period of time, when they feel the genuineness in you, and surely they are going to help you out. I personally, I have experienced that. The moment I felt competitive, really I was into so much pressure, and every day I have to think about them. Every day I have to understand what they are going to do. What am I living? Am I living really? Or am I just day in, day out, I'm trying to fight out them? And for what we are living then here? So it's like give and take policy kind of thing. Okay. We may have a question that what if they don't change? They change or they don't change, because the character that you have, that I wanted to help or I wanted to learn, I wanted to appreciate, will keep you in peacefulness, will keep you less stress. Okay. No matter they respond or they don't respond, they give or they don't give. It's matter that you are healthy and your thought process is healthy, then definitely the day will come that we all can really reap the fruits. So here the rule is refine your speech. So speech talk to them in a pleasing manner. So in a way, we have really found some good things in them, and you appreciate them, and we will also be happy, and they'll also have good good thoughts about us. Okay. Then raise our character. Okay, now raise our character and refine our speech and raise our character. Again, 17th chapter of Bhagavad Gita entirely deals with these things. So what kind of speech we have to do, how we have to do, and what kind of nature it should be there. Okay, that's what it says. 17th chapter 15th sloka says, Anudvegakaram vakyam satyam priyahitam chayat. Satyam, you should speak the truth. Priyam, which is pleasing to them, and hitam, for their benefit. So for their benefit, we have to, more than pleasing, sometimes pleasing, they may feel that we are flattering them. But if if you say them for their advice, for their betterment, surely they will appreciate us, and they wanted to be with us. Okay. And raise character is like being a well-wisher, like Suhurdam Sarvabhutanam. So trying to be a well-wisher for all of them. See, all these things we are not today. We may not be in this point of time. We may not having these things. But over a period of time, if you slowly, okay, now develop these things, we are the persons who are going to be happy despite wherever we are and in whatever situation we are going to have our own uh, better conditions dealing with the stress or even overcoming stress certain times. And the last one, the one which is called a spiritual stress, 3+1 rule. The one is spiritual stress. So this in 6th chapter, 5th sloka, what is the spiritual stress is like the mind. Understand the mind is a major balance. So major middleman, okay, between the outer world and the internal world. Okay, it is a mind. What the information you have, how you trained it, so what kind of information you have put into it. So that is how you are going to deal the things, how you are going to see the world, you are going to see the people. So it says in Bhagavad Gita 6.5 that if you train your mind is going to be the best friend of you. If you neglect the mind, it is going to be the worst enemy. Okay. So people who train their mind, the mind will open all the opportunities to get whatever we want in our career success, for our career success. But if you don't train the mind, and definitely it is going to kill us. The suicides happen because mind has become an enemy. Okay. So there is a good dog and a bad dog in us. So some part of your mind which is good dog, if you feed the good dog, it is going to protect you. If you feed the bad dog, it is going to worsen you. Okay. So the best part is how you are going to control your mind is. So this is what the entire all the scriptures of this world say. Mind can never come control by only our efforts. Mind can never come under control only under our efforts. Okay. It should have the prayers of the we should have the prayers. We should have prayers. Okay. And only the Lord can help us in controlling our mind. No matter we have to do our part, okay, in controlling the mind, but ultimately the grace of the Lord will actually put us into. That's why you find previous acharyas, previous gurus, so they have absolute mind. Even the contemporary ways, you find Mother Teresa, so you find Abdul Kalam, so they are good social worker and good scientist, and he had absolute control of the mind because he follows Islam in such a way that he always he's wherever he prays to the Lord. You know, despite he's such a great scientist, and almost like we can say he's a pioneer for the space, at least in the contemporary world. But where did he get that much that the maturity to deal with the things, to deal with the kind of people when in his post coming from a humble background, okay, coming humble from a normal village where there were never an opportunity, but to extent where he has gone, and we can understand what kind of post he has handled. Okay. Either in the scientific world initially, then he became a president. Still, he's one. I think he's one person who did not have any controversies, no matter whatever it is. And if you ask him, he's a great spiritual person. So spiritual persons only know the nature of the world, and they can understand and they can deal the things. And spiritual persons are those persons who are really selfless and who are well-wishers. I think in the starting point of his career, so there was a problem and somehow it failed. And I read from his biography that when there was a failure and when all the press came to know the reasons for his failure, then he was the person who came front. He said, "I am the main responsible person for this failure, and somehow I will try to rectify it." And he never blamed the the mistake on anyone, though he is not responsible really, but still he has taken the result because he was a leader and he was selfless. So he was protecting his team. And when in the next attempt, when it was success, he asked all his employees all his colleagues to actually face this press, and he was behind. He didn't talk anything with that. So it's such a matured character, such a matured when. So when it comes, means when you have prayers every day, okay. When you see having stress balls, gonna having you should talk like this, you should walk like this. So all this temporary things, why we need to act for a simple temporary gains, okay, which actually put us into more and more pressures. Why we want to act genuinely, okay, which where we only will enjoy the fruits. Because I've been in in a college, in an organization. I know what is in and out of, not only in this organization, any organization. But I understood that instead of earlier, before coming into ISKCON or reading these books, so what I am and what was my behavior and how I was dealing with things, I knew. And when I really started taking this and I was really practicing genuinely, so I know still there is a long journey. I should do so much, but still whatever I have done, I'm reaping those benefits. I'm happy with whatever I am. Really, whatever, there is nothing stress on me. Whatever stress is, there is a positive stress, because stress should be there, because we also wanted to reach many people. We also want to build organization. We want to come out, so we need funds, and we talk to people. And when we talk to people, some people will praise us and will accept us. Some people will shout at us. So will really embrace us. It's not our life is also not an easy one. So, but we know, because we know why those people are angry. We know why these people are really happy, and why these people praise us, and why these people are angry. And we understand what is their heart and what is their mind. And then because we accept those things. Because even if I am in that place, I'm also going to speak the same way, because that is how we know the things, because we know the nature of this world, we know the nature of the people, we know what that person is going through. Okay, and that's why we don't have any grudge on him, or we don't have anything, because whatever I'm doing for the Lord, I'm doing for the organization. It's not for me. Whenever if I am the controller, if I am the center, then I have to take the load. If I say I have done my best, I have gone, I have talked to him, but somehow today it is not worked up. Okay, tomorrow we will try it, some other people. So things are, yeah, one day it's going to be there, one day it's not going to be there. It's one day it's our day, one day it's not going to be our day. But I should be loyal to the Lord, I should be loyal to the organization, and I should be loyal to my moral, ethical values, whatever I have learned. And that is, no matter I achieve or don't achieve, my inner world is peace, and I can go to sleep peacefully. Okay. And the same thing, if Abdul Kalam can happen, it can happen, which the modern world actually really, if he is seen as a role model. So if he is also a scientist, a well-knowledge person, but at the same time he is a spiritual person. So if you are, it's not that spirituality should be taken at the age of 60 years or 70 years. Really, we are going to lose our entire life. Spirituality is, it's a part of human life where we have to work on side by side along with our natural normal duties. Okay, so when we work on along with our natural normal duties, definitely you take the benefits whenever you require. During our struggling days only, you are going to reap the benefits. So working hard through 50 years, 50, 60 years, and then you do some spirituality. And what is the use of that spirituality when it's not going to help you, when you are really going through challenges, and you are going through certain depressions, or certain part of your life when you are really struggling hard. Spirituality is one thing where you have to really use it when you are fighting hard. Okay. But unfortunately, somehow the myth has spread everywhere that if you are going to Lord, if you are praying something, these things are to be dealt after 60 years. Okay, so it's a really myth, and that's why now the entire world, at least people who are not praying, not taking interest in these things. So they may be temporarily successful. They may be in a limelight for some days, no doubt. But what they'll be going through in the inner world is really mm, they're going to really struggle innerly, and that's why you see great, like people who are not so spiritual. So though they go to higher height, they remain alone. They remain alone. They don't have people to talk. They don't have people to share. They don't have people to anyone to trust, and that's why suicides. They get into depressions. That's a problem. So spirituality is one thing where we have to work out simultaneously when we are working itself, because that's where we can make the best use of the solutions from the spirituality, and we can use it. That same energy can be used for our daily life. Okay. That's where Arjuna was also a man who was actually doing his duty as a kshatriya, fighting for a kingdom, but he has used his spirituality, and taking the advice of the Lord or advice of the guru, mentors, counselors. So taking their advice, and he fought it. That's all. So never ever think that we are the only controllers and we can do anything. It's all this like all these quotes like you can win and you can do whatever you want. You are the temp. See, all these things they're good to say, they're good to hear, but they are not practical. Okay. So if you want to really come out, the spiritual says, yes, you have to fix your mind on the Lord and engage your intelligence on the Lord. So, see, just like Arjuna used his mind, intelligence, and at the simultaneously he started fighting and he came out victorious. So, worldly scriptures. I want to put that so that because we are children of the Lord, so we are all part and parcel of the Lord, and we are not. We are not our. This is not our place, and that's why everyone is recommending, and we are going to be temporary in this place. If they say we are going, we should go away to the place. We have to go to kingdom of God. If every scripture is saying that, though they are following in different places in different times, but message is one, means I am in a temporary world for some time. Okay. And we are not here to control this world. Okay. So understanding that this is a miserable. So I am the product of the Lord. Hey. So when a person dies, the body remains, but who is going there? A person who is following Islam or following Christianity or following Sanatan Dharma or Sikhism, whatever, everybody will die. But scriptures are saying that you have to go to kingdom. Then who is going to go kingdom of God? Or who is going to Jannat? Who is going to Vaikunta? So there is a living entity, there is a conscious being inside this body which will go back to kingdom of God. Okay. So this body, which is made up of earth, water, fire, ether, which is a material body. So because this world is material matter, so this matter will mix with this matter. One day, either you burn it or you put into a 6 feet hole, whatever it is. Ultimately, body is going to deteriorate here. Whatever you do, in whatever dharma you follow or whatever rules you follow, ultimately somebody is going from this body to there. Okay, who is that somebody? He's a soul. That's what we say at a soul. So Bhagavad Gita give enormous knowledge about this soul. Even we also, in the common sense, we can understand these things. Okay. So understanding the nature of the body and the nature of the soul. Lord has two energies. From Lord we get two energies. It is the 7th chapter, 4th and 5th slokas, 2 verses, 4th and 5th slokas. Lord says that the soul is a part of his superior energy. His superior energy. He has many energies, but they are broadly divided into 2 energies. Soul is a part of his superior energy, but this body and this world is part of his inferior energy. That means soul is something which is superior, coming from one of his energies, which does not have death, which is not going to die, and which we cannot see now, but we can feel it. Okay, but the body component, the mind, intelligence, all these components, as well as this material world, the entire the world we are seeing, this is his inferior energy, which is low energy, which is going to get deteriorated, which is going to die, or which is going to deteriorate. But the soul is not going to die. That's what all the scripture says. You are going back to kingdom of God. If I'm dying, who is going to kingdom of God then? Who is going? So there is a conscious being inside this body, using this body for certain desires, for certain impressions. So they wanted to do certain things. So the soul temporarily using this body, and this body deteriorates. Like once you had a child body, now you youth body, then later on you have going to have older body. Ultimately, you are going to die. Then the Lord says, then it goes to kingdom of God, or that depends upon what we have done in this world. I don't want to go into those details. So understanding it simply, like I am the driver of a car. So car also has 2 eyes, which is its headlights. Car also has horn, which is our mouth. Car also has radiator or engine, which is our heart. Okay, bodily heart. So, but there is a driver inside. So the driver inside us is the soul. Okay. Suppose, and take that we are going in a journey in a car. Ultimately, now what is going to happen is that car is running out of fuel. It needs to get fuel at some station. And I'm also hungry. Okay, I'm also hungry. I also need something to eat. Somehow I gone to a petrol station and I asked the boy to fill up petrol to the car, okay, because I'm going to I'm running out of fuel. So if I say to the boy who is actually filling the fuel, if I say, okay, you fill 10 liters to the car and fill 2 liters for me also because I'm also hungry. Okay, it looks absurd, no? Okay, so fill to the car 10 liters. To the car you fill 10 liters because I am also hungry. You please fill me 2 liters of petrol. So what will happen to me? And definitely I am going to die. Which means here we can understand that the car needs are different and the driver needs are different. For the car needs, for car to survive or to run, it requires a different material to eat. That is fuel. Me being a driver, I'm also hungry. I'm also running out of fuel, running out of food. But I need a different material, which is called as rice, wheat, okay, whatever, sambar, rasam, whatever. So fruits. So that will fill the driver. That is which is a different material from petrol, and petrol will actually fill the which will reduce the hunger of the car. Which means I want to say bodily needs are different and soul needs are different. Okay. So and right now I am engaged in a soul in a body, okay, which is have a totally different nature. And me being here have a different nature. So my needs are different from the bodily needs. That's why I'm saying why there was no stress release, there was no reducing stress. Even if you go, if you increase the gadgets, if you increase the facilities, comforts, they are good for the body, no doubt about that. But they are not the actual food for the soul. So if you are not giving the actual food for the soul, okay, and if you're only trying to serve the body through technology, and definitely one day we are going to be hungry, we are going to be frustrated, and we are going to lead a miserable lives. Okay, so coming to the last part, I think I'm out of time. Just 2 minutes. Please bear with me. So, so this is the entire thing. So you find a chariot here having 5 horses, which are 5 senses: eyes, nose, ears, tongue, and skin. And you have the ropes, the threads or ropes which are handling the horses, which is called as mind, and the driver called as intelligence, real driver. And there is a passenger who is soul, who is a passenger. So my eyes are compared to the horses, the mind is compared to the thread, so my intelligence is compared to the driver, and me as a driver inside me, the soul, the passenger inside this body. Okay. If if the senses are very strong, it eats whatever it wants, it sees whatever it wants, it takes out whatever it wants uncontrollably. And if the mind is weak, the threads are very weak. Holding the horse, those ropes are they're very weak. If they're very weak, and if a driver is weak, if he's not very strong, if a driver is not strong, how the journey is going to be? See, the horse are going to be ruthless. The mind, because the threads are not strong, the ropes are not strong, they are not strong. So, and because driver is weak, ultimately the journey, the soul is going to suffer like anything. The passenger is going to suffer. Okay. See, but if the senses are controlled, giving proper time when to eat, what to eat, how to eat, and if the mind is properly when their weak ropes are replaced with strong ropes, and if a driver is properly fed and if he is become a healthy and strong man, then the journey of the soul in the body is going to be safe. Okay. So then what to do? So what is the permanent and most important thing is for the entire life. If you are even if you are in the organization, if you are in a family, if you are in out of station, wherever you are, in which part of the world you are, this is the thing. This is the ultimate thing which we can do. Simultaneously, we can work on with our own goals, with our own what our targets and all. So engineering, yes, develops our comforts, facilities, and technology, but divineering. So divineering is a word which I have just the matter of just to just have a similar kind of term. Divineering is So having association with the Lord, or association with the books, association with whatever religion you follow, association with the devotees or with the people who are good people, who are selfless people. At least we should have at least 1 or 2% in our life, entire life. At least we should have 1 or 2 people who are genuinely, who are really concerned about us. We should have, if we are unable to get even 1% in our entire life who can trust me or who I can trust, and we are really, we can say that we are really a miserable people and we are really poor people. Next, books. Yeah, those books which will give information about ourselves, about the Lord, like Bhagavad Gita, Quran, Bible, or any self-help books which will help us our career. And most important, three is it's like A B C D. A is about association, B is books, C is prayers or chanting. So we have a set of prayers in every religion. So you can always early in the mornings, if you have good habit of prayers or meditation, chanting the holy names of the Lord, which we say the praise the Lord. So if you do that in the early hours, and definitely Lord is going to say work it out, and our mind is going to cooperate with us. Then diet is vegetarian diet as much as possible. If you are vegetarian, definitely it is going to work it out. And please have thorough visits to place of worships. Okay, either weekly ones or either in the festivals. The more you try to have such a kind of habit of going to temples or going to having prayers, and side by side taking your responsibilities of doing your jobs into organization, stress are going to get reduced. And researchers, you can Google anywhere you can Google, you will get this particular information that prayers are going to reduce your stress. Okay, because I being the product of the Lord, I being the product of the Lord, I being the product of the Lord. Okay, because my connection with the Lord, because I am the product of the Lord. That is why my connection with the Lord will help me to come out of many challenges. And this body is a product of this world. That's why it goes and sinks and finally mixes with the world. But I, being the product of the Lord, I have to have connection with the Lord. If I don't have connection with the Lord, if I don't have connection with the Supreme, and definitely I'm not going to have a very good, very healthy life. Okay. It could be relationships, it could be handling challenges, it could be anything or thing. It is going to have. That is why all the researchers among the world, if you can type anything, prayers help people from depression. Prayers help people from stress. People help from so many challenges. They can fight the challenges. You can see it. Okay. So finally concluding. So thank you very much for bearing with me for extra time. So mental stress rule 1 is dukkhalayam. Yes, you should understand the nature and rules of this world. Don't expect and don't lament. Okay. Physical stress rule is asashvatam. This is a temporary world, so where changes are constant. So we should be disciplined and balanced. You should know when to do and how much to do. Social stress rule number 3, ego principle. So you should deal with the people. So have a good speech and raise the character. And spiritual stress, last one, rule 4 is uncontrolled mind. We should control the mind by chanting the Lord's names. And we chant here Hare Krishna mantra. So we just chant Hare Krishna, Krishna Krishna, Hare Hare, Hare Ram, Ram Ram, Hare. So this, our day starts with chanting, and whatever we go everywhere, we do everywhere, and finally we are facing the challenges, and we're absolutely fine with the things. So anyone who wanted to go through and want to know much about the management of life and things, because this one topic is not going to end in one thing. So this Bhaktivedanta Prabhupada, so who has given this Bhagavad Gita as it is. So it is throughout the world. So and many lakhs and lakhs of people they have really have benefited from this. Please go through and really thank you very much. Thank you.
So, okay, sir.
Sorry, sir. I have taken some little time. Please.
No problem. Valuable information, sir.
Yes, sir.
Okay. Okay, sir. Very thankful you, sir.
Yes, sir.
Now, because this competitive world,
Yes, sir.
Global competition, all people are suffering with stress.
Yes,
In
sir.
their job pressure due to various things happening in their everybody's profession. As a faculty, as an engineering faculty, especially in private engineering colleges, present scenario,
Yes,
the
sir.
attitude of students and performance of students, we are also having a lot of pressure, stress in our life.
Yes, sir.
But it is our responsibility to educate the students in all aspects.
Yes, sir.
During our journey in every day in education
Yes, sir.
institutes, every faculty is playing so many roles
Yes, sir.
for benefit of the students. Like sometimes we are playing so many roles like listeners, directors, mentors,
Yes,
uh,
sir.
so many.
Ye-
So lot of patience is required for every faculty while
Yes, sir.
doing their
Yes.
profession as a this noble profession. In that
Yes, sir.
aspect, whatever the information given by you, sir, very happy.
Sir. Yes, sir.
Special thanks to you, sir, at the beginning of your uh, this presentation and ending of your presentation, how
Yes, sir.
one should prepare to listen the
Yes, sir.
lecture. And at the time of conclusion, you already given two beautiful examples. One is a car example, and another one is horse and
Yes, sir.
a relation between something like soul and eyes and intelligence.
Yes, sir.
Very beautiful examples given by you, sir. I
Yes,
hope
sir.
our participants would enjoy this session.
Yes, sir.
Very helpful to the participants, especially teaching faculty, to do their daily activities with stressless activities,
Yes, sir.
stress-free activities.
Yes, sir. Thank you.
So very thankful you, sir,
Yes, sir.
for your valuable information. And I request all the participants, tomorrow is the last day. Morning, we are having two sessions. One is by Dr. G.L. Samuel, sir. Sir will medical applications and other applications of robots. And one more session will be covered by Dr. V. Veerana, sir, about reconfiguration robo. And afternoon section, you people are ready to attend test as per AICT Atal norms. Okay, we will give clear instructions about the test. At what time between 2 to 3:30 we are going to conduct the test. Once again, thank you very much, sir. Bon Prakash, sir. And
Sir, if anyone wants to have, if anybody are already in this journey and if they wanted some help, please give my number to them,
definitely,
and I'm ready to help, and I'm able to help them in whatever way I can.
I can share your number and your details to all the participants.
Yes, sir.
Also,
I'm ready to help. I'm ready to help.
Yes, sir, principal garu.
Sir.
Principal garu.
sir, myself HOD, sir. Not
Yes, SOD garu, namaskaram andi.
Namaskaram.
ఇటువంటి టెస్టులు చాలా ఇంపార్టెంట్ అండి.
Sir, sir.
Faculties of engineering.
Voice is very low voice, sir. Please.
Yes. Hello, HOD garu. It's very good lesson, sir. Very good session. Very good session, sir. Very good session. Mash gariki namaskaram andi. Mash gariki namaskaram. Right,
Thank you, sir.
Right, sir.
Thank you.
Right, sir.
Thank you very much, sir.
Right, sir.
Yes, sir. Thank you, sir, Mr.
Okay, sir.
Thank you. Thank you for all of them, and then we'll meet again, sir. Thank you very much,
Definitely,
sir.
sir. Definitely.
Yes, sir. Sure.
Thank you, sir.
Thank you.
ఒక నిమిషం కూర్చోండి సార్ ఇది రాసేసారు